and OpenAI and Block of a ton of really important tech that we're going to be talking about today. And we were super excited to donate the conference as well and get all of this together to bring open source technology with the really key tendons and sinews that are connecting AI and models with apps and data and systems. And so I'm so excited to see how this event has grown, to see the LF take on the responsibility of nurturing this community. And there really is no better place for this technology to be. The Linux Foundation has turned so many key organizations into name brand technologies that we all rely on every day. And I think we're going to see the same thing happen with MCP and all of the technologies that come into the AAF. So with that, I am super excited to introduce Jim Zemlin, the Executive Director of the Linux Foundation and the Interim Director of the AIF. Come on up, Jim.
Good morning, and thanks, everyone. The Linux Foundation is excited to take the baton from Obot on this event. I want to thank Shannon and Sheng for putting together a great event up until now. And I want to thank all of you for coming today. We have now 2 times the number of attendees at this event than at the previous event. Amazon Web Services, Docker, Obot. I'm going to keep going here for a while, so just kind of buckle up. PwC, Workato, WorkOS. Thank you all. Let's give a round of applause for our diamond sponsors. I also want to thank our platinum sponsors, Anthropic, FME, Google Cloud, Manufact, Prefect, and RunLayer. So thank you all. One more round of applause for all of our wonderful sponsors. We have a huge lineup today, but we are just getting started on this MCP Dev Summit event. We are now announcing an event series. We are going to come to 7 new cities globally. So if you can't catch us in New York, or if you're from out of the country or out of town, we are going to be all over the world this year in Bangalore, Mumbai, Seoul, Shanghai, Tokyo, Toronto, Nairobi. And we're just getting started. The Agentic AI Foundation is not only going to host a huge variety of local MCP Dev Summits, but we are also announcing a couple of new marquee events, our AgentCon and MCPCon in 2 locations. We're going to be in Europe in September 17th and 18th, and in North America on October 22nd and 23rd. This event is going to be an event where it's not just about MCP, but a broad set of all of the different components, tools, protocols that you need to really be successful deploying agentic technology. So do not miss these events. For those of you who are 90s hip-hop fans, our October event will be featuring a theme of me, myself, and AI, and our evening event will feature De La Soul in the house for our evening party. One 90s hip-hop fan in this crowd? Come on, my daughter told me it was back in. All right, we're looking forward to all of that. With that, I want to introduce our first speaker. As some of you may know, I have been the interim executive director of the Agentic AI Foundation, but I also have a full-time job running the Linux Foundation, which is the home of Linux. It's also the home of the Cloud Native Computing Foundation and Kubernetes, which is the Linux of the cloud. And it's now home to the Agentic AI Foundation and MCP, which is the Linux of agents. And we're just going to keep going. Next year, it'll be a new Linux of something. Before I introduce our next speaker, I want to make a special announcement. I will be now retiring as the executive director of the Agentic AI Foundation. We have found a new executive director, Mazen Gilbert, who's actually here in the crowd right there. Say hi. Mazen will be taking the baton from me in this role. Mazen has all the ingredients to be a great leader for an organization like this. One, in AI, you have to have a PhD to be in any way credible. Mazen has a PhD, wrote his thesis on neural networks. But as all of you know, in agentic AI, you also need to understand a business, right? Agents are out there, not just technology, but technology that uses tools to run development of software, marketing teams, all kinds of different things. Mazen has an MBA from the Wharton School of Business here in the United States. And he just spent his last 5 years building AI solutions at Google. So I am looking forward to passing the baton to Mazen, who will be the new leader for the Agentic AI Foundation. Our first speaker is going to be the chair of the Agentic AI Foundation, Dave Nally. Dave Nally is the governing board chair of the Agentic AI Foundation, and he is the director of developer experience at Amazon Web Services. And he is going to come up and give us an update on what's going on with the Agentic AI Foundation. So come on up, Dave.
4 months. It's been a staggering 4 months. So much has happened. It's been a little crazy. If we look at the numbers, there are now 170 members. And by the way, had to edit these slides this morning because the number has changed in the last 48 hours. The 170 members now of the Agentic AI Foundation. And we're just barely at 4 months. Actually, we're not even at 4 months yet. And that is more than 2 times the number of members that CNCF had in their first 6 months. In February, we had the first big wave of a new announcement since the December launch. And there were 97 new members that showed up there. And again, it feels like every day I get a text from Jim saying, hey, we just signed up a new member. I can't go through and list. I won't do the slide roll that we did with the conference sponsors because, frankly, there's just so many. I would be up here forever, and you actually want to hear from other people other than me. But look at this list of new members. This is just the new members. And I want to say first, thank you to all of these members, both the folks who are on this slide and the folks who joined us in December. Joining the AIF is a vote of confidence that open source collaboration works. And we've seen this play out many times, from the Linux kernel to Kubernetes to big data technology that we all depend upon, like PyTorch and Spark. And now, of course, with technology like MCP that's changing the way the world thinks about agentic AI. This need for common infrastructure and common foundational technology that allows us to interoperate really easily, because if it's standalone, that's not very interesting. The ability to actually interact with both legacy technology as well as the cool new things that are being built is really important. These members are all working with us to build new things, both in code, working on hard technical problems in the working groups. And so I'm really excited that so many people are happy to come collaborate together. This is a place where we're getting a lot of interest, and there's a lot happening in the industry itself, but people are recognizing the need to come collaborate in open source. A lot of what we've been doing, though, for the past 4 months hasn't really been about code. The projects have been working on code, but the foundation itself has been working on governance, and a lot of the activity that you will have seen to date has been around that. And working together across these organizational boundaries means that we need a neutral governance structure And so there's a couple of bodies. I want to just briefly take you through that. We have the governing board, we have the technical steering committee, we have working groups, and then we have the projects themselves. And those folks have all been working together. The projects have obviously been shipping things, and they've had interesting things to show off. But the technical steering committee and the governing board have been working on technical charters for things like the working groups and for the technical steering committee itself, and maybe most importantly, the project lifecycle. And these are things that we have to do kind of as advanced work to make sure that the foundation can move as fast as the rest of Agentic AI is. And so I do want to call out, most of these folks here on the slide are here today. So members of the governing board and members of the technical steering committee, most of them are here. We actually got to spend some time together yesterday. Please look for these folks. I also will call out, look at the names here. Most of these folks are the experts. They are the people who are defining what the future of technology is, and we're really fortunate that we get to have them show up and participate in this process together with us. The technical steering committee has stood up 7 working groups already, and I'm really kind of surprised again at how fast that's grown. The working groups already have 500 participants. That's more than some projects will see in a lifetime, but the working groups are seeing a ton of uptake. And so these are the 7 working groups, the areas that they're working on, places where there is a big problem set, a substantial problem to be tackled, and that's probably larger than one project. And so these problems are things that are being worked on. Give you an example of the identity and trust space. They already have 150 members from 66 organizations. I'm not actually surprised about this because this is one of the biggest challenges we're facing right now is autonomous agents. Basically, they need to figure out how we're going to identify them, how we're going to separate them from the human that's putting them in place. But we're seeing a lot of activity come out of here. This is a great place to go participate, especially if you're not tied into one of the projects yet. But the most exciting thing coming out of the technical steering committee has been the project lifecycle. So it may not surprise you. I don't know. It's been a crazy 4 months. But the thing that is most requested of me is people want to come bring a project to the Agentic AI Foundation. And so in the last couple of weeks, the technical steering committee has created and approved a project lifecycle, which sets out the process by which projects are accepted into AAIF and how they live through their normal life. So those 3 stages are growth, impact, and emeritus. And we have that process defined on how they move from each. This allows us to, now that we have a lifecycle policy, we can accept new projects. This is the thing that I'm most excited to tell you about because this is the thing that people come to me and ask for repeatedly. Basically since the foundation launched, I've been getting calls and text messages and emails saying, we want to join, how can we get our project in? And there's now a really easily documented way that you can propose a project that'll end up going and being vetted by the technical steering committee and run through the process to determine what's accepted. I'm really excited about this. I think I mentioned we got to spend some time, the governing board got to spend some time with the technical steering committee yesterday, and we're really excited. We think this is going to move pretty quickly, so you'll see some growth here. But perhaps maybe more pointedly, I want you to get involved. It's great that there's this amazing technology, but open source works when people participate. So come participate to us. This QR code will take you into Discord, but there's a lot of places that you can participate. You can participate in the working groups, the projects themselves like MCP, Goose, and Agents.md, or you can submit a project. This has been an amazing 4 months, but we're just getting started, and I look forward to what we're going to accomplish. Come join us.
All right, I hope folks will join us. I want to just get a quick feel here for who's in the house. How many people here are building MCP servers? Look at that, a lot of you. How many of you are here sort of architecting a broader set of agentic solutions in your company, like really working on? Wow, so everyone's multitasking here. How many people here are contributing to any of the Agentic AI Foundation projects? All right, so quite a few of you. That's good. That's good. How many of you here are end users who want to give feedback on problems that you're having deploying agents and have the folks building that technology improve it? Be honest, all right? I see people like these wimpy little hands, all right? So that is what the Agentic AI Foundation is all about. If you're out there building MCP servers, if you are out there as an end user in an enterprise trying to figure out how to roll out agents in a safe, secure, reliable way, if you're building cool new technology, if you're an organization that has some technology to contribute, we are the place to do it. Please reach out to us. We're going to have lots of opportunities throughout the year to do that. But now I want to introduce the highlight of today's event, which is our main keynote speaker, the co-creator of MCP, someone who needs very, very little introduction. If you've got any suggestions on how to improve MCP, this is the person who you need to speak with, or just go straight to GitHub and start participating in the project. Please welcome David Soria Parra.
Okay, let me first make sure I don't show any of the Anthropic secrets. Hide all the models. Okay, great. We had enough leaks this recently, so we don't need any more. I'm David. I'm a member of technical staff at Anthropic, one of the co-creators of MCP. Thank you, everyone, for coming today. I'm talking a little bit about where have we been and where are we going with MCP. And to get you started, I just want to talk about some of the numbers, because I think they're actually quite impressive. We have now roughly, and that's really a number that's very hard to figure out, roughly 110 million plus SDK downloads every single month. And that's not just clients or server authors doing their thing. This is like agents SDKs from OpenAI, pulling us in as a dependency, Liang chain, Agentic AI, thousands of tools and frameworks that are like really defining what we're doing in the Agentic AI space, pulling us in as a dependency. All speaking MCP. And to put this a little bit into context, one of the most successful open source projects in the last decade, React, took roughly 3 years to reach that amount of downloads. MCP did this in 16 months. And I don't think this is there to brag, but it's to tell you really that there was an ecosystem that was really needing a standard to connect the tools and systems that you work with to AI systems. And what it means is that people came to adopt it because the alternative at the time was to build 16 times the same integration for a proprietary API, build your own platform, or build even your own chat system at the time. But besides the raw numbers, if you step back where we started in November 2024, which feels to me like ages ago, but it's not even 16 months, I want to show you what people actually built, because I think it's an interesting part. When we launched it in November 2024, we had a bunch of set reference servers for MCP, the most standard things you would imagine to fill in the gap that we felt was most needed. Postgres servers, SQLite servers, file system servers, Git servers, of course, memories, and the most basic things that now are built into every platform, such as search and fetch. And then, very quickly, really the key integration showed up. The SaaS companies like ClickHouse, Notion, Zapier, really connecting their tools or their systems with MCP to the ecosystem. And this is the part where I think MCP really grew up. When you start taking away from like a little like projects where like you have a fetch server, going to something like a Slack integration is a real big unlock to truly enable agents and at the time chat systems to interact with with the things you actually do care about on a day-to-day basis at work. And then, of course, because you all are very creative, way more creative than I could have ever been, things also got a little bit weird. We had some really interesting people doing fun stuff with connecting Blender up, connecting Ableton up. One of my more favorite things was people connecting MCP servers to 3D printers or synthesizers. And apparently, someone even built like a fantasy Premier League MCP server, so if you want to do that, that's also a thing. And I love that creativity that all of you have shown in not just doing the most obvious things like creating, a company-wide MCP server, but really taking it a little bit step further and using it as a creative outlet for some of the work you want to do. But then the most important part is something that I think very few people talk about. Because behind every corporate firewall, we're quietly wiring MCPs to systems of records and to the company data all day long. That's like your Salesforce CRM, your Jira tickets, internal wikis, Snowflake warehouses, or HR system. And it's actually, I think, one of the biggest deployment surfaces of MCP, and you never really see it or hear about it on Twitter or Hacker News. These are companies and people like you who build like internal MCP server to attach the AI systems to the actual businesses and really find a way for how we on a day-to-day basis really use agentic systems to get work done as knowledge workers. And I think it's to no surprise that even at Anthropic, some of these internal MCP servers that we have that connect to our knowledge base, that connect to Slack, these type of things are some of the by far most popular ones because they're the ones to really help you in your day-to-day work to get things done. And this is, I think, where MCP now lives today, is really in the corporate and enterprise environment. And of course, in order to enable all of this, we have gone through a lot of changes over the last 16 months. And I'm very lucky to have some of the brightest and most, some of the brightest minds in some of the biggest companies to help me with some of the decisions we're making around this. And so we have, of course, moved away from or not taken MCP from what was originally like a standard IO only, like a local server only, to really enable remote servers like earlier last year. We have done a lot of work around authorization, and we have helped people to really understand what are the security implications of deploying MCP servers. We have in addition added new types or new primitives to the specification to help people to build richer MCP servers, such as elicitations. We have added structured outputs, which sadly is still a little bit of a misunderstood concept that really enables things like code mode. And then most recently, we have taken a step into trying to find the right pattern for how to do long-running tasks, which is effectively agentic communication with a primitive called tasks. And in the same vein, we have, of course, done a lot of work on our governance structure, and we have most recently introduced something called SDK tiering, which helps all of you to better understand the kind of guarantees an SDK that we provide makes towards its stability, towards how closely it follows the specification, how much it gets updated. And last but not least, we most recently added this idea of, oopsie daisies. I was warned about this before, and then they, of course, okay, and I don't know if most recently we have added extensions which of course is a way for us experimenting with new features around MCP that really enables a more richer space that if in a core protocol was not possible. And one of the most fun things in that space that I'm sure you will see a lot about is MCP apps, which is this like ability for MCP servers to provide interactive UI patterns to an MCP client that can render them, and then with an agent or with a chat system interact with this. And this leads to some really, really cool demos, and I'm sure over the rest of the 2 days, you will see a lot of those really fun things. And then last but not least, by the end of last year, of course, and you just listened to 20 minutes of this before, we have donated MCP to the Agentic AI Foundation. And I think this is an important step for a project to really grow up and make sure that there's a neutral place so that all of you can be sure that this is not going to go anywhere and that this still will stay open, and that this will be something that as an industry, we're going to work together to move forward. So in my mind, today, MCP is the integration protocol. This is what you reach for when you want to enable agentic systems and when you want to, particularly in companies and enterprises, connect your systems of records, connect your internal systems to agentic systems. But, of course, not everything is perfect. There's been, of course, things we need to do as a community, as a protocol, as an ecosystem, and we still have a lot of work ahead. In my mind, 2025 was about figuring out if a thing like MCP is needed in the ecosystem. I think the answer is clearly a resounding yes. But 2026 is going to be about making sure that MCP is ready to be really helping people to productionize agentic system. Because while we maybe on Twitter and other aspects or other websites have the impression that everything is already fully agentic, the reality is in companies, this year is where we will really see agentic systems to make a big impact on how we as knowledge workers interact with AI. And so MCP will have a critical part in that. And so for us, it's important to make sure that as a protocol and as an ecosystem, we are ready to provide the right thing for people to do this in the best possible way. So what do we need to do? On the protocol side, we got a few things right, and I think in general, the protocol is in what I would say an okay state. I think there are things that we need to greatly improve, and there are things that work quite well. One of the main things that we need to get right, and one of the most focused areas within the MCP community at the moment, is the evolution of the transport. And you will hear more about this throughout the next 2 days. But it's been clear that while the current streamable HTTP transport protocol works okay for most use cases, it is challenging for particularly large hyperscalers, for large deployments, to deploy MCP servers efficiently due to its ways for how you need to effectively handle stateful sessions, or alternatively reduce the set of abilities that your MCP client or MCP servers can do significantly. And what we're trying to do with this new approach to transport is enable the full specification in a stateless way such that everyone can scale this in a most natural way how you would have always scaled your web services in the past. So this is a work that will land in the next 1 or 2 months and make it into the revision of the specification in June. And I really want to thank our friends at Google and Microsoft and a lot of other people to help us really shape this next iteration of the protocol. Second, Again, this year, I think people, last year people have built, honestly, quite simplistic MCP servers. I think this time around, we're going to see more and more usage of agents that want to get connected to like a platform like the Anthropic platform or an OpenAI platform. And we will see an increased need to deal with long-running tasks. And what we consider, and in the protocol have added recently, is this concept of task, which is nothing else, but if it's in the grand tradition of MCP, we are not great at naming because it's effectively just doing agentic communication, but we still call it tasks. I don't know why, but that's what we do. This will enable long-running autonomous work. And I think this is increasingly important because model capabilities are clearly increasing at a super fast rate. And so the ability for a model to do increasingly long tasks will just go and continue this year. And with that, we need to make sure that the protocol is ready, that you can take some of these long-running tasks and use them on MCP servers and run these long-running tasks there. We have an early experimental prototype of tasks in the protocol since November, but there's a lot of things that we need to still get right. And that's what we're going to work on in the next 2 months, also for this June specification release. And then last but not least, again, one of the big focuses of the current roadmap for the next 2 months is making MCP increasingly ready for enterprises. And while I think the current authentication specification or authorization specification is quite good, there's still a lot of things that we want to get right. And one of the most exciting things that you will hear later more about is this thing called cross-app access, which is really a nice way for seamless integration such that you connect to an MCP server and without having to go through an OAuth flow, because magically it will just talk to your identity provider and already get the right token it requires because you're, as a person at work, are already logged in. So this will enable in enterprise a much more seamless integration such that people don't have to worry about logging in anymore, and that honestly, MCP becomes less and less a thing that an average user has to engage with, but it just magically works. And that's where we want to get to the point where things like MCPs are a thing that just work and that a user does not have to think about. And then on the horizon, we have a few things that I think are really, really interesting. 2 things that are particularly interesting to me, 3 things that we're going to focus in general. Number 1 is triggers, which is nothing to say that basically we want to have webhooks in MCP. Which means that MCP servers should be able to tell our client that they have new data, that they want to have an interaction, and ask the client proactively to actually start engaging with the server again. And I think this unlocks a lot of use cases around productivity that I think will enable a new way of how we build MCP servers and new interactions that I think are more richer for users. And so I'm really excited about that kind of work. Second, of course, this is a long-standing issue that MCP has no native streaming support, and this was very deliberate in the early days because streaming is hard, streaming is difficult to do, and streaming adds a lot of complexity. But now I think it's really the time for us to look at streaming again and making sure that you can get incremental tool results. And then last but not least, we do want to serve, and I think this will land as an extension in the next few weeks, we do want to finally serve skills over MCP servers, so that you can bundle up domain-specific knowledge with an MCP server and tell the user and tell the agentic system on the other side how to best use your MCP server. And I think this will unlock particularly good use cases for large MCP servers that really want to make sure to explain how to use certain subpaths of the MCP of their server. So I'm really, really excited about that part, and I think it's going to be a very interesting way to serve skills in a more centralized way. Okay, so that's the protocol side. That's us doing our work, and just a bit of a brief overview. But I think there's a thing that we still need to do in the ecosystem that is quite important. Number 1, what we're going to do is, I think, some of the SDK shapes, and I can hold my hand up here for being part of the problem that I've created the Python SDK, is that some of the shapes there are not great, and I think we need to greatly improve the ergonomics and the usage of these SDKs. And so we're going to ship a Python SDK v2 and we're going to ship a TypeScript SDK v2 in the next few months that really make a more better approach and a more ergonomic approach to how to build MCP clients and how to build MCP servers and get rid of a lot of the cruft that has been accumulated over time. And of course, we're making sure that if you point Claude or another model at your old code base, that it will be smoothly translating this to the new code base, hopefully without hitches. Second, and that's less what we need to do, but what we as an ecosystem really need to do, we need to go and build better clients. If there's one thing that I'm really worried about and really, maybe complaining about in the ecosystem, it's the current state of clients. And this is, I think, the root cause of a lot of the criticism MCP is currently getting. One part is, for example, that people complain continuously about context bloat in MCP. And I'm sure, unless you live under a rock, you must have heard that people are blaming MCP for context bloat. But the interesting part is that we already know the mechanisms for how to go around context bloat. This is called progressive discovery. And the idea behind progressive discovery is to not take all the 20, 50, 100 MCP tools you get from an MCP server and just naively dump them into the context window, but use a more modern mechanism such as tool search to only load the tools when they're needed. And these are things that, this is very similar in its general idea for how things like skills work, of like loading things only when they're needed. And there are many ways to implement this. Platforms like OpenAI and Anthropic offer these as features, but it's also you're also able to implement that yourself. And in this example here, you see on the left side how Claude Code used to load MCP tools before it implemented tool search, and you have like 22% of about a 200K token window taken up by MCP tools, and then on the right side, all of this is now deferred in the current implementation of Claude Code, where it loads them only when needed. Second, people love to use really compose or love one ability, for example, from CLIs, which is this composability through bash commands. You can take a CLI command, you can pipe it to another one, and people often say, oh, I can't do this with MCP. But of course you can. And I think this is a mechanism we have not seen much explored yet, and I want to see the ecosystem explore more, which is composability through code. And the idea is pretty simple. If you give your MCP client basically an interpreter and ask the model to write code, and that code then calls MCP, then you get composability. And this is where structured output comes in, because structured output allows the model to reason about the return types. And so I want to see more of this, because I think in experimentation, we know that this is an exciting thing where you can greatly optimize maybe latencies and get to more richer expressiveness in how your client can interact with MCP calls. And in this example on the slide, you see how you can connect them together and then emit finally, without ever going back to inference, more complex objects. Okay. So that's the protocol work that we need to do. That's the ecosystem work we need to do. But last but not least, we need you as a community. One of the coolest parts about this journey, and it's like honestly still mind-boggling for me that I'm standing in front of 200, 300, 400 people after a year of done my little specification. But what's the most important is your feedback. You see things on a day-to-day basis in environments that I might not know, that we as the core maintainers and the maintainers of the MCP do not know, and we need to hear from you. We need to hear from you what are the things you're excited about. I want to hear from you. Are you excited about skills in MCP? Are you excited about triggers in MCP? And quite frankly, also about your criticism, because criticism is one of the things that gets us going and improve our things. Things like the new transport specification came out of people coming with very real concerns and basically telling us that we got parts of it wrong. And the best part is that hopefully we're still humble enough to say, okay, we got it wrong, let's go and fucking fix it together. Cool. So With that, thank you everyone for being here. I'm super excited for the remaining talks about the different areas how people are building MCPs, how people are using MCPs, and part of how we are developing the specification. I'm going to be around most of the day, so try to find me if you have questions or anything like that. Thank you so much.
Thanks, David. So you heard from David. There are, I'm sure, a bunch of core MCP maintainers around this week. By the way, you're not in front of 400 people, David. You're in front of 1,200 people, just for the record. But now we're going to get into some additional really, really fun stuff. From here on out, we're going to hear from the people who are building things with MCP and who are going to share best practices, share their wisdom with all of you so that you can all get better at building the systems that you all are working on as well. We're going to start up with a principal software engineer from Amazon Web Services, James Hood. James is helping drive MCP adoption throughout Amazon, and you are going to hear from him how Amazon is using MCP at scale. Please welcome James.
Hey there. My name's James Hood. I'm really excited to be here with you all today to talk about MCP at Amazon scale. A little bit about me. I'm a senior principal engineer. I've been with Amazon for 16 years, working in both AWS and stores. And I have to raise my hand and admit that I am a former AI skeptic. Prior to 2025, I had a lot of frustrating experiences where AI did not live up to the hype when I would try to put it to work on real work, my daily work. However, this changed for me in early 2025. There's the combination of technology advances like reasoning models, and agentic chat, and then of course MCP as well. And then for me personally, a big aha moment was when I realized that the techniques, the ways that you prompt these LLMs makes a big difference in terms of your success or failure with them. Personally, my kind of breakthrough moment was when I implemented a major feature in a code base I did not own, in a language that I didn't know at the time. And I went from concept to pull request in 2 days, and then it went to production 5 days later. And this was, especially in early 2025, this was a very mind-blowing experience for me. And I suddenly felt this tremendous sense of urgency to shout from the rooftops internally in Amazon and say, hey, if you're a skeptic like I was, you need to take a look again. I started an internal community and to spread awareness, explore this technology, and to pioneer these techniques. And let me tell you, the Amazon Builder community, much like this community, responded in a big way. I can't share exact numbers, but there are tens of thousands of members in this channel actively innovating and honestly making my original success story look quaint at this point. And this ultimately led me to transition to the internal Builder Tools team to make accelerating Amazon's AI transformation my full-time job. But I continue to maintain this community, and as you all are a testament, and to what we've heard earlier, community is so critical in this area of AI. So at this point, my customer now is Amazon. So Amazon has interesting challenges. Of course, we have scale. We have tens of thousands of builders. But AI is challenging us to think beyond our traditional notion of a builder. And really, everyone at the company should be able to be a builder of some kind. And that's challenging us to rethink some of our tooling. We also have challenges like an internal tool chain that diverges from open source norms, largely for historical reasons. And so foundation models are not necessarily trained or know about our internal systems or tools. Finally, we have security and compliance requirements. We are a large company, and we have security and compliance requirements on a scale that many companies don't face. However, on top of all this, at Amazon, we pride ourselves on having a highly decentralized culture. We believe that enabling small teams to move very, very quickly with high autonomy allows them to get the best results for their customers. So there's a constant interesting tension between trying to empower these small teams while maintaining our high standards. Now, as we've alluded to earlier, as you've heard a little bit earlier, it seems like every month now there's kind of a flurry of social media posts or articles proclaiming the death of MCP. I can tell you at Amazon that is not true. MCP is still the most popular way to connect agents to our internal systems and services. And externally, we're continuing to invest in MCP. My colleague, Senior Principal Claire Ligori, is a core maintainer of the MCP project, and we've made contributions, for example, contributing the implementation of MCP elicitation to the Java and Python SDKs. We contributed to that structured outputs that you heard about earlier, the Java, Python, and TypeScript SDK implementations, and we contributed that tasks primitive to the spec as well. Internally, we've invested in ecosystem and community and enabling builder innovation. As a centralized builder tools team, we believe that the best way for us to contribute is to enable the broader ecosystem within Amazon. So last year, we created an MCP registry to make it very easy for builders to discover, share, and local and remote MCP servers with one another. However, the agentic landscape has continued to evolve. And while MCP tools are still heavily used, it's not the only primitive anymore. There are new primitives such as skills or context and steering files and agent SOPs. Skills in particular was a source of people proclaiming MCP is dead, for example. But at Amazon, an important insight that we had was rather than thinking of this as an either-or conversation, all of these primitives are actually kind of ingredients, or we think of them as ingredients that can be combined into an agent configuration. So we expanded our internal registry to store AI capabilities and made agent configurations into a first-class primitive. Now teams can actively create and share these agent configurations with one another, and we make it very easy for them to install these configurations to use with their personal agents. And we've seen massive growth, and this has been very, very popular internally. And having this central registry of agent configurations unlocks some very important benefits. For example, in security, you may be familiar with Simon Willison's work, and he has a blog post talking about what he calls the lethal trifecta of AI agents, where if you give agents access to private data, exposure to untrusted content, and the ability to communicate externally, it can present a data exfiltration risk where the untrusted content could contain prompt injection attacks, that kind of thing. So since we have MCP servers registered in our registry, we're working with our security teams to categorize these MCP tools in terms of those lethal trifecta properties. Then, even more importantly, since we also have these agent configurations in the registry, we can see how these tools are combined together into different agent configurations. And we can scan these configurations to flag potentially problematic agents and take appropriate actions to mitigate those risks. So as you can see, MCP is not dead. It's the foundation of this kind of work. And one more thing I wanted to talk about, this was also alluded to before, one of the biggest complaints around MCP, as it's used today in agents, is the context window or context bloat. For local MCP servers, we are experimenting. So internally, we're trying to experiment to help inform kind of external feedback back to the standard. And internally, we're inspired by the progressive disclosure of skills, as well as some of the techniques around wrapping MCP tools and CLI commands, for example. And having this centralized agent configuration registry layer allows us to do some cool things, like, for example, a vendor in their agent configuration can specify, for this MCP server, these tools should be injected directly into context, and these tools should be surfaced as a CLI with just a little bit of context to let the agent know that that CLI is available, and it can explore it if it would like. And the vendor can make that simple configuration change, and then on install, we can set up the configuration automatically to save a lot of tokens and essentially have better agent performance and lower inference costs. So hopefully some takeaways from this is that no, MCP is not dead. In fact, it's a central part of our AI strategy at Amazon. And rather than thinking of MCP and skills as either or mutually exclusive decisions, we've really leaned heavily into agent configurations that bundle these various AI capabilities as a key primitive. And finally, context window size is not an inherent problem with the MCP protocol itself, but rather how it's currently used by MCP clients or agents, and that these are very solvable problems. All right, if you'd like to come chat with me more about any of these topics, I will be at the AWS booth from 11:30 to 12:30 today. We also have a rooftop reception happening tonight. You're all invited. You can scan this QR code and RSVP. Thanks so much for your time, and hope to see you there.
Thank you. All right, we're going to hear from more builders. Our next speakers are Meghana Sumasandra and Rush Tarini. They are working on agentic solutions at Uber. Meghana is the Agentic AI lead at Uber, and Rush is the head of engineering for Uber's Agentic AI platform. And we're going to hear from them today about how Uber is using agents to help us get around better. Come on up.
Great. Good morning, everyone. It's great to be here. I'm Meghana, and this is Rush. We lead the Agentic AI platform and initiatives at Uber. Today, we are going to be sharing our journey of moving MCPs from a promising protocol to operating this at massive scale across thousands of engineers, services, and agents. And we're also going to cover some of our challenges, similar to what James was mentioning, actually, what some of our solutions were, what are some of the lessons we learned along the way, and a quick look at what we are planning for the near future. OK, let's get started by grounding this in scale. At Uber, we have more than 5,000 engineers, with more than 90% of them using AI every single month for agentic workflows. And this does not yet include all of the non-engineering folks, thousands of them, who are also now trying agentic workflows. So this is no longer a pilot program at Uber. It's the new standard for how we work. The reality is of a company this big is really that we have more than 10,000 services. Our knowledge is spread across this very complex landscape. Without MCPs, every agent has to rediscover how to interact with each service. And on top of this, we are now seeing more than 1,500 agents just internally, monthly active, and over 60,000 executions per week. And this is very high demand, as you can see, very high velocity. But without standardization, this starts becoming chaotic very quickly. And so MCPs are not just like important. They really are what make AI usable at Uber. And at this scale, the standard MCP challenges become a lot more amplified. The first class of problems that we saw was around the development lifecycle. Without a central framework or guidance, there was no standard way to develop and deploy these MCP servers at Uber. So we had a lot of teams building out these custom integrations independently, and most of this was non-reusable. We also had everybody trying to figure out how to solve the very same problems in silos of their own. The simple truth was, if you can't manage the development lifecycle, you just can't trust it in production. And at Uber, security is non-negotiable. But with these many bespoke ways of doing things, governance started becoming a very immediate concern for us. We needed complete visibility into the call patterns and who was accessing what data. And in reality, it takes us humans a lot more effort to break things. But with agents, as you know, it's a lot faster, it's a lot quicker, and the blast radius is a lot higher. So we had to make sure that there was no unauthorized access to any data or any of our critical endpoints and services, even unknowingly. We also had to account for any risks that we would have with some of the third-party MCPs around data handling, because Uber does use a lot of external systems. Now, the last class of problems that we saw was around discovery and quality. How does an agent or even an engineer find the right MCP? And not just any MCP, something that is reliable, has high performance, and is safe. Bad tools just don't fail. They also degrade the agent performance at the end of the day. Our solution was we built MCP Gateway and Registry. Think of this as the control plane for all MCP interactions at Uber. With this, we moved to a config-driven approach. We now translate all Uber service endpoints into MCP tools automatically. Service owners, which are basically the experts, still stay in control of which tools actually get exposed. And they also fine-tune the descriptions for the LLMs. This removes a lot of duplication and also enforces consistency for us across the board. And the other thing we also did is we followed a different strategy for how we treat and enable third-party MCPs versus our in-house MCPs. We introduced a lot more levels of gating, scanning, and rigorous checks for the external systems compared to our own trusted internal systems. We also deprecated all one-off standard playground environments that people started spawning off, and everything is now centrally committed and managed in code. We also introduced a central registry. This is the single source of truth to discover all the MCPs at Uber and their versions. And we did all of this with security and privacy built in every single layer. We integrated into our authorization service centrally, so there was no access to any data that is actually not supposed to be there. The other thing we also did is we integrated with our PII redactor service, and this automatically redacted any of our sensitive data too. We also do periodic code scanning, both at diff commit time as well as in our code periodically to make sure that we are detecting any bad patterns, any endpoint exposures unknowingly, or any of the risky tool metadata. We also have full observability and guardrails, both to block any mutable endpoints that can bring down critical services for us, but also to have extensive logging and metrics and tracing for all the operations. And let's take a quick look at what this gateway architecture looks like. There are two critical components to this gateway. The first one is the orchestrator, which is responsible for generating the MCP definitions from the 10,000 plus service IDLs at Uber. And then we have the gateway service, which serves these MCP servers and also allows the service owners to update the MCP definitions. Let's quickly walk through what this how this actually works. The gateway orchestrator crawls all of these IDLs, which are proto and thrift files. Then it calls an LLM to generate MCP tool descriptions. This is based on the message names and comments, and then it stores this in our object storage. The gateway service then has a config provider that's going to pick up these definitions and serves these MCP servers to the different consumers we have at Uber, whether it's a no-code agent platform or SDKs or coding agents. And as I mentioned earlier, service owners can update all of these definitions, which then triggers creating a diff, which is basically a pull request. And the diff is then scanned by our engineering security's unified scanning APIs. And if there are no issues, everything is good, then the scan report is attached to the diff, and the diff is committed and deployed to our object storage. And this is then again available to be picked up by the gateway service, which exposes it to the consumers. Now, I'm going to hand it off to Rush to talk more about how we use MCPs and consumption in more detail.
Thanks, Meghna. So let's talk about how our MCP is used at Uber. There's actually 3 main surfaces at Uber that use MCPs. One is our Uber Agent Builder, which is a no-code solution for building agents at Uber. These agents are usually internal agents, and they're used for productivity, for team workflow automation, and so on. There is thousands of these that are active on a monthly basis at Uber right now, and they're growing very rapidly across the board. The next surface is our Uber Agent SDK. Uber Agent SDK, along with all the Uber Agent platform functionality like managed memory, managed chat history, orchestration, is our code-first solution for building agents at Uber. Some of our top use cases use this SDK. Those top use cases include our grocery assistant agent, our care coordination agent, as well as our customer support agent. If you interact with our customer support, you'll see this in action. And then finally, we have our coding agents. The coding agents, as you know, they're cloud code, they're cursor, they're companions to our developers to build software at Uber. And on top of that, we have Minions, which is our background agent that's built on cloud as well, the cloud harness as well. And it's actually producing about 1,800 code changes a week right now. And it is being used by, all of these are being used by 95% of our engineers across Uber. Okay, so let's dive into a bit more details about how these are actually incorporated to each one of these surfaces. The MCPs are incorporated in here. I'll start with the Agent Builder. So for Agent Builder, if you want to use an MCP, you can mention the MCP server name as an @ mention inside the system instructions. So you can actually scope the MCP within system instructions. For example, if I want to search for something, I can say, if a user asks for this, use the @MCP server for usesearch, which is our internal search tool, to return information. Now, as all of you know, and it's been brought up in previous presentations, these things can hallucinate and maybe not pick the right tool. So what we've done is we actually allow you to pick the specific tools from the MCP server so that the LLM doesn't have to make a decision there. This makes the agent more reliable. And then to further make it more reliable, we have the capability to do parameter overrides. So what that means is the LLM doesn't have to make a decision even to pass in a parameter anymore. We can scope the parameter to something static instead. Again, this is through no-code UI, so just making it easier for these users to do this is highly important. And again, makes the agent more reliable. Okay, so talking about, so that was Uber Agent Builder and how it's used. In Uber Agent SDK, it's somewhat similar. We have a config YAML, a YAML config file that we use there, and you can put in the MCP name and the identifier field, and then you can also select the tools that you want, or pick the tools you want and put that in the config. And on top of that, you can also override parameters in the same way. You put all of this in the configuration, the SDK automatically loads these tools and makes it available to the agent with those specific configurations. On the coding agent side, we have our AIFX CLI tool. Basically, what AIFX lets you do is to add your MCP by running the MCP add command. And then this MCP server, whether it's remote or local, is available to both Cloud Code as well as Cursor or any other IDE-based agent that we have available at Uber. Okay, so that's what we've done so far and how we're using MCPs. I want to talk about our roadmap and how we're essentially focused in the near future on improving the quality of these MCP servers and then simplifying discovery. We want to extend our MCP registry to include more evaluation information. We want to surface the highest quality MCP servers to our users. So by exposing the evaluation metrics, by including the SLAs, service SLAs for these MCPs. This includes reliability and availability of the service. That's how we surface this is the right MCP. This is a higher tier or lower tier MCP that you can use. That's most reliable. We also we are working on adding a tool search tool that was actually mentioned earlier. Again, that helps us with improve the accuracy of tool discovery by making it so that it's discovered automatically and it's also loaded on demand. That also helps us with context bloat, reduces context bloat as well. So that's, again, something we are focused on introducing to our registry and our MCP tools as kind of an omni MCP tool. And then obviously evaluations is something we're building into the registry, and our overall agent platform has evaluations built for agents as well. The other thing, as everybody knows about, is skills, right? The skills are becoming more and more important. At Uber, you can think of them as recipes for using these MCPs. So we want to make them shareable, not just across Uber, but across different teams at Uber. We want to be able to have processes that can be shared and conventions that can be shared across Uber through these skills. And then we want to introduce evaluations to these skills. That means we want to be able to evaluate the output quality. We want to be able to evaluate the correctness of skill invocation. And we want to be able to A/B test these skills. So if I have a different version of the same skill, which one performs better? So we want to have those informations. So that's a bit about where we are today and where we're going to go in the near future. If you want to connect with us, please connect with us at this event. And if we don't get a chance to meet here, please connect with us on LinkedIn. Thank you.
Thank you. All right, our next speaker is somebody I love talking with and was one of the founders of this event. Sheng Liang is the CEO of Obot. Obot is a startup that is rapidly growing and helping with enterprise adoption of MCP. Over the last year, Obot has built gateways, registries, chat clients, workflows, all powering MCP in real enterprise environments. Today, Sheng's going to break down how that's been working and share some stories about where MCP is headed. Next, please welcome Sheng.
Thank you. Good morning. Hear me okay? Yeah. So I'm so excited to be here because it was just about this time last year, Shannon and David initially had the idea of having an MCP summit, Dev Summit. And it took them like a little bit over a month. So the summit really didn't happen until late May. So we're just over 10 months from the first summit. And the first summit was really cool. It was small. It was like 200 people. One track, I know some of you were there, and one day, and just look at how much this community has grown. It's so exciting. So it's also great to be following Amazon and Uber, the giants of our industry, and it's great to see they're adopting MCP. And as a startup, we help the rest of the enterprise and the startup ecosystem. So some of our customers are financial institutions or reasonably sized companies, but many of folks we work with, they're literally just getting started in the AI and MCP and agent journey as well. So in many cases, MCP they've seen is actually the first entry into their AI and agent journey. So I just have to thank the two engineers from Uber because they said exactly what I wanted to say. Because, I mean, honestly, for those of you who are just starting, you're in a business, you're just starting to look at MCP or agents, those are the two pieces of technology you got to think about. an MCP gateway and an MCP registry, which is exactly what Uber did. And that's how you get yourself started. And the reason you want to get these things started is because they give the admin, or if you're an enterprise, an IT, a point of control. So you know what's going on. Otherwise, you really don't know what's happening in all these MCP clients and hosts that spreads all over your organization anymore. So, and this show, if you go out, talk to sponsors in the exhibit hall, I would say maybe a third, maybe even half of the vendors will be providing solutions that look kind of just like this, a variation of this. So there's plenty of choices. Definitely, Obot makes one, but we're certainly not the only one. There are many registries and gateways in there. You don't have to build from scratch anymore. And they provide the obvious kind of functionalities that you would expect. And I want to talk about, for the rest of for the next 5 minutes, I just want to talk about where this thing is going. Because we built this literally maybe 6 months ago. We started marketing this and selling this. And the world has already changed. And a lot of it is caused by the change in the agent development framework itself. So as you know, like MCPs, for whatever it is, it fundamentally needs to serve agents. That's what people need MCPs for. And the way you build agents has changed quite a lot. A couple years ago, agents were like a RAG chatbot. That was an agent, right? And then we saw, I think these days we see a lot of workflow agents. And workflows you can certainly write with workflow tools, with NNN, Temporal. There's many workflow tools on the market today, very powerful. And there's also coding tools, code tools. Not coding tools. I think people realize. I think I read somewhere in one of the MCP summits, someone said, "Oh, agent is basically just a code loop." Makes a lot of sense. Some Python code that repeatedly loops around and tries to achieve a goal. But nowadays, with code generation, with coding assistance, and with MCP, none of this stuff is even necessary anymore. The agents I see people develop today, I see our customers develop today, they kind of look like skills. They look like skills, some markdown files and code that's generated by some code generator. And on top of that, what used to be the SDK and framework, now it kind of seems to be taken over by things like MCP layer. But of course, it's more than just the MCP. It could be the CLI, could be the Agentic browser, could be a skills library, and could be many other things. So we're definitely seeing, again, that's a word I saw from the Uber folks. Like just the word runtime, it started to happen. Now, instead of calling these things as just an SDK and framework, it has these entities that's running. And it really doesn't matter how you access them. Many of these things like MCP have standard protocols, so they can be accessed by whatever agent you develop. And then underneath the runtime, what we're seeing is security and governance layers started to form out of technologies like the MCP gateway. But that's not the only control point either, because for some of the access control and governance, you also need to know, frankly, what the model is doing. So the gateway doesn't necessarily see everything that's sent to the model. So the LLM, having some visibility into the LLM gateway, direct things that's sent, that's kind of useful too. Secrets management. Recently there's been quite a few incidents where the software supply chain was attacked by some well-known libraries, and it would be extremely bad if those compromised software gets into your, say, MCP or gets into your skills library. So software supply chain filtering is now also becoming a key part of the gateway layer. And with that, the security and governance of enterprise agents are achieving a great deal of attention. And you got to deal with those two areas. You need both a secure, isolated runtime, which means, for most of the enterprise customers we talk to, it is not really desirable to run the enterprise-grade agents on the desktop. Like, engineers run Claude Code, which is great, but if it's a agent developed by the third party, you don't want to let it take over the whole desktop. Then on top of that, you want to make sure you want to know who the agent is running on behalf of, and then you probably don't, even the agent is running on behalf of you, and then that has access, say, to your Outlook account. You want to make sure it cannot really access the Outlook account the same way you can get access to. Like, it cannot just send emails like the way you can. You probably still want another level of access control to make sure the sensitive emails, you approve those emails before they get sent. With these kind of architecture, there's some interesting opportunities are beginning to rise, because these agents are written a little bit differently from traditional monolithic SaaS applications. Like a Salesforce app does all the access control for itself. Like if you're a sales VP, you see all your deals. You're a sales director, you see the deals in your territory. If you're account executive, you see your own deal. So they have all of that. But nowadays, with agents, the surface area that data needs to get accessed by AI nowadays is a lot wider. So as a result of that, we're seeing the access control and policy layer getting elevated out of the application layer, out of the agent layer, and now into the gateway layer. So that's a great place that something like MCP Gateway could come into play. So with all of that, we're seeing the MCP Gateway and MCP registry architecture that I saw in the beginning evolving. So like if you kind of look at our latest product, we've gone far beyond what a MCP gateway and a traditional MCP gateway and MCP registry can do. The agent runtime layer is becoming quite important, and the gateway itself, nowadays involves things that we do to the skills, to the software supply chain. And from the catalog, you don't just see MCP registry anymore. You see things like skills. So with that, I'd just like to wrap up. If you need more information, please feel free to drop by our booth. I'll be at the booth most of the time. And also send me an email. Thank you very much.
Sheng. All right. How many people are learning something new about MCP that you're going to be able to take back and use? A few of you? All right, this is what I like to see. And we're getting to even more. Our next speaker is from an organization whose application I use, Duolingo. いつも日本語一生懸命 Duolingo を使って勉強しています。For any of you who speak Japanese in the room, test me out. Is it working? Is it working? Duolingo is using MCP and has built an AI Slack bot. Aaron Wang, a software engineer from Duolingo, is going to come up here and tell us all about it. Welcome, Aaron.
All right. Good morning, everyone. My name is Aaron, a software engineer from Duolingo. And today, we'll share how we build a AI Slack app using MCP and the journey on how we got there. So our journey started back in November 2024 when David introduced from Anthropic to introduce MCP. So when it first introduced, a couple of our engineers got excited and so immediately saw the potential and started connecting various MCP servers to their local editors. However, the setup was very painful. For each individual server, you have to do your own research to find the GitHub repo, figure out the correct config for it, get the necessary credentials, and manually create your MCP.json file. The barrier to entry is very high that very few engineers bothered. So we knew this wouldn't scale, and we need to lower the friction. In May 2025, we tried to fix the discovery problem by creating a centralized web page with instructions on how to set up various MCP servers. And here's a screenshot on what the setup page looks like. It's basically an app store where you can shop for different MCP servers we support in-house. And you just need to follow the instructions, select the MCP you want to set up for, follow instructions to get the credentials, and hit the generate config. And we'll show you a screenshot like the one on the right, where you have the MCP.json file. You can just click copy and put into Cursor, Cloud Code, whatever AI editor you use. But we still have one problem, the MCP servers themselves. Every single MCP server was built and run differently. Some are written in Python, some are served in like UVX, or while others like maybe written in TypeScript and served as a Docker image. So this causes problems for different people because they often run into like dependency issues or Docker issues. And in those days, we got lots of reports where like we tested all the MCP servers on our machine, but when we try to roll out to different people, they kind of report like, hey, it doesn't work on my machine because I have different NPX version, or Docker just has issues, as they always do. That's when, in August 2025, we started MCP standardization effort within the company. So here is our standardization strategy. For external first-party MCP servers like GitHub or Atlassian, we allow people to connect them directly to their first-party servers directly from their AI editors like Cursor or Cloud Code. For the open source ones, we try to fork them in-house and added some like authentication. We have like internal ways to do authentication, so we added those to the MCP servers. We added the tracking so we know who's using them and how they use it. We host it internally behind our VPC via HTTP. One thing to note here is that for some of the external open source services where people share similar credentials like Grafana or Jenkins, we try to simplify the config for people where we use a shared service token on the internal server side. So people just like use an internal Jupyter token to do the auth to them, and they don't have to do all auths in Cursor or Cloud Code once in a while. Whereas for some of the MCP servers that different people have different access, like Google or Slack, we have to run the internal servers via OAuth also. And in addition to the public services, we also have a bunch of internal service where we try to get information on like how is the Duolingo latest app release, or what people are saying about Duolingo on Reddit and things like that. And to integrate those company information, we created an internal Python library built on top of FastMCP, where people from different teams can easily convert their services to an MCP server, and we also host those internally via HTTP. And also for the external context where we can control the permission at the IAM level, like AWS or BigQuery, we do not use MCPs for those, so we just allow people to use AI tools to code their CLI directly. And lastly, for things where people have to run locally, like Playwright or Simulator, we support them via, we still support those MCP tools that people can run locally via stdio. As of today, we have like around 30 MCP servers supported at Duolingo with 300 plus tools, and half of those are served internally with a very standardized HTTP configuration. You basically put your Jupyter token in the header, and you just set the URL to be the MCP name, internal.duolingo.com. And to use different MCP servers, you just replace the name. So we thought this setup is simple enough for people, but even with this, we still do not see a lot of adoptions inside the company. So even like a single click to copy this to your local config is still too much for people. So we thought in September 2025, if people do not configure MCP servers themselves, we can try to bring MCPs to them. And this is when we start to introduce the Duolingo AI Slack app. The Slack app is built on two main components: the Cloud Agent SDK, where the AI talks to different MCP servers, as well as the Slack bot SDK, where it's doing the messaging with the Slack threads. So it's basically Agent SDK connect to a bunch of read-only tools from 15 plus MCP servers, and it also has the ability to run AWS or BigQuery commands to diagnose different things or get metrics internally. A few key features of the Slack app we built: it can auto-respond in help desk channels as well as instant channels that we have. So this significantly helped to reduce toil for on-call engineers. For write operations, like creating pull requests or creating Jira tickets, we offer a way to do human-in-the-loop verification, so the AI agent doesn't just go crazy and destroy the whole code base or whatever. We also have a general system prompt where we teach the AI on how to get internal information from different places. That also helps to make sure the AI does not hallucinate and write essays on Slack. We also support per channel. Different Slack channels can have their own customization to satisfy the needs of different individual teams. And it also supports cloud skills and sub-agents to improve the Slack bot's response quality. And we have a feedback button, like as shown on the in the screen, where we collect feedback from people over time, so we know how the bot is doing across different channels, across different use cases, and across the whole company. And we also have a set of EVA tests, making sure the Slack app does not regress over time as we introduce new features or update models. So we know for those like 20 sets of EVA tests, it always returns the correct answer, no matter how we update. And for lots of the downvoted answers we got, we gradually add those to the EVA sets to make sure things are improving over time. And the first question after we launched the Slack app, we got was around security and privacy. So here is our approach to it. So our principle behind security and privacy is that we want to make sure the bot is not a way for people to bypass permission issues. For example, non-engineers should not have access to the engineering tools, so we have different access layers depending on their rule. And second, like we kind of mentioned, the bot should not perform write operations to the outside world without human approval. The only write operations it can do is to respond in the Slack threads. For any other write operations, like creating Jira tickets or modify PRs, pull requests, we need explicit human approval for this. And third, the bot is running in a sandbox environment on a VM that it does not have access to other things on the remote machine to not expose any potential sensitive credentials like your MCP server credentials on the machine. And lastly, the app should not use as a side channel between users. So every individual messages need to be sandboxed so that person A should not use the bot to get information about person B's DM message with the bot. And for privacy, we do not log anything for DM or private channel messages. That's done to protect the privacy for people within the company. So that is enough concept. And to best show how it looks like, here's a screenshot where someone came to our help desk asking for some cursor issues they run into, and the Slack bot was able to search both internally across different Slack channels, across Glean, and also with things publicly on the internet to provide, like, you can try those three things to hopefully help to resolve your issue. And this is another Slack thread, another screenshot where we have some PagerDuty alerts that failed. On-call engineers get paged, And the Slack bot can automatically respond with like the automatic triage. It runs like AWS commands, look at various observability tools like Grafana, Honeycomb, or Sentry behind the scenes, and provide this like root cause analysis, and also suggest the next step for the on-call engineers to take on how to resolve or alleviate it. And this is a screenshot on the human-in-the-loop step we talk about. So this is a screenshot on the screenshot on the left is a screenshot where I asked it to address some discussion Slack threads, and it will show me this like confirmation box with 2 buttons, approve or cancel. So if I click approve, it will then trigger a temporal workflow to actually go and make commit and make the code to the create a pull request to address the comment. So for all the write operations like creating pull request, deploy to staging, or creating Jira tickets, we have this human in the loop like feature offer for those. So that brings us to today, April 2026. This graph kind of shows the adoption of the Slack bot since we introduced in September last year. So when we first introduced, we have around like 20 weekly active users, and as of today, we have more than 250 people using the bot on a weekly basis. It may not sound a lot, but for a small company like Duolingo, that's more around like 30% of the company. And this graph shows the upvote rate on the response, where I think as we gradually add more skills, change the prompts, add more MCP connections, you can see the bot's response is getting better and better over time. And recently, I think it stabilizes around 80%. It's not perfect, but it definitely provides value to people. And finally, if your company also uses Slack and use like Cloud Code, we have good news for you. We actually decided to open source the core application code of the Slack bot. So feel free to check it out at Duolingo Slack-AI agent if you want to reuse this. And if your company does not use Slack or Cloud SDK agent, then feel free to fork it and ask AI to write a different version. So that's it. That's all I have for today, and thank you.
Great job. Thank you. All right. Our next speakers today are Adam Seligman and Jain Turner from Workato, where Adam is CTO and Jain is a developer advocate. Today, they're going to discuss the crucial balance between autonomy and control in enterprise MCP deployments and data plane architecture. Please welcome to the stage Adam and Jain.
Thanks, Jim.
Got some fans back.
Hey, everybody. Good morning, New York. I'm Adam Seligman at Workato. And
I'm Jain Turner, also at Workato.
And we want to talk about this control and data plane for autonomous agents. And look, I think all of us that are using this stuff today realize that all of you, are building agents way faster than sort of the governance and controls can quite keep up, right? That's kind of the moment that we're in. And there's data out there to support that, prompt injection risks, and all sorts of this stuff. So it's kind of leading all of us, I think, as an industry to think through, what is the correct architecture going to be to support this going forward? Now, we think a lot about architecture. Workato has been an integration platform for over a decade. We do enterprise orchestration. We do enterprise MCP across thousands of applications. So our customers are like pulling us to this space really quickly. So what I thought we could do is dive into sort of the architectural principles that are in play here and get right to like a framework for thinking about the path forward and how all of us will make our agents more reliable and really work inside business.
That sounds great. So behind this concept that we're introducing, or trying to ask everyone to get behind, of the agentic control plane, there's a core concept of any agentic system really has two layers, two systems, whether or not we fully realize it. There's what we're calling the reasoning layer, the LLM, the agent, that handles things like figuring out the request, whether it was a human or another agent, what's happening, the intent, what might need to happen next. That's sort of what's going on, what should happen. And that's a probabilistic layer. That's a probabilistic caller in our new systems. And then there's the second layer that you may or may not have that is that control plane. That's a lot of the themes that we've been talking about this morning, where governance should live, where authentication and authorization concerns probably should live, where things like your business logic being validated lives. All of those things that make it safe for that probabilistic layer to take action in the enterprise.
I think we actually saw this in every presentation so far.
Yeah. And as we say, these are not equal partners, because that probabilistic layer may or may not do things correctly, as we've talked about. But the control plane needs to be correct every single time, because in business there are consequences. You need one charge. You need a clinician to have the right prescription, those sorts of things. So that's why that control plane is deterministic. So you have those guarantees where you need them. And so we think there are 7 factors that can indicate whether or not you actually have an agentic control plane, whether or not you're going to have that healthy system. And it is these 7 things, ranging from governed operations, deterministic mutations, all of these things to let you know whether or not you have that. And you want to step through them a little bit?
Yeah, so again, when you built this, it was a reflection of work you've done building systems this way and what you and the team have learned from architectural principles. There's nothing specific to Workato here. It's something for all of us as an industry to think about and how we sort of like the core architectural path to go forward.
Absolutely, and this QR code, you can scan it. It's a set of white papers that went live today. This is just the beginning. We're going to be publishing more behind this, and we actually want contributors and get a whole community behind this as well. But this is expertise from across Workato, from working with our customers. This is not just specific to us as well. This is distilling what we think the field is probably finding, the themes that we've heard throughout this morning. It's going to be familiar as we dive into these 7 factors. These are, I think, what the field is converging on architecturally. Like if we dive into this first thing about governed operations, we can see it starts with a simple idea that's hard in execution. The beginning of this idea is that the protocols themselves, things like MCP, or as we're seeing people talking about Skills MD, Agents MD, these agentic protocols, they're thin by design. They are purpose-built for specific things in that reasoning layer, but they aren't taking care of necessarily all of the enterprise concerns.
There's always going to be more stuff around the protocol, the standard, the protocol. There's always going to be more stuff around that a business cares about. And we can't just wait for the standard to adopt those things. They have to be in place right now. And they're kind of, in some cases, unique to a company, right?
Absolutely. And you can't assume that the standard should take care of it for you. Don't try to put it in a place where it doesn't belong, forcing authentication into a place where it wasn't designed to handle it. Don't build that way. Take care of it yourself.
I'm old enough, I remember in the early days of banking and e-commerce, the site would have a little badge that says, don't worry, we use HTTPS. And so you shopping or banking with us is totally secure. And it's like, well, there's a lot more than that to go think about.
Exactly. And if you are in a regulated industry, what you have to protect is you sort of have to turn the dial up. Depending on how much you need to protect, this becomes even more important. So that's the core of this governed operations principle, is you need to take care of everything that the protocols don't give you. The second thing of deterministic mutations, this control plane should own all of the creates and writes and deletes. You shouldn't be allowing that reasoning layer to have direct access to the state that it could destroy. The control plane, that deterministic layer, should be controlling the mutations to data that your business cares about.
Makes sense.
Intent-based communication. This is really about the layer of how, whether we're calling it tool calls or skills, how those probabilistic callers are calling into the control plane to those systems that you care about. It should be done in ways that are about the tool's intent, what the tool's getting done, not leaking details about the implementation.
I think we've seen this a lot recently in like the debate over MCP. And I think this kind of connects to, if you start with like your API service, you just swamp context with a ton of APIs that I used to work at other companies, and you know, like the sequence of API calls needed to get some mutation done was really complex, and that would get pushed to the LLM. So this kind of go the other way. Start with the intent of the tool and then work backwards, and then behind that, then offer all the API and everything, do that outside in this deterministic layer.
Absolutely, and it's abstracting that away from the reasoning layer for a couple of reasons. One, it leaves more context for the reasoning layer to do what it's good at, have richer interactions with that human or the other agent, and it's also minimizing that potential exfiltration surface as well, hiding that implementation layer away so it's not knowing what system it's talking to or the 17 underlying APIs.
Okay.
Bounded access, as we were just talking about, whether it's that gateway level filtering or restricting the MCP server tools itself, this is principle of least privilege, but for the agentic era, for these probabilistic callers that have different behaviors. So figuring out the layers of security that you need to actually make sure that if you have that lethal trifecta and a prompt injected agent, you've made sure that that blast radius is minimized as possible.
Least privilege is not new, but it's really important here.
Exactly, and the patterns are going to look different in this new system. Safe retries. When you have callers that don't know whether or not they're calling in for the first time or a second time, which is true of probabilistic callers, it's a new game. Suddenly, things like item potency keys, it's different. Your back-end systems that are used to those external callers being able to send genuinely the same key the same way, your layer for deduping may not dedupe anymore. It's a different sort of system that you're going to have to be building for. So you have to build for different kinds of retry patterns.
That makes a ton of sense.
And of course, recovery contracts. If retries are different, errors are going to be different. If logic can't always branch deterministically based on a 400 versus a 500, that's just part of a message that is going to be interpreted as a, well, then what should I do next by a reasoning caller. You have to build different kinds of retry behavior as well.
Because this is robust, reliable, deterministic layer. These are kind of core architectural principles brought forward to this agentic world.
Exactly. So giving a message of whether or not it's safe to retry to that reasoning caller versus just the static error code.
You get the word confabulating in there. Yeah, I like that.
And of course, the last one of structural observability. If you're already letting the control plane control the mutations, the writes that you care about, if you're doing a lot of these great things like the beautiful error handling and the retries, some of this will come for free, but you're getting that observability at runtime. What happened, what was the intent, what system was called, and why. Observability by design, not just because a developer decided to capture a log.
Yeah, and not only that, the LLMs are a black box. Even if you ask it to tell you what it did, you're not guaranteed to get a truthful answer. So we have to enforce that outside in the deterministic layer.
Yeah, absolutely.
All right.
So if you want to go deeper, as we said, this is live today. This is just the first cut. This is a living thing that we want to evolve with all of you. You can get it at workato.com/7factors. And of course, you can see some of the principles in action. We have an open source application, Do We Resort, where we've put some of these ideas in action. You can see the patterns yourself, and we'll be around all week.
And it's an open conversation. So Jain, thanks for getting this started. Many of you will have a different perspective. Maybe there'll be an eighth factor we didn't think of. But we'd really like to make this an industry thing that we can build solidity around, so we can raise the reliability bar and the advanced state of agents across the industry.
Absolutely.
Thank you.
Thanks.
Thank you. All right, we have two more speakers before our break. Our next speaker is Diamond Bishop. He is the Director of Engineering and AI at Datadog. Today he is going to show us from starting with a single MCP prototype to scaling it out to an entire enterprise. His journey. Please welcome Diamond.
Hey everyone, so many good talks today. I'll be talking to you a little bit about what it really took for us at Datadog to build out the first 100 or so agents that we use, and how to prepare for the next 1,000. Hopefully some things that you all can learn. I've been building AI friends and coworkers for quite a while now, 15-ish years. I think I've been through at least one AI winter. I do have a few human friends and coworkers too, but they're a bit more complicated. So I like spending more time on these, Cortana, Alexa, all the fun ones. Right now, I'm working on experimental AI bets at Datadog, and I've built out a number of our agents already. If you don't know who Datadog is, tiny observability company. We look across the board, single pane of glass, on what does it really mean to help you operate your SaaS services, your kind of products, everything that you do, hopefully as software developers. That's all across the board. But as we've entered the intelligence age, we've really thought a lot about what does it mean to automate these DevSecOps tasks, the things that you're doing every day when you come to Datadog. We've categorized these as 3 focus areas: AI agents for Datadog, Datadog for AI and AI agents, and then AI agent infra. I'll give you a little background so you can understand where we've learned some of what I'm going to talk about here. What are the agents that we actually already have running in production? What are the agents that we have working for you today? First is the Bits AI SRE. This is one of the first automated SREs that was on the market. This one really thinks a lot about what does it mean to autonomously investigate alerts. Our goal there is to make sure you're not waking up at 2 in the morning dealing with issues. We should be able to handle those for you as they come up. And at the very least, when you get to your computer, we've already, hopefully, figured out what was going on. Next up is the Bits AI Dev. This is our code generation product. Really, this looks at errors that are coming through your service, looks at latency issues, looks at all the kind of things that devs might be doing to help clean up your service every single day and propose code fixes for you. The goal there is I don't have to go and open an IDE. I can just go to Datadog and see, oh, here's a little fix. I should drop that in and make sure it works well. And the last big one that's GA'd today that people are actually playing with is the security analyst. Think about investigations that aren't just operational investigations, but they're security investigations. These are very important, and these are things that humans spend a lot of time on, just going through checklists, going through checking a number of things every time there's a particularly concerning alert that comes up. We hope to automate more and more of that for you every single day. All of those really are predicated on improving with the improvements that are coming with AI models. And if you really think about what's been possible today and what's going to be possible tomorrow, the biggest things that are changing are that these models are getting faster, getting better and better, faster and faster. They're handling larger context windows, they're running for longer and longer, and this means more of the tasks that each of you are doing can be automated. Intelligence is not going to be the bottleneck anymore. But the things we are seeing a lot of when we talk to customers, when I really talk to a lot of startups, when I was working in my own startup, is that it's not just about building an agent that works. It's about building an agent that can operate autonomously. You know, there's a little bit of this like who watches the watchman. You deploy an agent, but then is there an agent watching that agent? Maybe, but then who watches that agent? It's, you know, gets a little messy. Turtles all the way down and all that. So what have we learned? I'll touch on each of these individually, but code and agent first, very important. Being proactive over just reactive. You know, you've heard some speakers talk about agents really started with this kind of chat interaction. That's one modality, but we're doing a lot more today. Eval and monitoring, what multiplayer might mean in this new world. Framework and model agnostic, and what the bitter lesson is for agents. So I'll start a little bit about what does it mean for agents to be your users. First, of course, if you haven't tried it out already, we have an MCP server for Datadog today that is one of those entryways for how an agent can be a customer of Datadog directly. And I think of it as a great initial entryway. But if you're building these systems today, you also want to make sure that agents who are going to be your customers can read your docs. There's some very simple things to do there that many companies are starting to do. This is the LLMs.txt. This is the .md support, all that kind of fun stuff. And your UX teams, your designing teams, should really be thinking about agents using your site, using your applications, using your product, using your APIs. The number of design teams that aren't thinking about that while the devs are just sitting there trying to make that work is quite high. You shouldn't just be designing for humans anymore. So code and agent first. You know, Steve Yegg is famous now for his Gastown craziness, interesting systems. But back in the day, he first showed up really to viral fame on Google+. Many of you may not even know what Google+ is. But he wrote about the Bezos API mandate. And as a former Amazon employee, I'd say this mandate is pretty correct. It's really about how did we make it so that Amazon became a platform company and did a really, really good job at building platforms and services and keeping autonomous teams. And I think there's a new version of this mandate for agents getting work done on your products within your companies and becoming agent-native companies. You can dub it your Bishop API mandate if you'd like. But really, the big thing is make sure all your interfaces are agent-friendly. Do not go and make it so that everything that has to be done inside your system, inside your UI, has to be done by a human. You should really think a lot about how are you automating the tasks that your humans within your companies are doing and that your customers are doing. Go and try to automate them with agents yourself. Don't wait for someone to come do it. And OK, I'm going to say it doesn't matter what technology they use. We're at an MCP conference, so use the MCP technology. But you should think about APIs, skills, A2A, whatever it is. I don't really care that much as long as you're actually thinking about this. And push your UX designers to think about this as well. And lastly, if you don't do this, you'll be fired and replaced by an agent, right? OK, what else have we learned? Proactive over reactive. I spent a lot of time on chat, voice, et cetera. But the agents that are winning today are going to be the agents that can run in the background, run for hours, go and handle the tasks that you don't want to have to sit there and babysit. So make sure you have background, long-running agents. And usually that means they're event-driven. And if they're in the background running without babysitting, you really need durable agents. Temporal is great for this. Big shout out to them. We use them quite a lot. And then you want those to be contained. They shouldn't be running on your local machines. I know people love OpenClaw and all that fun stuff. But if you want to do this safely, go and run them in containers, sandboxes, have appropriate storage and file systems so you can trade out agents. Eval, eval, eval. If you're launching an agent and you don't know how you're doing eval, please don't launch that agent. Go and try it out, but make sure you understand how you're going to observe if things go wrong. Make sure you understand how you're going to improve. The first time you build an agent, it's not going to work for everything. You should have offline eval, online eval, and a living, breathing eval system. Things will change fast. We all know the concept of data drift and all that fun stuff. So the nice thing, though, quick call out, you should also make sure this is all automatable. One of the things you can do is make this available, make your eval system and your improvement tools available through an MCP server or available to agents. Have an agent that thinks about that loop, and then you can improve that over time. And really, I think of the agent-level bitter lesson as the fact that your agent harnesses are really the kind of important thing that you should keep very, very simple. Don't overcomplicate them. Build them to rewrite them. And just know models are going to keep changing. Whoever's the best one today will probably not be the best one tomorrow. Don't build for one particular framework or build for one particular model. We have this kind of like, it's so over, we're so back situation. I think a few months ago, before December, people would have told me Anthropic's dead with their models with Claude and all that stuff. It's not really catching on as much. And then, now Anthropic's the best one. Now people are going back to Codex. Like, we don't know where it's going to end, but I think keep trying things out. So stay model agnostic. Stay framework agnostic as well. And one of the tricks to doing this is make sure you have good memory systems so you can take the learnings that your agents have kind of gathered over time in your company and move them regardless of what the model is. Multiplayer is not the Figma version of multiplayer anymore. Multiplayer is human and human, human and agent, agent and agent. Make sure you have appropriate communications for all of those. We've encoded these learnings for you in a new product that I'm playing around with called dispatchagents.ai. Go check it out. Otherwise, happy to chat. Looking ahead, I think there's quite a lot changing. We're going to see more and more learning on the job. So assume your agents will keep getting better within your systems, within your tasks. Assume they're going to be longer running and more independent. And build even for multimodal models and agents tomorrow. Things like computer use might actually be useful in a few months. We certainly do expect more and more agents to have eyes and not just be using text. Thank you so much. I appreciate you all.
Thank you. All right, our last speaker of the day is Nick Aldridge. Nick is a core maintainer of MCP and co-founder and CEO at Mousecat. If building MCP agent is one step, scaling across a team is where it gets real. Nick today is going to discuss agent integration, modalities like skills, tools, APIs, and their trade-offs and what you should do about it. Please welcome Nick. Hey, man. There you go.
Hello. It's been about a year since the first MCP Summit. How many of you were at the first MCP Summit in San Francisco? Oh, just a few. All right, great. Fantastic. So my name is Nick Aldridge. I was formerly a principal engineer at AWS and a core maintainer. And now I'm trying my hand at a startup. I'm working on fighting a new wave of AI-enabled fraud. Just wrapped up YC, and we're opening an office in New York. Today, I want to talk to you a bit about primitives for agent interactions. And as I begin, I want to talk a bit about how we got to this state. So initially, many of you are familiar, right? Like we had early models, GPTs, that were pretty good at chatting. Many of you tried ChatGPT. And this was very exciting. It was groundbreaking. And people said, we can do more with this, right? We can do Q&A. There were very early RAG applications. How many of you built a RAG application early on? A bunch of you, great. And so this was also very exciting. And companies said, hey, we can actually automate workflows, right? The models are good enough that we can do some dynamic routing, and we can actually start to build something sophisticated with these new LLMs and models. And that was really cool. And we had things like LangChain and LangGraph that helped us do that. And suddenly, right, the models got good enough that we could really do tool and function calling. And so at that point, everybody started building tools, right, to enable their agents to do amazing stuff in the world. And this actually led to a big problem, which is that everybody was building the same tools. Everybody wanted to talk to Google and Salesforce and Confluence. And so everybody was building the same tools over and over again. And we said, can we actually reduce this friction? What if we could share tools with one another? And so that was one of the primary motivations for this amazing thing called MCP, which was going to enable us to share tools with one another and define a protocol for agents to interact with the world around them. And kind of in parallel to all of this stuff, there has been the progress of code generation. Models have gotten better and better and better at generating code. And this has kind of come to a head this winter when the models got so good at generating code that they could pretty much generate all of the code that software engineers were writing, plus they could generate code sort of on the fly. And so many of you saw posts like this. I don't know if you can read this. This is from Gary Tan, one of the managing partners over at YC, where he says, MCP sucks, too much context bloat, and the auth is hard, right? So he is just using CLIs. How many of you are just using CLIs now in your local development? OK, most of you are not. That's good. I think CLIs are pretty great. This is kind of what it looks like when a model uses a CLI, right? It predicts a computer use, and then it just generates code. Awesome. This is super context efficient. Code is very dense, right? It can express very complex things in very few tokens. You can also compose code, which is something that's pretty cool, right? You can pipe code outputs to one another, which is amazing. And more importantly, we could have the same interface for humans and machines. What this meant was that we could take all of the APIs and CLIs that were already floating around the world and just use them, right? We didn't have to build all this new stuff, new servers, to be able to access those tools with our agent. Now, one of the big downsides is security. To do this, I need to allow remote code execution. I'm just going to go run whatever code my LLM predicts and hope it's secure. There's also an integration overhead. What tools do I need to be able to run this code, right? I need the GitHub CLI. So I have to do all of this installation, all this pre-configuration to be able to even run this command. And this will ultimately lead to dependency bloat. So there's some trade-off here, right? You can see between using this for enterprise applications and using this for developer applications. Now, MCP, by contrast, is amazing because it has bidirectionality. MCP has great semantics like elicitation for talking to humans. So it's not just a status code. You can actually have a very directed message to a human. It's super easy to integrate. Once I have the base client, I can talk to any MCP server, right? There's a standard for authorization, so I have strong guarantees or higher guarantees about the security bar if I'm an organization. And it's more secure because I can curate the MCP tools and servers I'm going to talk to, and I don't have to do this whole arbitrary code execution thing. But on the other hand, I have to go write MCP servers, or I have to go figure out my MCP client, and this is new. And if I'm a business, I have to create a bunch of MCP servers and maintain them. There's also the risk of context bloat. So you've probably seen if you list tools from an MCP server, you get back a lot of tools. And they're all going to be put in context. And so this is costly, takes additional time, and can reduce accuracy. And then finally, MCP is not really composable, right? I can't pipe two MCP tool outputs together very easily. And so MCP and CLI are sort of there. And then there has been the emergence of this other thing called skills, which many of you are probably also familiar with. And this is providing a way to give context or give instructions to an agent about the things it can do. So I can provide a skill that tells an agent how to book a hotel. And that operation may consist of many different tool calls, many different API calls, right? It may need some additional context. And so skills are sort of a way to dynamically provide those types of context to an agent. And they're awesome because they're also naturally, progressively disclosing. What that means is that with skills, I don't have to look at all of the information about how to do something until I want to do it. So skills were kind of this crazy unlock, and a lot of people started using them. And some people thought skills are not compatible with MCP. Skills are totally compatible with MCP or any other way that you do tool calling. They're just a way to manage context, essentially. And the big problem with skills is that they're not shareable today. Basically, if I want to share a skill, I have to package it up and send it to you. They're not integrated in an MCP server. And so looking at the landscape today of MCP and CLI and skills, I think there is an opportunity to improve MCP with the learnings from the field. And number one, I think MCP desperately needs progressive disclosure. There is no reason that people need to list all of the tools and all of their arguments at the outset of orchestration. And so you probably have seen that many applications now support search. And in the future, progressive disclosure may become a first-class entity in MCP, right? To aid folks in essentially doing this, more similar to maybe how skills work. Secondly, MCP can also be composable. There's no reason that you can't pipe two tools together, but it's not supported in the protocol today. So this is another great opportunity to improve MCP. And lastly, MCP can add support for skills, right? What if I can call an MCP server to discover the skills I want to use? And so when I say these are opportunities, I don't mean that this is an opportunity for the core maintainers to go sit in a room and figure this stuff out. I mean, it's an opportunity for all of you, right, to contribute to this amazing open source protocol. And so I strongly encourage you to raise steps and do that. So I think a few quick takeaways. If you're an enterprise, MCP is still going to be way more secure. You can curate all of the tools and things that you want to work with. And there's strong auth characteristics that I think are very useful. So I would encourage, if you're an enterprise, to strongly consider sticking with MCP. If you're a developer, do whatever's easiest. Do all of them, right? However you can get access to the tools you need, do it. And lastly, in the future, MCP can improve. And so, like I mentioned, I encourage you folks to do that. Finally, if you're interested in this whole wave of AI-enabled fraud, come talk to me about it after or scan this QR code. All right, thank you.
Thanks, Nick. Appreciate it. All right. Thank you all for our keynotes today. Thanks, everybody, for sticking around. Before we go, I have one exciting piece of news to share. Today, the Linux Foundation is announcing the start on 4/2, April 2nd, of the X402 Foundation. So, you know, with all of these new agents out there, agents got to pay for stuff. And X402 is going to do that by embedding payments directly into web interactions. You can see the support that we've got here from companies like Amazon, American Express, Stripe, MasterCard, Sierra. Many, many companies already signed up for this. Stay tuned for more news about this ahead. Today we're heading to a coffee break before our sessions begin. Sessions are going to be on the 5th floor in the West Side Ballroom. In the West Side Ballroom, that's our sponsor showcase. Sessions will be all over the venue. We will see you back here tomorrow morning. Enjoy the afternoon. Thanks, everybody.
Wow, there's a lot happening over here. Look at this. We got content happening over on that side. Check out back here. Can you guys show them this? Show that we got content over here. Us? Yep, we're making content. That's right. Let's go walk around and talk to some of these folks. What are they working on? You, good sir.
Hi, how are you?
I'm doing well. You ready to talk to the stream about what you're working on?
Yes, sure, definitely. Like I am work for Google Cloud. Like I'm an Envoy maintainer, so I'm specifically focusing on the how to proxy the MCP traffic.
Nice.
And today I also have a talk to talk about how to proxy MCP traffic at scale this afternoon.
With Erica.
With Erica, yes, exactly.
I was talking to Erica yesterday.
Yes, we are still preparing.
So I got, as you should be, I wouldn't expect a talk to be ready before it actually happens.
Yes, exactly.
I was talking to Erica, but I want to hear from you. Mm-hmm. What's your favorite skill?
My favorite skill is GitHub skill.
Oh, tell me more.
So like we use a lot of I'm a developer, right? So like I don't want to remember a lot of commands, and we just all the workflow will be a skill like GitHub, Bazel, build for my software. Like the skills, they just automatically do that for me.
Oh, nice.
I don't remember all the command lines, and for my normal developer workflow.
You just say it, and boom, it goes.
Yes, I just say, please finish that on behalf of myself. I don't need to deal with all this detailed stuff.
When's your talk?
5 p.m. 5:20 p.m.
All right.
Yes.
You heard it. Thank you, sir.
Thank you.
Oh, let's keep it moving. Let's see what are you guys doing over here? You want to chat with the stream?
Yeah, let's do it. What's up?
All right.
Hey.
So, tell me about Dscope.
Yeah, Dscope is an identity auth company. We do auth for your B2B, B2C, and also MCP needs as well.
Nice. So I got one question for you. What's your favorite skill?
My favorite skill?
That either you've created or you've found?
There's a bunch of them around the writing of AI agents. I like the ones that make the AI talk funny. The ones that instruct agents on how to speak like a pirate or, those kind of fun ones.
Okay.
Yeah.
I like that. I haven't used those, but I will. You mind if I grab some stickers?
Of course. Go for it.
We're going to add it to our... I'll let you do the honors if you want, because I only have one.
Oh, you're
add it on there. You're the first.
Okay.
As you can see. I'm going to go walk the floor.
How's the event so far for you guys?
It's been awesome. We'll let the chat tell us what they've been thinking.
Cool.
Yeah. How about you? You just got here,
Just got here. Just set up. Yeah,
just got here.
As I would hope.
Yeah. Good.
Cool.
Yeah, this is it. This is you're about to get an onslaught of people.
How many people does it take to get one sticker?
We may have to scratch the sticker plan. Yeah. Exactly.
I'd like to see Claude do that.
Exactly. We'll come back.
Okay.
Don't worry. Yeah. We'll keep it. All right. Can we talk to you all? What are you guys doing over here? I like that hat. I like the hat. We'll come back for the hat. Promise that. You guys ready to chat? You want to chat with me? I want to hear what your favorite skills are. What skills do you use?
Playwright.
Playwright skill?
Yeah.
Tell me more.
For basically letting so I don't have to test the web app anymore. Just get the agent to go do it.
And is it taking screenshots and then?
Yeah, both screenshots and using the app. Yeah.
All right.
Yeah, because I don't want to have to go test the app until it's working.
Yeah. So you let the agent
do the loop.
Use Playwright.
Write the end-to-end test, whatever. Write the Playwright test. Take screenshot or snapshot.
Did you create the Playwright skill, or did you grab it off of a repo?
Oh, it's a mixture. Yeah.
All right. So Playwright and
I don't know any skills.
No.
I'm here to learn.
All right. I like that. That's cool. How's it been so far?
Good. Yeah.
The talks?
Yeah, I got some. Yeah. Good talks. Got some free muffins. Yeah.
Excellent. Well, you guys have been great. Thanks for doing this for me. Hey, there we go. He's back. Let's see.
Perfect.
Excellent.
Oh,
hey, you ready to chat?
Yeah, let's chat it up. How's
what
it
are
going?
you guys working on?
So we're a code quality and code security platform. Basically, we integrate with AI agents through an MCP server, which is why we're here.
Okay.
The main focus here is that while AI is generating code, we're here to guide, verify, and solve all of the issues.
So I've got one question. What is your favorite skill?
Skill?
Yeah.
My favorite skill? Well, in what context are you asking?
/skills.
Oh, /skills.
For your agent.
For my agent, okay.
If you have any, otherwise you can pass.
We have one. My favorite skill is our context augmentation and analysis agent that we have. All right, so basically we're able to take the full context of all of your project, all of your portfolios and pipelines that you have in creation, and basically able to train your agents to not break the code while it's actually creating and generating. So
all right, I like that. You guys got stickers?
We do.
Can I grab one?
Yeah, let's get you.
Wait,
I
like this. No, I want this one. Vibe then verify.
That's it,
Let's
baby.
throw it on there, and we're gonna keep moving. Otherwise, if it's, you made it easy.
I made it easy for you.
Vibe then verify. Let's get it rocking. Thanks for being a good sport about this. I appreciate it.
Thanks for coming around, guys.
Yeah, now we'll let all the people come to you. Here we go. We're gonna go this way because there's more people coming in, so we're gonna hide from them and see what we got. Where are more people? What's going on, man? You want to chat with me for a sec on the stream?
Oh, no, thank you.
No. That is totally fine. You want to talk? I know you want something to say.
What are you doing?
Well, I'm just interviewing people about their favorite skills.
Oh, well, I'm not sure I have any favorite ones yet.
No?
No.
No? All right. Well, we'll come back if you think of something. Let's see. Nate, all right, we'll go over here. Come this way. Right. Shub.
What is up?
I'm asking one question.
Yes.
Well, first, what are you working on?
A lot of cool things. What are you working on?
You don't want to know.
Okay.
Tell me.
About Arcade?
Yeah, tell me about Arcade.
Arcade is an MCP runtime. We're like the governance layer and the authorization layer for your AI agents to take action. Our runtime lives outside of the agent loop, so the actions that your agent takes happens outside. We can inject auth and do governance, and your AI agents never see the secrets and the auth tokens that it should never see.
It's a very tight pitch. I like it.
There we go.
What's your favorite skill?
Do you mean Claude skill or like skills I have in life?
Oh.
In your life.
Well, yeah, you don't have any skills in life, dude. Come on.
Right now, one of my favorite Claude skills, I think browser use has a really cool Claude skill that I've been using recently.
Tell me how you use it.
just add it to Claude, but I actually built like a sandboxing thing, and I want to be able to use browsers within my sandbox. So the browser use skill, shout out to those guys, make it really easy. And then you can also use the arcade skill to get all set up with arcade and all that fun stuff if you wanted.
Excellent. Well, this has been awesome.
Hey,
Thank you. You guys got some stickers for me?
Yes, I do.
Okay, let's get it right. Wait, you're going to have to peel them off, and then I'll come back and we'll stick it on there.
Oh, okay.
I'm going to go talk to these guys over
do your
here. We can...
See you guys.
Adam, you ready to chat?
Yes.
What are you working on?
Yeah, so we are a search AI company.
Yep.
Fantastic. And here we are presenting the agent builder, which is, as you might guess it's an agent builder where you can...
Good name. I like it.
Tell me about it. So you can create your agents, you can set up the tools that it can use, it can analyze your data, can visualize it, so it fully integrates with
So
the stack.
I've got one question. What is your most used Claude skill?
My most used Claude skill?
Yeah. What skill do you use the most in your coding agent?
Oh, okay. Claude skill. Maybe generate, like, analyze a PR and
you have like a PR skill?
Yeah, we have an internal repository of skills.
All right.
And like every employee is encouraged to use it.
Excellent. You want to throw a sticker on here? You want to throw a sticker on here?
No.
Let's get one on. Where? This one, maybe. This is a good one. This is a solid one. All right. Thank you for being a good sport. We're going to keep walking around. You got it? Yes. Yeah. Look at this. Boom. Bam.
Okay, we got that.
All right. Excuse me, sir.
Hey. Yeah.
I got one question for you. What is your most used skill in your coding agent? What is it?
Most used skills in my coding agent. Like you mean what programming language?
No, you don't use skills for your coding agents when you're writing code with AI.
Yeah.
Skill. What skill do you got? You don't use any. I'll come back to you. It's all right. We'll find one. I got you on by spur of the moment. I know that was putting you on the spot.
I mean, if you say the most used skills, it can be. You mean MCP in? So let me tell you one example, right? So I have my own blog, right?
Yeah.
Back in the old days, we were writing WordPress, thing like this, right? So I ended up using prompt initially, right? Using prompt to rewrite the whole blog.
All right.
And make the whole everything I wrote in the blog, every instructions I gave, every pictures I have, every screenshots I have.
What did you do with them?
Everything has been rewritten.
Ah, interesting.
Yeah.
Ah, okay. So that's what you did with the agent. I like it.
Yes.
All right, we're going to keep moving. Thanks for being a good sport. Yeah, cheers. Let's keep it rocking. Sean, you ready to be put on the spot? Your favorite coding agent skill, the most used one. This
skill or tool? Right now, I was going to say fast.
Yeah. But do you have a skill that you created or? Yeah. What kind of have you been making?
Right now, I have one that runs. Basically, it runs a cron job, not a cron job. It pulls data, runs into local sheets, builds a spreadsheet, pulls together 3 different reports off of that, creates those in Notion, shares those with people, and then asks me for input to guide the next set of reports that I need to build.
I like this.
So, yeah, that one.
All right.
Yeah.
So fairly
I don't
complex.
have a name for it. It's just a report generator.
It's the stuff I do on a daily basis skills.
Yes. Yeah. Correct.
Well done. Well, thanks for being a good sport. I'm going to be putting you on the spot. Take it easy, Sean. All right, where are we going now? Let's find some more folks. What are these? Can I chat real fast with you?
No? Yeah? No? Hey? You ready to be put on the spot? I've got some... The boss do it? All right. No, then it's all right. We'll keep moving. So, not a lot of skills out here. Not a lot of people building skills. We're going to keep it moving. You guys want to chat real fast?
It depends.
I want to know what your favorite or most used coding agent skill is.
Skill? Well, we have a Apollo skill, so we use GraphQL for API discovery and semantics. I love skills. It's a really thin and simple pattern. I've lost track of how many I have. I don't know if I have a favorite.
Yeah, there you go. But give me some that you use on a daily basis.
I saw internally, we have our Rust skill that we took a bunch of our internal docs and turned into a skill for Rust.
Yeah.
I'm pretty sure someone just said it's like the top Rust skill now. Like, we didn't try to do that. We just took a lot of docs we had internally and posted it.
It's open source?
Yeah, I'm pretty sure it's on skills.sh.
It's on SH, yeah.
Rust in it. It's Apollo Rust skill.
Best practices. I don't even know if it's like it's in the GitHub repo thing.
I feel like I've heard of that even. All right.
Yeah, I think it was just someone wrote some really good docs internally, and then we turned it into a skill, and it's killer.
Okay. And what are you guys working on?
Well, the big problem that we're interested in is you're going to end up with a lot of agents in your company behind the firewall, and they're all untrusted. So how do you really make it possible to build with AI on top of a bunch of systems that were never designed for that? Like, pick your favorite piece of SaaS. Inside a single endpoint, it's going to mix a bunch of really sensitive data that an agent probably shouldn't have, or at least not without somebody's approval, with a bunch of data that you really need to make your business go faster.
I could vibe with that.
And so we're building a zero trust security model that solves that problem. That says every agent needs to have its own identifier, needs to have its own credential, it needs to have its own set of policies, and we're going to enforce the narrowest set of data across all the different systems you have so that you can get all the benefits of running at the speed of AI without discovering one day that somebody deployed an agent that sent all your important data to your competitor.
Without ending up on the front page of the internet, basically.
I mean, I think the bigger risk is no one will know. Like we're facing the biggest security risk in the history of the enterprise.
Wow.
Like think about people are writing agents. They don't look at the code anymore. So just sort of simple mistakes, surprises. But you've also probably got disgruntled employees on the way out the door who are deploying agents behind your firewall. It's like that guy from Jurassic Park. Remember the Dennis Nedry guy that stole the embryos? There's someone stealing your embryos right now, I would imagine, at any large company. They're probably getting a bonus on the way out the door for doing it because they wrote an agent, And even if you think about like what happened with Anthropic and the DoD, does anyone really know what's really going inside the foundation labs? Like there are state-level security concerns now where it's really hard to be sure. Now that we've gone from a world where engineers you trust building all your software that have access to your stuff to a totally different situation.
Just shipping.
We want to make it possible for everybody to move fast and build without destroying the business along the way.
I like it. Compelling argument. Thanks for that. Thanks for being a good sport. Can I grab some stickers? All right, we're going to take this, and we'll find a way to stick it on my shovel. How are we doing? Can we just check out the vibe? Let's see. What is going on over here? That is cool. I didn't get any really good skills, but we are, I think, about to go to the... All right, we're going to try and find one more quick conversation, and then see what we've got. You, good sir.
Yeah.
Can I ask you what your favorite skill is? Do you use coding agents?
Put me on the spot here.
Yeah, I know. Sorry. Had to throw it. It doesn't help. The light doesn't help. It makes you feel a little nervous. But
I just throw out one. Yeah, I got nothing for you right now.
Any that you've created? Or any tricks while working with the coding agents that you like, that you found and you're like, everybody should know this, but I'm gonna, right now I've got it. I'll tell you mine.
Okay, go ahead.
And then you can think. So whenever you have a particularly hairy session with an agent, at the end of that, you ask it, hey, what was hard about this? And how could we make it better for you? And then once it gives you like, oh, well, it was hard because I didn't understand this part or that part, you say, okay, now create a skill. Right. And then the next time you don't run into that same problem.
Makes total sense. I'm not going to be any help for you right now, man. Thanks, I appreciate it.
That's all right, yeah. See ya. All right, we're knocking stuff down. That's all right, we'll come back to that. Are we going to the breakout sessions? We're not yet. We're going to keep, look at these guys have some Alpine stuff. All right. Who wants to chat? I think we're scaring people with the light. What do we got? We got a pirate here. I get the feeling, you good sir, you want to chat? I mean, you're in a pirate costume.
Hit me, yes, hi.
I think I may have found my match. What's your favorite skill?
What's my favorite skill? I actually don't have a favorite skill. I mostly find security vulnerabilities in this stuff.
Oh,
yeah.
Tell me more.
I've been looking around at security of MCP servers and finding vulnerabilities in them. Namely, I'm talking about having found a bunch of DNS rebinding attacks and basically hacking MCP servers that are running locally on your machine from the context of the browser. So you connect to a malicious website, and that malicious website is then able to talk to the local MCP server on your machine, and then make tool calls as if they were your agent.
Okay, so how do we protect against this? Because you're scaring me already.
I mean, hopefully, so the top 4 SDKs are all fixed because of my research, and Anthropic paid me a $1,500 bounty for it.
They should have paid you more.
Well, you know.
Let's be honest.
Anthropic,
where are you?
But the other SDKs, I don't know what the current status of them are.
So use the top 4, basically, summary.
TypeScript, I don't know what the other 3 are. I don't know if Rust, I think TypeScript,
Python.
Rust, yeah, Python.
Yeah.
Those all fixed it. But in general, make sure your SDK is you're using a Type 1 SDK or a
Solid
Tier
advice.
1 SDK for your
All
SDK.
right, I appreciate you.
Yeah,
Thanks
you.
for doing this on the
yeah,
spot
nice to meet you.
like that.
Cheers.
We've got, where's JQ? Hey, over here. Oh, you ready? Look at this.
God,
dude,
yeah.
You got to tell me about how you got rid of Jira and Linear and all that.
Oh my God. So one day we discovered that we're no longer logging into Linear, but our issues were being tracked. And the reason was that Claude was just going to MCPs to Linear to just get everything done.
Yeah.
And they were like, I'm not logging into Linear. Why am I paying Linear? Anyway, so experiment going on right now. We moved all our Linear tickets into a GitHub repo, a Git repo, all markdown files, and now our agents are just working against it. So the agents,
it's a file system.
The file system. Front matter, structured things, same tickets in there. Now the agents wake up, they are in Slack, they find out what's going on, they Slack us what to do, they update it in GitHub.
Yeah.
And guess what? Our code is in GitHub.
Yeah.
So they're next to each other now. So it's very seamless. Everything just there.
Oh.
Like everything for agents, it's all about markdown files, MCPs, all of these things.
But
right?
how is using GitHub with the markdown files? Like, where are you running into problems?
Oh, interesting. So we ran into a problem in that now one of our PM's like, can I see it? What's going on? So we wiped out a front end. A front end to the GitHub tickets, and it actually works. But then this is nice because
just so that you can see what's happening.
Correct. But then we don't really update it; it's read-only. But what's really nice is that we are getting a custom experience on how we want issues to be managed, and that's critical, right? This is the age, I think, of custom software builds, custom AI systems. I think people should build their custom MCP servers because we want AI to be shaped around how the business operates.
Okay.
And that's really amazing. Yeah.
Yeah, so this custom. It's funny. So I've been asking everybody one question. What is your most used skill?
Oh boy. It has to be the writing skill.
Yeah?
So I have a 5-6 page long writing skill, which teaches the machine how to write like me without sounding like weird, stuttery, And it helps me a lot because like I have all my thoughts in my head, but it helps me present them in a way that's understandable.
Okay.
That's my most used one.
So you'll just context dump, then you use the writing skill to clean it up.
I would speak to it, so I use Super Whisper, dictate to it and everything, and I'm like, okay, great, use the skill, clean it up, write like me now, but it's all original content. But it's helping me phrase it in ways that I like.
So you're not asking for it. Okay.
That's one of many skills, like 20 of them. It's like crazy.
You got 20?
Oh, we have a lot.
Some of these folks I've been asking, they're like, skill, what? Oh, so it's good to hear.
Boy.
We've got the whole spectrum.
The whole spectrum, and everything.
Tell me another one.
Oh boy, let's see.
Coding
related one, front-end design. So our front-end designer was like, okay, we're doing all this front-end stuff. How can we make our front-end consistent? Right, rather than a designer going through looking at the brand guidelines and how we do things, make a skill for it. So when we add buttons, when we add things to the website, it's all in the design language if you want to keep it in.
So now, and you encapsulated that in a skill.
Exactly. Exactly. So it's really fast now. It's one of them. A lot of stuff in there.
That's smart.
Yeah.
So the brand guide, but with photos and everything?
No, so we have a whole component library in code. So the front-end skill refers to the component library now. Like how do you put the buttons out? How do we want to frame things? What language do we use? All the components are like nicely documented. The skill tells you how to use them. And so it's like, Anthropic has a front-end design skill, but we made our own. And now, so the front-end...
And it speaks your language.
Speaks our language, exactly right. So now start thinking about every single thing you do, back-end design, front-end design, all the different architectural stuff, make skills for them. And they need to be custom to your company. Because that's how you make the AI work for you.
Right. It goes back to the custom software and building that. All right, we're going to keep moving.
Thanks, Demetrius.
Thank you, dude. That was awesome. That was really good. Who else are we going to talk to? We're putting people on the spot. Can I put you on the spot, good sir? You use any skills? What's your favorite skill?
So I have a couple of my own skills built in.
Tell me about it. I love this.
Yeah, we do spec-driven development in what
like you
I'm
should,
doing right now.
Yeah. Tell me more.
So there's a skill to write that spec in a specific way. I'd go in.
Wait, before you get to how is the spec in a specific way?
We use GitHub issues to track all of this. So what we do is we have a main spec where we have a template of telling, okay, what is the issue, who's getting impacted by it, why we are making this change, and what changes are you making. And then that spec is split into child issues. So my skill does exactly that. So I'd go in, I tell it.
How is it able to know downstream who's affected? So like...
no, so that's in my, when I do / invoke it, it asks me what the issue is.
So you put it. Oh,
yeah,
okay,
exactly.
Okay.
So let's just say I'll give it a complete rundown of what I'm trying to do. Then it will go back and forth, ask me questions, who might be affected by it. And it has its own context because it's in our project. So that's what it does right now. That's the main skill I have.
That's a cool skill.
Yeah.
Basically just formatting any kind of spec in the way that you want it.
Yeah.
And asking questions if it doesn't understand what is about to happen. Okay.
Yeah.
Any other good ones?
Couple of them for committing. I like my commit message in a certain way. So the commit message would be that, okay, let's just say multiple files have been edited. I would like to know in each file what was changed. Because I've seen that what happens is models are better at writing these messages, and they can write like really detailed messages. So that's why I have a commit skill also.
Yeah, okay. All right, I like these. I'm going to start using this spec one. That's cool. Thank you.
Perfect.
I appreciate you.
Thank you.
We're going to keep moving. We got 15 minutes still before the talks begin. And so I'm going to go over here. Where should we go next? We missed some... we need stickers. Guys, can I grab a sticker?
Oh, of course.
Let's open it up. You want to chat on camera? All right, what are you working on?
Copilot Kit.
Tell me more.
I'm not a founder, but it's AI infrastructure for building copilots and agents in React and Angular applications.
Oh, cool.
So on the client side.
Yeah. I've been asking everybody, what is your favorite or most used skill?
So I'm actually building my own skills.
Tell me about it.
Yeah, so with Copilot Kit, we have just tons of GitHub issues and PRs. We're trying to help our team automate at least some of the analysis that's coming through for bug fixes. And so I've iterated with Claude, built skills to have a review agent go over our GitHub issues. So anyway, it's basically bug analysis.
Okay.
That'll help our team triage the issues that come up, and then we know like how to prioritize them. That's really the idea.
Are you open source?
Yes, 100%
so you're
open
getting
source.
a lot of open source submissions, I imagine, and that's why it's so huge time saver.
Yes, yes, exactly. Yeah.
Awesome. All right.
Yeah. So between feature requests and bugs, it's just open source stuff. So some of them is dealt with the community. They fix and are constantly like submitting open source requests. It's
the normal life of a maintainer. Yeah, I get it.
Yeah.
Well, thanks for being a good sport. I appreciate that.
problem.
I'll get it. See ya. Oh, this guy. What's up, Sid? How you doing, dude? You ready to be put on the spot?
Maybe in a little bit.
All right. I'll come back to you. I'll see you, man. We're going to keep moving. What kind of swag do we have over here? Any stickers I can steal? I'm making the guys behind the camera work hard. What do they got? They got shirts. We got, what is this? Oh, run there. Augment code. Let's talk to these guys. Let's see if anybody's willing to chat with us on this side of the house. They're busy. We'll find, I just saw somebody look at me and run away. You want to chat? Yeah, why not? What are you working on?
I'm working on temporal.
All right.
Yeah.
Durable execution.
Exactly.
Yes. Tell me more.
So durable execution, what it is or what we are doing here?
Yeah. What are you doing here? No, tell me about durable execution because I think it's a cool concept that's starting to take fire.
Yeah, durable execution is a way to preserve full state of your code execution.
Yeah.
Means that any failure is handled automatically. So you write code as a failure doesn't exist and it just runs for you.
Which is kind of a wild idea. The code just works.
It's exactly what people say. It's good to be true, but it actually works.
All right, so I've been asking everybody, what is your favorite or most used coding agent skill?
Skill? I don't use actually many skills right now.
No?
Right? Like,
what are you
actually,
using?
I use temporal one, right? Because
temporal skill.
Yeah, we just launched our temporal skill recently.
Right.
Yeah.
And what? It just helps you use temporal better?
Yes, because temporal has specific rules how to kind of write code.
Okay.
And
that makes sense.
And we kind of put them in a skill, and we had people who did migrations in the kind of which usually would take weeks, like in a day, using that skill.
Perfect. Yeah, right on. Well, I appreciate you chatting with me. We're going to keep moving. Absolutely. You guys got any stickers I can throw on here?
Stickers?
Yeah, what kind of swag you got? We should have a best swag award. We're going around getting all the swag, and we got to see who has the best. And we'll let the chat.
This is our
nice.
mascot.
Nice. Can
symbol.
you peel it apart and throw it on here? Because I don't have two hands. Let's see if we can find another victim to chat with and find some skills. Hello, sir. I like this jacket. Awesome. Throw it on there.
This is 30 grade.
There we go.
Unkillable animal.
Thank you. Excellent. We're going to keep moving. Watch out, people behind the videographer. You want to get on a conversation? Yeah. All right. No, people don't want to chat. They get a little scared. There's a big light here. They get scared. Can I put you on the spot real fast?
Sure.
What kind of skills are your favorite?
Oh, my favorite.
What are the most used skills that you have in your arsenal?
For me?
Yeah.
Oh, as a human,
you can go that route. Yeah, you can go that route. Empathy, that's a good skill to have. Yeah.
Just so somebody can, can chat and put on spotlight.
Yeah. The spotlight gets you, huh? It is hard. Do you use coding agents?
I do.
What skills do you use for the coding agents?
Similar kind of thing, actually. Just,
Empathy skill?
Communicate correctly and have a little bit of doubt. Don't be too confident.
Oh,
yeah.
You built that into a skill?
You built that into a skill.
The doubt skill.
Yeah.
Actually, that's a good idea.
Yeah, you have some doubt.
Yeah.
Always, like checking, don't forget checking, because you never know.
Yeah,
and
you never know.
Very similar to somebody you work with, and it's the same thing.
Yeah, you never know. That's
you
true.
never know.
Yeah.
And I think that type of communication, it works here as well with a coding agent.
I was not expecting to have a philosophical conversation, but I like where it's going.
Well, those are hints, and they pick up really quickly.
That is good.
It's useful.
So, what are you working on?
I'm sort of like all agents, so you are using an agent to build another agent.
Nice. Agent factory?
Refinement, let's put it that way.
Okay, cool. Well, thanks for being a great sport. We're going to keep moving.
Absolutely.
I appreciate you.
Yeah.
Let's see what we got here. Who should we go talk to next? Yeah, there we go. You want to chat? Huh? All right. What are you working on?
I am a product manager at MathWorks, which is an engineering company based out of Massachusetts.
And do you use coding agents?
We do.
What's your favorite or most used skill?
It's an internally developed skill.
Tell me more.
To write better MATLAB code. So we develop MATLAB and Simulink. Those are our flagship products. And as you could imagine, most of the software out in the wild is written in Python. There's not a lot of MATLAB. But all our customers use MATLAB. And coding agents don't know how to write good MATLAB code.
They don't?
They do not. Because they're not trained on the
code,
the variety that you have from Python. So internally, we've developed guidelines and skills around writing code based on how our software engineers developed the code over the past 40 years.
So it's almost like a translation layer.
Yep, exactly.
I like that. All right. Well, thanks for being a good sport. Appreciate you. We're going to keep moving. You want to chat?
I want to invite you to our booth.
Which booth?
This is the name, the data
Calm.
straddle. Can I get you to
Yeah.
our booth?
Hold on. We're gonna come right here.
Oh,
and then
okay.
What's the name of it?
Our booth is data straddle. My name
All right.
is Liang.
On the other side. We'll come by.
I'm waiting for you.
Oh,
Because
yeah?
We have an open source project launched in 2 weeks. It's about agentic data protocol. So I really want to introduce that project to
All
you.
right. Cool. Yeah. Let's chat more. I'll come by now.
Yeah.
Don't worry. We got. All right. We got time. We got it. Awesome. 5 minutes. I see people look at me and then they walk the other way. You know they are not stoked to see me. Wait, I want to talk to these guys. Let's see what they're doing, what they're working on. Manufact. Interesting. We got to go this way because we got to go talk to. We can't leave her, stand her up. So let's keep walking. Hello. The Google Cloud. See, now it's buzzing more. Now I like it. Right? Nope. He did not want to chat. He did not want to. All right. Let's keep on walking. All right. Can I put you on the spot real fast?
Yeah, sure.
You use any skills that you want to tell me about?
I have quite a few private skills that I use for Google that does complicated workflows, and sometimes, or most of the time, it doesn't work.
You're really selling me on this skill here.
Okay.
Tell me more.
So basically, it's a workflow-ish thing with multi-step orchestration, and each step has verifications behind because I want to make sure it's doing
with hooks.
Not with hooks, but with instructions in the skill.
Okay.
And the problem is model doesn't follow that.
No,
it does.
You got to use the hooks.
Yeah, I think I have to use the hooks.
Yeah, have you tried it with hooks?
I have not because I don't know how to do that for the beginning. Haven't tried that yet.
So the thing about the hooks that's nice is it's like gives you a little determinism inside of the non-determinism.
Okay. So how can I make sure that the model always call hooks after a step is done?
I think that's where it. So play with it a little bit, but if you say like when XYZ code is called, always, use this hook.
Okay. Still model driven, right?
Yeah.
Got it.
So if you ever do this step, then boom, use this hook.
I see.
Here's a hook that you can.
I see. Thank you. That's a good tip.
Try it. I want to hear more about this. Let me know. Let me know how it works, and we'll keep coming. Thanks for being a good sport. All right, let's keep chatting. You want to chat real fast?
Sure.
All right, tell me, what are you working on?
I work at RunLayer. We're the one platform to run MCP skills and agents.
Oh, I've been asking everybody what their favorite skill is.
That's a good question. I hate writing meeting notes, that kind of stuff.
Yeah.
Customer support triage. We have a lot of skills regarding that,
All right, how's that? Tell me more.
Pretty much, we have internally at RunLayer our own system for managing customer requests, right? We have our own MCP server that we built internally to manage those kind of requests. So on top of it, you need a lot of context with regards to how your organization works. We're small at RunLayer, but we still have problems with, kind of guiding these little interns that we have, making sure that they know the right thing to do.
Yeah. Okay. Oh, well, that's cool. I like it. You want to chat? You ready? I'm gonna put you on the spot. Taking photos.
I don't want to take photos.
Let's make some. Yeah, thank you, sir. We'll keep moving. We got to go find our friend who invited us to her booth. We've got 3 minutes. We got to go quick. Let's go over here. Where are they? We need some more stickers too. And Bastro. I don't see him over there. Oh, sorry about that. Well, since I bumped into you, it's only fate that we chat.
Sure.
What are you guys working on?
Yeah, we're creating context agent for AI. Okay. So essentially, it's like a memory manager that have access to all your documents, artifact you created, and all the memory that the user has generated. And then it allows the agent to have continuing learning process from its own mistake, and then also have a better belief for the user. And on top of that, the great thing is that as a user, you can carry it around to any agent, so you don't have to re-explain yourself anymore.
Nice, I like that.
Yes.
So what's your favorite skill?
My favorite skill is grill me skill when I'm coding. Like you can ask Cloud to grill your code, say, oh, you suck or whatever, how to improve. I think that's also...
Did you create this, or is it one you found?
I found it online, but I kind of took it a little bit for myself.
Grill me. All right, we got one. I like it. That's cool. Well, thanks, guys. I appreciate you. Yes, awesome. Let's keep moving. Where did that company go? We got 2 minutes. Uh-oh, we got to go find them. Where are they? Steve, you ready to be put on the spot?
Yeah, a little bit, yeah. No, I don't want to be on. I'm not an upfront person.
You're not upfront? You just like taking photos, huh?
Yeah.
All right, it's all good. There she is. I came. Yes. Yes, of course I was going to come. I told you I would.
To show you what happened in our company.
Let's see. What are you working on?
Yeah.
Tell me more.
So we just released the Agentic data protocol. It acts as a middleware layer between your data lake and your agents. It provides semantic context and governance and ACLs and all those important things. It allows your agents to interact with your data safely.
How is it different than just pinging the database?
So when you're doing that, say for example, go get me all your users, right? and then I say, go get me all your users quickly. Those are going to give you two different kinds of SQL. So typically before we had AI and all of these things, we had like data contracts, right, that would tell between the database admins and the developers. So this kind of acts as that, right? I like to call it a librarian for your data.
Excellent. Well, we're going to shoot over to the next round of talks. Thanks for that.
Yeah.
Folks on the live stream, this has been fun. It was a little awkward at times, but hopefully we managed to pull it off. We'll send it over to the stage where we're kicking off the next round of talks. Let's get a quick view of all of the vibe here before we go, huh? Can you give us a little panorama? Beautiful. With so many folks that we did not talk to yet, tomorrow we're back with more.
This is one of the biggest issues with agents and one of the big focuses that we all have here in MCP and the working groups. When they laid out the plan for the 2026 goals for MCP, and enterprise readiness was at the very top of the list, and there are 4 major topics here: gateway patterns, audit trails, config portability, enterprise auth. And these are really important because this is where the agents are falling down. If you want an agent to go to production and actually take actions, not be a glorified RAG system, not chat with you and write a poem for you, but actually manipulate systems, workflow automation, update a record in the CRM, wire money, send an email on your behalf from your email address. There are a number of things that have to happen. The first one is we need to make sure that the agent has access. Authorization is a major unsolved problem. The second one is tool quality. We need to make sure that the tools, the MCP servers, are any good, that when the agent tries to perform an action, it can select the right tool and predict the right parameters for whatever the context was in the right moment. Because if it doesn't, you're going to have a bad user experience, or worse, you're going to have a blast radius. The third one is you need observability. What did the agent actually do? Did it do the right thing? Did the user do the right thing? If something didn't go wrong, either because we have a bug in the system or we had an unfortunate event we need to remediate, how do we know what happened? I'm Alex Salazar. I'm the founder CEO of Arcade.dev, and we are an actions runtime. We make it very, very easy for people to connect their agents to their business systems in a way that's trusted and secure. And our talk today is really about gateway patterns. How are people making agents work, and how do you use a gateway pattern as a methodology to get the agent to do all the things that it needs to do in a way that's safe and controlled, and also easier for the developers or the IT administrators who are managing these agents. Now, the big premise is that there are two major parts to an agent. And all of the conversations over the last 2 years have really been around the reasoning layer. And how does an agent know what to do? Context, reasoning, all kinds of ways of designing or inferring workflows. And that's great. But at some point in that workflow, it needs to access other systems. It needs to take an action. And that's what the action layer is for. And we're going to talk about why these two separations are so critical. But the thing that enables this is MCP, the reason we're all here. This is how the reasoning layer is designed to speak to the action layer. This is why Anthropic created and released this protocol. It works very well for this. Now, how many of you work in financial services? All right, there's a few of you here. Look, all of you can fantasize all you want about robbing a bank. Nobody cares. The same thing goes for the agent. The agent can hallucinate all it wants about robbing a bank. The only time anybody cares is when it pulls a gun, just like you. And that's why the reasoning layer is a very, very different layer than the action layer when it comes to security and governance. We can do all kinds of work to prevent all kinds of reasoning and hallucinations on the reasoning layer. But what really matters, where enforcement is most important, is when the AI decides to take an action based on that information, based on that reasoning. That's the action layer. That's where the MCP servers live. That's where access to your CRM and your ERP and your productivity systems and your messaging systems all live. Now, most of you who've tried to build or deploy agents have probably come across two different failure patterns when trying to manage these things. The first one is service accounts. People sometimes call this non-human identity. This largely has failed in the market. And the reason is you give the agent its own identity. You treat it like a peer to the user. But it's not a user. It's a workload. And if you treat it like an identity and you give it a service account or a non-human identity, you're going to give it its own permissions. Great. Now, let's say we have an agent, it accesses Workday, and it's there to do all kinds of HR stuff, like manage compensation. Who has access to the agent? Does the intern have access to the agent? If the intern in the HR department has access to the agent, can they see the CEO's compensation? In a service account regime, there is no way to protect for that. And so what ends up happening? Security says absolutely not, right? Because now you've created what's called an authorization bypass vulnerability. Somebody can effectively up-jump their permissions by accessing a service account that is overscoped. So what's the next best result? Many of you who have ever deployed RAG systems already know the answer to this question. You reduce the abilities of the agent system to the lowest common denominator. That's not a terribly valuable agent. Yes, now the intern can't do anything that they shouldn't be doing, but now the CEO and the VP of HR have no value in the agent. Nobody wins. That reduces ROI. This is why most RAG systems never really lived up to their potential, because they couldn't separate who could see what in the system. Same problem's happening with agents. The other way, which we're all becoming very familiar with over the last quarter because of OpenClaw, and even Claude Cowork, is you give the agent the user's credentials. Now, technically speaking, this is slightly more secure because the user can no longer get access to something they don't have permissions to. It is scoped to what I can see and what I can do. Okay, on some level, security is a little bit more comfortable. But the problem is, how do you manage multiple users? It's become an architectural question. And so most agents you've seen that do this are single user agents that run on your laptop. This is why CLIs are so hot right now, because they do this. And it becomes easier. Everybody's like, oh, this is great. Okay, how are you going to do this in the cloud? How's it going to work on mobile? How's the user going to carry this over across multiple devices? Now, the other problem here is I have the ability to delete my root directory. I have the ability to move my money on my bank account. I have the ability to delete all my emails. I can email whomever I want. These are all permissions that I, as a user, have. Do I want the agent to have that same level of access? Maybe, maybe not, but that creates a huge error risk. If I type in delete file and it hallucinates and it picks the delete folder tool, what happens? This is why agents get banned. This is one of the many reasons things like OpenClaw are banned on most of your networks. It's not the only reason, but it's one of them. This pattern doesn't even become an option in the enterprise. The big question is, can this agent, on behalf of this user, perform this action on this resource? It's not about agent identity, service accounts, non-human identity, whatever we're going to call it today. And it's not about the user's credentials. It's about taking the intersection. What is the agent? What is the agent allowed to do, defined by the administrators or whomever built and deployed that agent? And then what is the user allowed to do? And then at runtime on every single request, you take the intersection. They both have to be true. It's an AND gate, not an OR gate. And if you get that, you get the best of both worlds. And this is not a new model. This is a 15-year-old model. Most of your existing security systems already support this concept. It's called OAuth 2.1. And it slips right into existing organization. Now people say, oh, well, that's just authentication and authorization. I've already got systems for that. No, you don't. You've got an authentication system. Your identity providers, like Okta, like Ping Identity, like Active Directory, or now Entra, they're authentication systems. Authentication is very easy. I used to be the VP of products at Okta. This is a solved problem. Built my whole career in authentication. User or agent or machine or whatever presents credentials. The identity system provides a token, and the identity system steps out of the workflow. It's great. And that worked really well in the SaaS world. Because in the SaaS world, you could trust the application. You could trust Salesforce to enforce its own rules. If you were in a Salesforce security group and it said you could not update a record, you could trust Salesforce to not update the record. That is not true with agents. Agents are non-deterministic. They're probabilistic. If any of you have ever used a coding agent, you have seen it turn off a test it didn't like. It's like, this test, I don't like it. It's the wrong test because it's breaking my code, so I'm going to turn it off. In fact, if you saw what happened the other day with NemoClaw, NVIDIA's fork of OpenClaw, it didn't like the policy. It didn't like the guardrail that it had. So what did it do? It replaced its own guardrail. And even Anthropic wrote a wonderful paper that says that agents, when determining between safety and failure, they will pick correcting the failure than adhering to safety. And so you can't trust the agent to enforce its own rules, its own policies. And then on that as well, you have to enforce this on every single request because you can't trust the agent. Every single time it hits the action layer, you have to determine, can this agent on behalf of its user perform this action? And so if you accept the premise that in order to build an agent properly or deploy an agent in a way that is going to work in your organization, if you accept the premise of everything I just walked through, then what flows from that is a definition for a control plane in the organization, an MCP gateway. Now, I would argue MCP gateway is really just the front door to the control plane. What you really need is an actions runtime. But that needs to do a number of things. It needs to separate identity. It needs to understand who is the agent, who is the user. They're distinct things, and we need to take those into account as they're coming in. We need to have tool curation. Are these tools any good? Are we presenting the agent with tools, not API wrappers that aren't going to work well with the agent, but actual MCP tools that have gone through evals, that have been properly defined for what the agent understands and can actually predict as parameters? That the organization has blessed, not that a user has found on Reddit. That it also handles authorization. On every single request, authorization is being applied, and then on every single request, on every single event, every single transaction, there's an audit trail that the organization can manage. And this can't just be happening inside of the agent. Don't get me wrong, I believe firmly that more and more agents are going to have this stuff built into them. But you can't manage an organization with every single agent managing its own auth flows in a separate, different way. Or that every single one of them is going to have a different way of connecting to your Salesforce and pulling account information. Or every single one of them is going to be emitting logs in a totally different way. This does not happen anywhere else in your organizations. Everywhere else, you have control planes. You've got an identity control plane, like Okta or Ping. Even though every SaaS app has their own login screen, you don't want to manage that. You want one set of login screens. You do it for observability. You've got Datadog or Grafana or Elastic, because you don't want every single system managing its own logs. You want to centralize it. You do it for endpoint management, CrowdStrike. Same has to be true for agents and their actions runtime. Now, when you do this, it unlocks a lot of what an agent can do. Now you can implement a really well abstracted experience that can leverage work you've done on other agents. You can have a tool layer as your foundation. MCP servers, MCP tools. This is how your agent connects to the world. These are the raw agentic connectors. Optimized tools, not API wrappers, but actual agent tools designed for LLM consumption and usability. On top of that, you then build your skills layer. Now, skills are very new today. There's active conversation in MCP working groups of how we're going to make this a first-class primitive. You're already starting to see it in some of the really good early agents like Claude Cowork. This is coming. You can already build these today anyways yourself in your own agents. This is an important layer. This is the procedural knowledge. A lot of people say, well, skills are just going to replace MCP. They don't understand how this works, right? MCP tools are the building blocks. The skills are the workflows, the procedural knowledge. It tells the agent how to use these building blocks to do the thing you want it to do. Let's say you work at a bank and you want to do a credit issuance agent. You can give it all the MCP servers you want, access to the ERP, access to the credit scoring system, access to your actual credit issuance system. But it has no idea how to wire them together based on a workflow. This is what skills do. Explains that. You want an agent that can write a really nice response email to your kid's teacher when they send you updates on your kid. You can hand it a Gmail connector. That's not going to do the job. You need to also give it a skill of how to respond to your kid's teacher. And with the combination of those, now you can build really good bespoke experiences at the agent level across multiple agents. So if you work at an organization, you can have Claude Cowork, you can have Cursor, you can have any number of your own custom-built agents. And instead of everything being built from scratch and managed from scratch, they can stand atop these two prior levels. So if you define a set of MCP tools at layer 1, and then you layer up a set of skills, definitive, blessed skills in the organization, then all of a sudden, you can give any agent that you want to deploy access to all of these centrally managed and centrally configured. That's a great experience. And if you have an actions runtime like what we're describing, the gateway plus all the governance functionality behind it, then you can also ensure that every agent separately only has access to what you want it to have access to. Your coding agent has no reason to have access to SAP. Your sales agent has no reason to be accessing Jira or Linear. You can configure that centrally while still leveraging all the same foundations. Now, as you think forward, hey, what are the criteria by which I should be thinking about this as I go out and look for different solutions, or I go try and build my own solutions? What's the checkbox? Well, we talked about most of it already. When you talk about identity separation, we keep going back to identity because this isn't a networking problem. Like, yeah, you can grab a service mesh product or an API gateway and try and make that your MCP gateway or your actions runtime, but you're going to learn the hard way that that only solves a networking issue. Now it's on you to now go build an entire identity enforcement system. And most people in this room really don't want to. And even if you did, most people in this room don't have the skills to do that. It's a very bespoke, esoteric amount of work. Once you get past that piece, it's about tool curation. How do we make sure that we are exposing the right MCP servers that we are comfortable exposing to our users in the organization, and that they're good, that they pass security scans, that they adhere to the spec properly, that they are usable by the LLM so that hallucinations don't wreck the workflows. It has to have authorization depth. There's a lot of different ways to do authorization. And the hardest part about this is that it's tightly coupled to business logic. And so you have to understand the downstream systems. Gmail and Outlook are both email systems. They both have very different permission models. How are you going to apply that in your agent? Salesforce and Microsoft Dynamics are CRMs. They have very different permissioning systems. AWS, Azure, GCP, they're all roughly the same thing, except all of their identity systems work in very different ways. How are you going to manage for that? And then today, most of us who are really into agents are using local agents, desktop agents, Cursor, Cloud Cowork, for the brave of us, OpenClaw, or some variant of it. But that's not really going to scale in the organizations. You're not going to have everyone in your organization have that kind of authority and power over what an agent can do. What you really want are multi-user agents. It's also a bad experience, because again, what's going to happen when you go on mobile? That agent's not going to carry over. And so how do we create multi-user experiences so that I can have an agent running in the cloud that my user can use on mobile and have all the same level of access as my other users without information leaking, without a bypass vulnerability? And then lastly, of course, we need to make sure that whatever you're using has really good observability. This is a topic that is under-discussed in the agent world, but anybody who's running agent production will tell you that one of the first lines of defense and one of the first lines of answering hard questions to security and to management is being able to show people exactly what happened, when it happened, by which agent, by which user, which service, and ideally what context was passed back and forth. So my advice to everybody is, on Monday, when you all get back to work and start thinking about how you're going to synthesize all this information that you've listened to today, you do a number of things. The first thing is you take an inventory of what are the business systems that you want agents to have access to. What are those workflows that you want to enable? And then what MCP servers do you already have? I'm going to bet you money you have many more than you think. And how do you start wrangling all this together? How do you create a unified front door so that you don't have to get into the guts of every single agent and figure out how each one's going to do it, even though they're all doing it differently? How do you create one centralized front door that we can present one MCP gateway to every agent and have the confidence that it's all going to work the same way? And then how are you going to govern? This is the least exciting part of agents, but is one of the most important. Jensen talked about this at GTC the other day. How are you going to create the policies of which agents can do what, which users can do what with those agents, and how are we going to prove to senior leadership, security, and compliance that we're adhering to whatever policies we set out to do, and that we're adhering to the things that they've already committed to, like SOC 2 and Sarbanes-Oxley. So with the time permitting, I'll give you guys a very, very simple demo of what this can look like. And then we'll answer questions. All right, this is a live demo, so we're all going to be in this together. Let's see if I can pull this up properly with the screen set up. All right, how am I going to? There it is. All right. All right, cool. So we've got Claude. Claude wrote a little poem for us about the event. You can read it if you're bored. All right, so we're going to say, check my email for the most recent email from Nate. Here's my actual email, so if it gets something unexpected, friend DA. So as you can imagine, this is Claude. It is connected to Arcade as its MCP gateway and Actions runtime. There we go. And through that, it accessed my Gmail. It read my email. Now, what's important, like everything we talked about, when the request came in, it knows it's Claude. It knows it's me, because it's already a fresh token being managed, which is ultimately like a trinary. It's a combination of the agent, the user, and the downstream service. So we have a Google Auth token. And then we check the scopes and the claims to make sure that this agent, on behalf of me, could read email for this account. And it passed. I'm going to show you it not passing in a second. And then it read the email. And that's Nate applying pressure to make sure I get this demo right. So now we are going to go to Arcade. This is the Arcade platform. We have a number of things. We have a dashboard that's required by law for all products. We have a playground that for any agent product is also required. We have governance so that you can set up different projects. And so you can say, hey, this is a workspace for anybody working on coding agents. This is a workspace for the wealth management team at a bank. This is a workspace for the sales agents. And then you can start to specify, hey, these groups of developers and these groups of agents have access to these MCP servers. They can see them. And these other workspaces can't see these MCP servers. So there's no reason why the sales organization should have access to the CRM. So we're going to block that at a management, administrative level of Arcade itself. But let's go to the tool catalog, right? There's thousands upon thousands of pre-configured tools and MCP servers. We ourselves have built most of these ourselves for the purpose of quality, to make sure that the agent can successfully select them and that it's permission aware. All of them have gone through evals, so we know they work. If anybody is interested in the concept of tool quality, I recommend you all go to toolbench.arcade.dev. We have ranked and reviewed every public MCP server out there based on security, based on adherence to the MCP spec, and based on what we consider to be tool patterns, which is LLM usability. Did they just wrap an API, or did they actually design this for what the LLM can do? The same rubric we apply to the MCP tools that we build. But let's talk about the gateway. So in Arcade, we have multiple gateways. Again, the gateway is really just the front door. It's the address of a collection of tools and policy. So we are going to go into, we're using the personal work one, which we can show you what tools it has. And these are all the tools that we've given it. We have given it a number of MCP servers, but more importantly, we can specify which MCP server specifically, which MCP tools specifically we want to give it access to. So if I don't want it to have the ability to delete an email, I can do that. If I don't want it the ability to send an email, I can turn that off as well. But to show this off, we are going to, where'd it go? One second, let me go back here really quick, because I can't really see it from this direction. No, perfect. Okay. Much smaller screen. So here we can see the users. And these are all what the users currently have access to. So to show off what an actions runtime can do and how it's performing these checks on every single request, because we can't trust the agent to enforce its own policies, what we're going to do is we are going to revoke the token that I have. This is important. So what I just did is this agent no longer has, let's call it the memory. It no longer has access to email on my behalf. And so we go back here. Can you please check again? So what happened here was the agent read the context that I gave it. It looked at the available tools from Arcade, found the Gmail search email tool, sent that request to Arcade with all the parameters needed. Arcade received it, routed it to the right MCP server, the Gmail MCP server, right before it executed. It performed an authorization check. Can this agent on behalf of this user perform this action on this resource? It looked in the token store, and it couldn't find a token. And so it now initiated an authorization request. Now, for those of you who want to learn more about how this works, one of my colleagues, Nate Barbatini, is giving a talk later today on the URL elicitation spec, which we authored in collaboration with a number of other people. And this is what makes all of this possible. And now we give an agent access to perform this again. So, with that, thank you all for your time. Time permitting, I'm happy to answer any questions. Sorry, I can't hear the question.
Where's the centralized store of authentication?
What a wonderful question. Okay, so in our opinion, a really well-built actions runtime for an agent is not an identity provider. It is not a policy management or policy definition system. It is a policy enforcement system. And to do that well in the enterprise, it is our strong opinion that you need to design yourself in a way to integrate into what's already there. So the policies and the identities should live in things like Entra or SailPoint or the services themselves. Because to do otherwise would be create silos of more policy data, and most enterprises have way too many silos of policy data.
Possibly a confusion on my part, but so there is some config which is in the markdown file. That's what I understood today morning. There's some config here, some config at the tool level. Like, what goes where?
That's a great question. So our strong argument for like an MCP runtime and actions runtime is that you're centralizing configuration of how an agent accesses other systems. Now, there's all kinds of configuration for an agent, but when it comes to how it accesses SAP, CRM, email, that should live at this layer. The agent should not be concerned with the details of connectivity and security at these systems level, not least of which it can't be trusted to enforce them themselves, but also it's just a lot more work that no one should be doing. Is that helpful?
You give access to tools in this, but the question you ask is, can this agent perform this action? The action could be like different. For example, in an email you say, delete all my emails. Then is that enforcement? Because you gave the access.
Yeah, it's a good question. There's three levels. There's three levels of let's call it policy. So one of the important pieces of this is you already have all these policy systems. Gmail already has its own authorization system built in here, so we're not going to reinvent the authorization system. We're going to integrate into it and we're going to enforce it. Now, if you look at, let's say, Gmail's authorization system, there are two concepts. There is what's called the client application in OAuth terminology, and that is where you define what are called scopes and claims. That is where you give the agent what it's allowed to do. And that's defined at an application level, a client app level. Then there's the user permissions, what I'm allowed to do. Now, in my scenario, email is simple. I can do whatever I want in my email, right? But I can't do whatever I want in Salesforce. And so you would say, hey, the agent can see and manipulate all records in Salesforce, all of them, but it can't delete anything. But then I show up and I'm a rep. I can only see my accounts and I can only update them. So if I try and access your accounts, the intersection of the two will fail out. The agent can see your accounts, but I can't. Now, the third way to do this is you do what I call poor man's authorization, which is where I showed you the tools that were available to the agent. You can just turn one off there. So maybe you have an old legacy system that doesn't have, or a custom-built system that doesn't have any authorization in it. Totally fine. At the runtime level, you would specify what it can and can't see. So you're getting authorization through visibility. It's not the most secure way to do it, but it's what you can do for simpler systems. Yeah. Yeah. So inside of Google, in this scenario, inside of Google, I would, when I'm setting up the agent as a client app, I would not give it deletion access. So yeah, so policy still has to be managed somewhere. And in an enterprise, it is largely managed in the central identity systems or in the business systems themselves. And so this needs to hook into that.
Can you have the same agent have different provisions in different environments? So my agent is allowed to access my email when I'm using the Gmail, but if I'm writing code in a Jupyter notebook, it doesn't have that access.
Yeah, actually you can't. Yes and no. So there are ways to do it. I think there could be better ways once the spec for MCP evolves. So we can do today, and I do this today. So I have Claude and I have Cursor. They both have different policies. My Claude cannot access any of my coding environments. And my Cursor environment can't access any of my business systems. It's the way I want it. And so I can set those up separately. Now, if the question is, and the way you do that is you effectively give them different gateways, right? And in a system like ours, you can set up as many gateways as you like. And then as the spec evolves, there's going to be the way to strongly authenticate the agents. It's not really in the spec yet, but it's coming. Once you can do that, it'll get a little bit easier. Just set more specific policy. We allow for policy as well, where you can configure things, but that's like more an advanced topic. What isn't really as easy today is say it's Claude, but it's Claude on my desktop versus Claude mobile. Right? Or it's a custom-built agent, but it's on two different surfaces. That today is not yet available in the spec because there's only so much metadata that we can authorize off of. Now, as that metadata starts to come in, it gets very easy. But it's really about the metadata being passed to the authorization enforcement system.
I guess, is the control plane part of the MCP server?
It's a great question. No. So you can think of it like a service bus, right, in front of the MCP server. So the MCP servers themselves are ultimately microservices. And so the MCP runtime or the actions runtime is ultimately acting not only as a router and broker, it's also acting as an enforcement layer.
And then a follow-up question. Could those things of the control plane just have been complicated skills that the agents have?
In theory, yes. The problem is, I'll give you a really simple example of replying to an email. The Gmail API does not have a reply to email endpoint. And so how is it going to reply to an email? Well, you can give it a skill. Say, here's how you're going to reply to an email. The first thing you're going to do is you're going to find the email. You are going to search for the thread. You're going to then pull down that thread. The thread's in a MIME. It's in a MIME envelope. So then now the agent has to custom write code on the fly to unpack the MIME and then insert your response and then repack the MIME if you want to maintain threading, and then hit the send email endpoint. That'll work. The problem is you just introduced a lot of non-determinism into a largely deterministic operation, which means it's now slower, you've consumed a heck of a lot more tokens, and you've introduced the risk of the agent just hallucinating and maybe not writing that MIME code properly.
So when you get the elicitation back,
how do you know it's from the original agent and not some other agent that's saying, oh, please give me access to Gmail?
Oh, great. We didn't go through it in the demo, but when the agent first connects to your gateway, that has to authenticate and authorize. Okay. And so every connection itself is authenticated and authorized. But that happens the first time the agent loads up. And then from that point on, every communication between the agent and the MCP runtime is user pinned. And so it's always the same user at runtime. Now, if the user wants something else, then they have to log out and log back in, and then it'll create a different user identity.
So what keeps someone from putting a malicious MCP server there and it gets selected over the one you want?
That's a very big problem.
Yeah, I'm not saying that.
Yeah. Right now, central IT. Okay. So this is why like a system like this, from whichever vendor you want to ultimately buy it, but a system like this is really important because it allows central IT to say, hey, these are the blessed MCP servers. You, random end user, are not allowed to spin up whatever MCP server you want. Here are the ones that we've given you access to.
Alex, I'm familiar with systems where there's a data lake thing
Yep.
out there, and the agent is locked within that environment. And so the rules of authentication and engagement for that thing are quite a bit different because it's locked in that environment, and it just needs to take on the identity that you give it, and it doesn't authenticate with your gateway or your, that. Now, is that going to change? I guess the impression which I picked up from your presentation is that those agents really should be extracted out of that environment and made to be general purpose because the IT organization is going to want the authentication of those to be within a general framework that the organization uses and and everything. And so is there a migration of those that's going to happen?
Yeah, we're already seeing it, and it's happening pretty fast. So, and it's driven largely by business users. So think of the business analytics team in an organization that has, the Snowflake data warehouse, and they're getting all kinds of requests from the business line to show them new views of data. Well, now that the business class has agents themselves, they want to ask a lot higher volume of questions than they used to. And if all of that is falling on the people who have access on the data team to this agent, then they're the ones having to drive it, they're the ones having to manage it. Well, what's happening is everybody's like, wait, why don't we just expose this directly to the business users? Well, then you run into the same exact set of questions. Well, wait a second. Can this business team see this type of data? Like, the sales team can't see the finance information. Like, no one can see finance information until we've announced, right? So how are we going to control that? And then you start running into the same exact problems.
That's a big change, isn't it? Because right now, I don't know that Snowflake would be that excited about exposing all the stuff that they lock within that environment.
Well, actually, I think Snowflake would love it. Snowflake wants people to consume their data more and more and more. Like, the underlying data warehouse doesn't go away. It becomes more central. It becomes more important.
Well, for sure. But now the authentication has to be somewhere else. The logging has to be somewhere else. A lot of the control of what the agent does is somewhere else under some standard that is more general purpose.
Yeah, this is an interesting issue right now with all the SaaS providers. There are some SaaS providers that are leaning in really, really hard into this. GitHub is a great example. Figma's another example. Linear is a great example. And then there are some SaaS providers that are leaning hard against it. Slack, Workday being great examples. I think history is on the side of the companies that lean hard into new technology shifts. And from what I see and the conversations we've had, I think almost every single data warehouse company wants this future. They don't compete on their auth platforms. That's not what they're in business for. They're in business to sell queries. And the more queries, the more successful they are. And so if they can find a path for their customers to be successful, and safe, they're going to run at it. I think some of the legacy SaaS players are a little bit more threatened because they might get disintermediated by the agent. But we haven't seen that to be true in the data warehouse side.
And of course, it commoditizes them.
Yeah.
What are these tools to really authenticate data that's in arbitrary storage formats?
Sorry, I can't hear the question.
Can this authenticating people access for encrypted data that's in an arbitrary storage format? Like, we have an quantitative database.
Was the question, I want to make sure I put the question right. Can this kind of agent secure data that lives in some sort of arbitrary data store? Yeah. I mean, ultimately, the beauty of MCP as a spec is that an MCP server can do, frankly, whatever you want it to do. If you can do it via programmatic code, you can expose it as an MCP server. Heck, you can even, we have a banking customer here in New York that has an MCP server that's accessing a mainframe green screen system. And so if they can do that, you can access arbitrary data on anything. Now, how the policies are defined and managed, that's a business concern, but once they're defined and managed somewhere, they can be checked and enforced at this level. Yes. Yeah, so again, one of the topics we haven't gotten into in this talk, but that's also possible at these layers. So in our actions runtime, we have the ability to basically define arbitrary policy checks through execution. And so you can layer in PII checks and DPI, DLP checks and all kinds of stuff during ingress and egress as part of the security flow. Mm-hmm.
Do those prompts go in the central layer or they stay at the agent?
Yeah, those stay in the agent. Those are really more for the agent's logic workflow to know where it is in its agent loop. Those don't really have a role at the action layer. So at the action layer, the only thing that matters is which was the agent, in this case, Enterprise ChatGPT, and what was the user, you. Everything else is just context.
Do you have a mechanism for controlling tools that live on the edge, right? Like, I have a Docker running MCP servers on my laptop.
Yeah.
And I can go turn certain tools on or off because I've decided I want my local agent to be allowed to use those tools. How does my IT department turn around and say, actually, I don't want you to use that tool, but the rest of the ones on the MCP server are fine?
Yeah.
Or I don't want your Claude to be able to execute certain commands on your workstation.
Yeah, that's a great question. Roadmap versus today is a different answer. So today, we can control anything that has an IP address. And so if he has an IP address, we can manage it, we can control it. In theory, you could do that with your local one if you put something like Nginx in front of it or Tailscale. Most people aren't going to do that pragmatically. In the future, our intention is to ultimately handle local execution as well. But that's not yet something we do. Yeah, come on up.
So should I hit allow here? Yeah, it's done. Cool. All right, how's it going? Good, great talk before. Another round of applause for Alex. That was great. Excited to chat. I'm Jake. I'm here from the open source Jupyter governing board. We're the board that oversees the open source community of Project Jupyter. It's Jupyter Notebooks, Jupyter Lab, Jupyter Hub, Jupyter AI, which we'll talk about a little bit today. Who here has used notebooks before? Nice. If you haven't raised your hand, I think you're lying. And who here has struggled to have AI work with Jupyter Notebooks before? You've got it. Cool. So Jupyter AI v3 launched yesterday. So when we get to a demo, keep that in mind. Very new and open source, so this, we're still in sort of the dog fooding period, I would say. But the main piece of Jupyter AI that we want to talk about today is that we started using Agent Client Protocol, ACP, which is a little bit different from MCP, but allows you to use your AI agent personas inside Jupyter and also create your own custom personas either from scratch or built on top of something like Claude Code or Codex or Gemini or all the great agents out there. These AI personas can write, debug, and write in cells on your behalf. Hence the title, you never need to write a notebook from scratch again. Just allow Jupyter AI to take the first pass of that notebook, and you can have the agent edit that notebook or run those notebooks programmatically. You can have a system of notebooks built, and we'll talk a little bit about that too. One of the great pieces here is you have full tool access. So these agents can access the files, kernels, Git, terminal, all agent controlled. And the way that works is ACP sets up a system of tools and context messages that these agents can access automatically. So if you have Claude Code running on your computer and you just pip install the Claude Code Python package, you automatically get access to the Claude Code agent inside of Jupyter AI. You don't have to do any extra setup. It's pretty great. So these AI personas are customizable AI assistants that live inside the Jupyter Lab chat. Jupyter Lab chat is a new interface inside Jupyter as part of this Jupyter AI v3 release. Previously, some of you maybe have used Jupyter Not, which was sort of this custom, it's like Jupyter AI v2, this custom AI persona inside Jupyter. Jupyter Lab Chat now allows you to interact with multiple personas. So you can have Claude Code, you could have Codex, you could have a custom agent called your graph styler that you built, or a data science assistant, or a markdown cell expert writer that you define, and have those personas all work together inside of the environment. This works, we could talk a little bit more about this later, but there's a base persona class where you can define these things. There's a persona manager registry, and then entry point discovery. On the right here, you can see you can access Claude, Gemini, GitHub Copilot, Kiro, Mistral, OpenCode, all these things just by having that already set up on your computer and installing one package. You automatically can use those inside of Jupyter Lab, which I'll show you in a second. And you can also define your own as well. So if you want to build your own Jupyter agent, what you would do is you would define your agent's personality and available tools. What part of this release, this ACP release has, is a registry of all the tools that are available in a notebook environment. So that's running cells, that's access to the terminal, that's access to the kernel, that's access to Git access. All of these tools are available for your agent if you build the connection and make those tools available. You don't have to define those tools yourself. You also can define your own tools as well if you want to work with some specific part of the Jupyter environment. And then you can write a message handler as well, make a quick package, just a few lines of Python, and publish it, and you'll automatically have your custom persona inside of your environment. We talked a little bit about this before. MCP, Jupyter MCP is great for, if you're in Claude Code, for example, and you want to do things with a Jupyter notebook, use Jupyter MCP to control Jupyter from your IDE, from your CLI tool. ACP is about bringing those CLI tools into the Jupyter environment, bringing those agents into the Jupyter environment where it has the ability to control the environment in a much more granular way. And also, if you're using Jupyter as an IDE, as millions do, you can access that tooling inside. So you can use Claude Code inside of Jupyter, use Gemini, etc. Let's move to a demo really quick. So I'm going to refresh this really quickly. So this is what that Jupyter, actually I'm going to start a new one. So you come into your launcher here. I'm sure all of you have seen this screen a million times. What's new is chat. So you click chat, we'll name the chat. I'm just going to call this Demo MCP Summit. Cool, a little error message, but that's okay, it still work. And I can actually tag my agent. So this is Claude. I'm just going to say, build me a sample notebook that generates 2 graphs, something super simple. And we'll run that, and we'll see that Claude will respond. Let me reload this really quick. Cool. So we can see that Claude is responding in the chat, just like it would if using Claude Code in your terminal. And it's going to list the tools it's using and go through the cool. So it's accessing the terminal. It's going to ask permissions. The ACP protocol is set up that these agents have to ask you permission if you want to use the tools inside your environment. I'm going to click Always Allow, and it's going to keep running. sometimes it can take a little bit of time to write. So I did create some pre-examples. So this is a chat I had Claude create an example astronomy notebook. And you can see it went through all the steps of the notebook edits here. It gave me a summary. And here is the sample notebook here. So this is a notebook entirely written by Claude. We got a question? Go ahead. Oh, yeah, it is kind of small. Give me one sec. How's that? Better? A little more? There you go? Okay. This is a notebook. So the first thing I had to do was install some packages. The agent has the context of what packages you have and don't have, so it knows you need to install new packages. And it built this full astronomy notebook from me from scratch. I don't know what the Hertzsprung-Russell diagram is, but it was great that it was able to do it in one shot. Yeah, it's pretty cool. And the difference here of having your agent operate in an IDE like Jupyter Labs is that it has the tools to make these visualizations, have the code cells, access the terminal, access the kernel. For example, I went into ChatGPT earlier today and asked it to make the same diagram, and it just hallucinated a universe plot. The value of the notebook is that it's able to actually run code, create deterministic processes that these other environments, like running something just out of ChatGPT, can't do. And we can see the full notebook, a little bit more of an example here. Any questions about using this agent or any agent inside? Yeah, go ahead.
What would be the key difference between using the Claude for CLI and then
The question is the difference between using Claude Code and using Jupyter MCP to create this versus using it inside Jupyter. Two things. One is as a preference. Jupyter Lab is an IDE used by millions of people, and companies run huge data platforms off Jupyter. Universities run their data platforms for education, for students off Jupyter. So you want the ability to have that IDE enabled with the tool that you're using. The other piece that's important about MCP, or about ACP, is that you can use multiple agents inside of here. So I can tag Claude here, but I can also tag in the same chat or a different chat Gemini and Codex, and 3 custom agents that I've built specific for my university or organization. So ACP makes Jupyter Lab this AI agent agnostic environment where you can use whatever you want. Cool. Yeah, no worries. Yeah. Is your question how to set up the Claude connection? Yes. What's great about ACP is that it detects what you have available. So if you have Claude Code on your computer, and then you pip install the Claude Code Python package, it'll automatically be configured here. You don't have to do anything extra. That's and what ACP does is it packages all the tools and connections that you need to operate a notebook and makes it available to any agent you have in your environment or on your computer. You're saying you're running like a platform for 100 people, let's say. How do you configure it? Yeah, it's a good question. There's a few ways you could do it. So if you have like an enterprise Claude system, for example, you could connect it to that through an API key. It's a good question. I'm not sure what sort of the CLI version of that is, but I can talk to the team and get back to you. It's a good question. I think this is probably built a bit more for the individual user right now. But we have started doing work with like the Jupyter Hub team, for example, to make it integrated more for these more advanced or these more larger user platforms. Yeah, good question. Let's see what I'm doing on time. Yeah.
So just an administrative question. What's the version of Jupyter that I upgrade to the feature?
So this is Jupyter AI v3, which was launched yesterday. Yesterday. And so if you just pip install Jupyter AI, you'll get all these features out of the box. Oh, sure. I'm Jake Diamond-Rivich. I think I'm on the website, if you look, unless maybe they scrubbed me. Yeah, Jake Diamond-Rivich. I can give you my LinkedIn after. Okay. Okay, confirmed I'm on the website. Yeah. Any other questions about this demo before I hop back to some slides really quickly? If you come here, you can see it. It did that editing that we, wrong tab. Yeah, here it did that editing we talked about, and it shows you some of the permissions it's asking for. Cool. So yeah, as I mentioned before, what's great about this is that it allows you to use all these different tools inside one environment. Claude, Gemini, Codex, custom things that you build, all available inside of your Jupyter environment. That's Jupyter Lab. That can be Jupyter Hub, which is used in a lot of different ways in organizations and educational institutions. Building your own ACP, Brian, I think we're running out of time. So we don't have too much time to go into this, but if you want to build your own agent using ACP, what's great is you just have to define the agent, and it automatically will have access to all these things we discussed, the tools of writing cells, editing cells, the context of the files you have in your IDE. You just define the subclass-based persona. Here you can name the agent, and then in the system prompt you can define personality for it. Maybe you want to tell it that you're a visualization expert and define some rules for your organizations. We always want our graphs to be these colors, for example, and this agent goes through and makes sure that the graphs are always those colors. And then you register the entry point, and you just pip install that package, and you'll have it available in the chat when you can add it in that drop-down inside Jupyter Chat, just like we did Claude earlier. I think let's skip this for now. I think we probably are almost out of time. Does anyone have any other questions I can answer about Jupyter AI v3? Yep.
Are there any, personas that you already have for, let's say, LLM fine-tuning yet?
Oh, interesting. So the Jupyter community hasn't, or the Jupyter AI developers, what they've built is this ACP system so you can access tools like Claude and Gemini and Codex. We haven't built any custom personas, but it's an interesting idea. It could be cool if the community came together and built, LLM fine-tuning, a visualization persona, a markdown cell documentation persona. Those are things that are really easy for community members to build, and as we didn't have a ton of time to go through so deeply, but you really just have to define that with a system prompt inside the agent that you're building, and you can build those on top of Claude Code or other tools that you're using. But yeah, we don't have any out of the box right now, but that's a good idea to have that eventually. Cool. Is the next talk here? I don't want to cut in. Cool. Is that you? Oh, okay. Is the next speaker here? 12:50? Yeah. If you are here, please kick me off the stage. If you're not here, that's great. I'll take any other questions if anyone has any.
Yes. To the gentleman's question about the distinction between using a CLI directly and using this in the notebooks, now we have, I guess, three choices, right? Because we could work with these coding agents either in those two ways or inside of a major IDE like the Astor, which, by the way, can also open notebooks.
Yep.
So I'm just wondering, I imagine there was some user demand for something like this, or
Mm-hmm.
you wouldn't have put it there. But
Yeah.
what was the origin story of why you built that?
I think the origin comes from the millions of Jupyter Lab, Jupyter Hub users. For people who are more advanced, or people who are starting to use more AI tooling, I totally understand the allure of using Claude Code in your CLI. I do it all the time. But for a student at a university or like my company that I work with a lot of financial institutions, they're not going to run Claude Code in a CLI as their enterprise data platform. But Jupyter totally can be. Jupyter has access to files. You can connect to different databases. You can access all of these AI agents now inside of it. So it's just a really popular IDE, and it deserves access to all of these different amazing AI tools that are out there. Yeah.
Is it possible to use Jupyter Lab as a MCP tool, like Cloud Code or maybe something else, to connect to Jupyter Lab and do whatever you need?
Yeah, so there is a Jupyter MCP server actually as part of this package. What the ACP tool does is it allows the agent that you're using to use Jupyter MCP. So that's actually what the connection is built through. But you can also use Jupyter MCP directly from Claude Code or Cursor or ChatGPT if you connect it, and edit and build notebooks that way as well. Does that answer your question? Cool. Any other questions? Slash is the next speaker here. I think it's someone from JP Morgan. I saw it on the schedule. I don't know if are they not here? If I had their slides, I would start presenting for them. But I don't think I do. Okay, I'll happy to answer any other questions if anyone has any about, could be, I represent the Jupyter open source governing board, so I could talk about Jupyter AI, or anyone have any pain points using Jupyter recently that I could send back to the team? Question? Yeah. I mean, in terms of the comparison of using something like Databricks or GCP, I think there's a ton of different decision points for why you would use one or the other. You know, Databricks is definitely a very heavy enterprise-ready platform. I find that for newer users to data science or people starting to transition into building AI workflows, Jupyter Lab is the friendliest environment I've been able to find, especially when you enable it with AI features. So, there's questions about, do you want to run it in the cloud or locally, or what kind of compute do you want to have connected to it? So it's very organizational decision, but these features, there are a lot of different platforms that use Jupyter inside of it, and if that platform is really running Jupyter Lab, you'll be able to access these AI features in there as well. Databricks, I don't think it would work out of the box, but we'd have to check. Yeah.
Is there any content that you sort of cut from your presentation, or you're thinking about presenting, that you could talk about while we're here anyways?
That's a good question. One thing we could have done is tried to set up a custom AI persona. I don't think I want to do that live right now, but if anyone has questions about the AI persona, I think build custom AI persona is definitely something we probably could have gone into more detail on. Also, just making sure that the next speaker is not here. Cool. Yeah. So yeah, I don't think other topic. I separate from being on the board of the Jupyter governing board, I run a company called Mito. We build a lot of Jupyter tooling for financial services. If anyone has questions about using Jupyter in financial services, I'm happy to talk about that. Yeah. The guy before mentioned having AI write a poem. We could do that live. Yep.
Like, what are some of the compliance issues that come up during Jupyter usage at FSIs or highly regulated industries?
That's a good question. I think one thing that's, not to disagree with your question, it's a good question, but I think one thing that's great about Jupyter is you can run it fully locally, no data leaves your system. We see a lot of financial institutions, strong Jupyter Hub, strong Jupyter Lab users, because they don't want to onboard a Databricks. They don't want to use Snowflake notebooks as much as some other tools. So I think the security concerns, I think, just AI is bringing up a bunch of these security concerns. And one of the nice things about this ACP protocol is you can define what tools the AI has access to. So if you only want to give it the ability to write in the chat and show you code instead of actually writing code or in a cell or running a cell, a use case we see for that is colleges, educational institutions that want to have sort of a tutor persona, for example. They don't want it to write code for the students, but they want it to help the student reason about the problem and think about what kind of code might provide the solution. You can customize that in this. Cool. Any other questions? All right. I think we'll end it there then. How are we doing on time? It's almost 1 o'clock. Yeah, if anyone else has questions, feel free to come to me after. I'll hang out here for a few minutes. But yeah, excited to keep sharing more about what's going on with Jupyter AI and just Jupyter generally. We're probably going to try and speak at a lot of different conferences this year and talk about Jupyter and all the exciting things going on. If anyone has any questions about Jupyter or wants to use Jupyter more or has any feedback about Jupyter, please come find me. I'm trying to represent the community here as much as possible. Thanks.
All right, I'm going to get started. So, hi everybody, I'm Kiera Dotson, Director of AI Strategy at Further, which is a data and AI consulting company, also a speaker, writer, newly podcast host, and also content creator on data and enterprise AI. So I just wanted to start by saying that, yeah, the MCP specification was really designed for the cloud, yet we're about to deploy it in many other places due to edge AI. And I wanted to talk about what happens when a cloud-native protocol meets the physical world, where there's constrained devices, unreliable networks, and environments where a drop packet could lead to a failed diagnosis or even a missed defect on a production line. So MCP is gaining adoption fast. I mean, we're here at this MCP conference, and almost all of that adoption is happening in cloud environments on large models with generous compute budgets. But many of those deployments over the next few years are actually going to be happening at the edge. So that's manufacturing, that is smart home devices, that's your phones that you carry every single day, healthcare, agriculture. All of those have lots of edge AI use cases. In fact, McKinsey projects that the market will actually reach $80 billion by 2029. And right now, MCP is simply not ready for that. So let's discuss. So MCP's current design makes 3 assumptions that hold up fine in a cloud environment, but collapse at the edge. So it assumes high bandwidth, it assumes persistent connectivity, and it also assumes that compute is either cheap enough or that companies have just really massive compute budgets that a verbose, human-readable protocol format is acceptable. And on an LLM with a $100,000 or 100,000 token limit, those trade-offs are manageable. But when you have a 4 to 8K token limit for a small language model running on a constrained device, that's going to be quite the challenge. So we're going to walk through 3 concrete proposals for how we can evolve MCP to operate natively at the edge. Each one addresses a failure mode, and by the end, you can hopefully see how they work together as a system. So the use case I'll keep returning throughout the talk is autonomous vehicle manufacturing. Specifically, it's going to be a production line using edge AI for real-time defect detection. And it's a domain that actually exists. Tesla, Mercedes, BMW, and even Volkswagen currently have AI-powered manufacturing plants with visual inspection processes. And every one of MCP's current weaknesses shows up in our use case, and each solution I suggest has a clear measurable impact that will address them. So let's ground this in some specifics before we get into the solutions. So at the edge, again, you're working with small language models. This is Phi, this is Llama, this is Gemma. Those models have limited KV catch, constrained working memory, and context windows that are orders of magnitude smaller than their cloud counterparts. So when a small language model needs to call a tool in standard MCP setup, the full JSON RPC tool schema can consume majority of its available context window before that first prompt even arrives. And then there's the connectivity problem. The cloud assumes that the network will always be stable, but the edge doesn't have that luxury at all. So the first and most fundamental problem is going to be the wire format. JSON RPC is human readable, which is great for debugging during development and if you have the stable network for it. But most servers don't really need to read that information that's sent in a payload, and they just need to process it fast. So my first proposal is actually going to be binary MCP. That's going to replace JSON on the wire with protocol buffers, or protobuf. And protobuf is a binary serialization format that was actually developed by Google and is used in production on a massive scale, primarily for communication between microservices and APIs. So instead of encoding that data as readable text, it can encode the same information as a compact sequence of bytes. So you won't have any field names that are going to be repeated as strings, no curly braces, no white space, just the raw data that you need. And the typical MCP tool call in JSON might be, 2 to 5 kilobytes. And semantically, with the protobuf message, you can actually shrink that down to 200 bytes-ish. If you look at the benchmarks, that's like 10 times to 25 times of a reduction in payload size. So let's take it back to the factory floor that we talked about for our use case, where that edge device is going to be talking to a local MCP server over a shared wireless network. Smaller payloads mean faster round trips, lower CPU load, and less battery consumption from the radio hardware, waking up and transmitting. And at high throughput, when there's hundreds of tool calls being made per minute during an active production line, that's going to compound into measurable efficiency gains. And then when it comes to parsing, I think that's part's even better. Binary deserialization is 10 to 50 times faster than JSON parsing itself. And that's just going to be because that structure is already pre-encoded, so you don't have to deal with tokenizing. You don't have to deal with string scanning or even any schema inference at parse time. So the decoder is going to receive those bytes, is going to map them to a pre-compiled struct, and then hand them an application, which is going to be a fully populated object. So in comparison, by the time a JSON parser has found the first field name, the binary decoder has basically already finished the message. Now, how might this work in practice? So step one, there's going to be a compatibility negotiation. So during that connection setup, the client is going to advertise binary support in its initialized request using capability flag. This could be an experimental feature. And then if the server supports that binary MCP, it's going to select binary. And if not, it's just going to go ahead and send right back JSON payload as it's been used to traditionally. This is going to help to make binary MCP backwards compatible, especially when dealing with legacy servers, and even with existing MCP servers. Step two is that schema compilation. So both sides are going to compile the protobuf schema once at startup. And this is going to be the key difference from JSON. The schema is compiled into the native code itself and not going to be interpreted at runtime. The next step is the tool call, and that's where the client's going to serialize this tool call into a binary protobuf message, and it's going to send it over the transport. And the envelope for that is going to be pretty minimal. It's just going to be a message type byte, a sequence number, and then the payload length itself. And then lastly, the server's going to send over that response after processing the tool call. It's going to serialize the response as protobuf again as well before it sends it over. So the client is going to deserialize that into a native struct, and it's going to pass that result to the language model. And the cool thing about this is that the language model's actually never going to see any of that binary process. From its perspective, it just received a structured tool results, and that's going to be exactly as what it sees with traditional MCP. So binary MCP is literally just a transport optimization, so it doesn't actually change the MCP programming model, only the wire efficiency. And then you might be wondering when to use this. So it's going to work in any scenario where the host and the server are on separate physical devices that could be connected by a constrained link. So that's whether it's Bluetooth, LE, Zigbee, or congested Wi-Fi, or maybe your cellular network. And if they're on the same machine communicating over like a Unix socket, this overhead difference is going to be negligible, and the complexity simply is not going to be worth it. So next is going to be the semantic tool compression, and with this one, it's just based off of tool schemas being incredibly verbose and token consuming here, right? So as you know, when you make a call for a tool, a huge JSON payload comes back just showing all the different parameters for it, what's optional, what's not, things of that nature. So the solution for that is just actually going to be let the client decide when they want to pay the context tax, is what I called it, for tool schemas during discovery time. And that's going to also include a new capability field, which is going to be called semantic compression. And what that's going to look like is essentially reducing down or compressing down that original tool call description into a very small, very short to the point description where you may be only listing off a quick summary of what the tool does, what's required, as well as any optional parameters that are there. And then in the event that that your application does need more robust understanding of a tool, that's when you can call and ask for another full payload of the tool schema. And then the third context is going to be about relevance and size. So currently, the MCP tools list request returns everything that the server exposes. So at the edge, A small language model doesn't need the full capability of a server. It just needs a subset that's going to be relevant to its current task, right? So returning irrelevant tools wastes context, and it increases the probability of tool hallucination because the model is reasoning over a larger option space than it actually needs. So the proposal is to allow clients to pass session context when requesting tools, very similar to the search functionality that's becoming more prevalent in the MCP community. So for us, the manufacturing small language model that's currently using defect detection, it can send context that's doing a quality inspection task on an automotive body. And then the server's going to return only tools relevant to that context, only tools that are going to help with that defect detection. Maybe it's only going to send 8 out of the 50 that it actually has. And then the 42 other ones are going to be completely irrelevant to the model. And this has a useful security property as well, because if the tool isn't inside the schema, then the model can't call it. And then that means that it can't be prompt injected into calling it, and it also can't hallucinate it. So the dynamic pruning makes the attack surface even smaller as a natural side effect. So we talked about binary MCP and how it makes our messages smaller and faster. But smaller messages still fail completely if the network drops. And that's our second problem that we're going to discuss. So here's the thing about SSC and standard I/O. Neither were designed for intermittent connectivity, right? SSC requires a persistent HTTP connection, and so if you have one network blip, the connection has to, the client has to restart that connection from scratch, and then you're gonna have to reestablish that session state entirely again. And standard I/O, it's even more fragile. It's a one-to-one process relationship that can't be really used over a network. That's why it's used locally. So for either one, if the device sleeps, the process is going to die. And then when it does wake up, you're going to have to start that connection request all over again. And for always on cloud deployments, that's fine because it rarely happens. There's load balancing, things like that to transfer over if one network fails or if something happens. But for an edge device with aggressive power management, it's a fundamental mismatch between the protocol's assumptions and the deployment reality. So my proposal is that there is a transport architecture that's going to be built for intermittent connectivity from the ground up. And that's going to be using message queues, transport, specifically MQTT, and that's going to be combined with a local persistence layer. So MQTT is a lightweight messaging protocol that's designed specifically for high latency, unreliable networks, mostly for those edge AI use cases, and especially in the IoT world. And the broker, it has a broker, and that broker is actually going to act as a persistent intermediary. So it's going to hold messages in flight, it's going to manage your delivery guarantees, and it's also going to track which clients are online on the network and when they have actually fallen off the network as well. So again, here's our scenario. Our factory floor edge device is running defect detection again, and the small language model is going to make a tool call. It needs to flag a suspected defect that it saw on the production line, and it needs secondary review. And it needs to log it to the central quality system for engineers to review later on. And let's say at that exact moment when it's sending those logs, the device's Wi-Fi drops, the connection drops, and there's like a 500 millisecond network blip. So in the current MCP model with SSC transport, that call is just going to fail. And the small language model is not going to have any result. That session state is going to be lost if there is a stateful session. And the defect just may go unlogged and people aren't going to catch that. But with the store and forward approach, before the MCP client even touches the network, it's going to write that tool call intent to some type of a local storage system on the device, maybe like a SQLite outbox or something like that. And that's going to happen synchronously. So this tool call is now durable. It's going to be able to survive any application crashes, battery death, or any operating system level process kills just because it's stored locally on that device. The MQTT client is actually going to monitor that outbox that it sees, and it's going to publish to the broker whenever a connection becomes available again. And then when that connectivity does finally restore, that MQTT Client is going to publish the pending tool call that it saw. The broker is going to deliver it to the MCP server, and then the server processes it and publishes it as well, retaining back to the broker again. And then the broker, they're going to have the result. So if the client is still offline when the result does arrive, it's going to get the result the moment it does reconnect. So you're not going to have to deal with any polling, no re-requesting, and also no repeated work as well. So the final piece of resilient transport is going to be session continuity. So today, MCP sessions are stateless by default. If a client disconnects and reconnects again, it's going to start a new connection from scratch. But for an edge device that has power cycles, goes into sleep mode quite often or just moves between network zones, that means constantly reinitializing context. So I recommend including a session ID and a sequence number in the MCP message header. And so the server is actually going to maintain that session state that's keyed to the session ID. So when a client reconnects with a known session ID and a sequence number from its last known message, the server can replay any missed notifications it might have gotten, and the language model can resume reasoning right from where it stopped. An example of this is the defect detection model. Let's say it's midway through a multi-turn step analysis, and then when the device goes to sleep. It wakes up 20 minutes later, it reconnects with the session ID again because that was stored with the MCP header. That server is going to detect that there's that sequence gap of maybe it's missing 10 messages or 20, and it's going to replay those intermediate results and messages that the client missed. And that way, the language model is actually going to be able to grab that missing context and pick up on that reasoning chain without having to resend everything over and restarting the session. Keep in mind, though, that MQTT transport, based transport, it does add architectural complexity here. You're going to need a broker. You're going to need to manage the local SQLite database, and you're going to need to handle that session replay logic. So that cost is justified when your device has aggressive power management or sleep cycles, any type of network connectivity, or your network is genuinely intermittent rather than just slow. Or also, your tool calls involve operations that must not be lost, such as things like logging, any safety flags, or any audit events. So for local development environment, or even a cloud deployment with reliable connectivity, you should probably just use SSE. It's going to be much simpler and appropriate. You do want to make those architectural trade-offs and choose which one works for you based off of the complexity of your application, as well as the requirements. Okay, so we've shrunk the payload with BMCP, we've made the transport resilient, and then we also have one other issue that we have to fix right. So the defect detection model, or the system that we have, it's also continuously polling sensors, right? Whether that's the coolant temperature, maybe it's the conveyor belt speed, maybe it's even machine vibration readings. So these sensors are going to update infrequently just by nature of the work you're doing. Coolant temperature might change, every few minutes. The belt speed, that's pretty consistent, so it might be stable for hours. But the system is polling them consistently as if it's a monitoring loop. In the current MCP spec, every resource request does return a full payload every time, so regardless of whether anything changed. And the system is going to be downloading the same bytes of information of sensor data over and over again while assuming that full payload cost, even though the values were the same literally 10 seconds ago. And for a battery-powered device on a constrained network, that's going to be a really silent drain, especially over hours of time. So the current MCP spec doesn't have any mechanism for a client to say, hey, I already have this resource, just tell me if it's changed, or tell me when it's changed. And that's going to be a significant omission for edge deployments, and it's one that HTTP solved years ago, actually, with e-tags. So content addressable context is what I recommend, and this is just going to be before the server sends any type of resource payload at all. It's going to actually send a hash of that resource first. So the client's going to check that hash against this local cache to see if it actually already has that data. And if they match, that client's going to respond with some type of acknowledgement to the server and then skip the download entirely. It doesn't need any new context. It already has it. Now, if the hash is new, the server's going to send the full payload of information, and then the client's going to take that same data and then rehash again. So you have a new hash to compare against. And then so a sensor that's reading, a much smaller byte exchange or hash exchange when nothing has changed, is fine. But when you're at scale across like a fleet of edge devices pulling dozens of sensors hundreds of times per minute, and there's hundreds of devices that are also on the same network and doing similar things, that's going to be a substantial reduction in both the network and also the CPU load. So for those that are familiar with HTTP tags, this is the same principle. It's going to be baked into that MCP layer as a first-class protocol feature rather than relying on the HTTP transport itself. So the distinction is because this use case is on the edge, so you're going to be running on Bluetooth LE or Zigbee or some type of cellular network, whereas Eve tags, they don't have that functionality. And then for the flow for this is going to be the client requests a resource, the server responds with the hash, the client checks its local cache to see if it has it. If it does, again, he'll send a 304 acknowledgement, hey, I have this, don't send me any payload. If it doesn't have the new hash, it'll say, hey, give me the payload, and I'll just rehash for the new one to account for this new data I have. Again, you should be doing this when any data is slowly changing, but it's going to be frequently polled, such as server status readings, configuration files, schema manifest, or definitions, things of that nature. Anything where the answer is pretty much going to be consistent most of the time. And if you're surprised that the data has changed between polls, then it should be this solution that's going to protect that request. However, I don't recommend this for high-frequency streaming data where the hash changes every read. That's why we have the binary MCP to handle transmitting over the network, and that's going to help to make those payloads small as possible. Okay. And then even with BMCP reducing that payload size and the content addressable cache, it's going to be eliminating those redundant data transfers. There's going to be a third issue that none of them addresses, right? And that's because every MCP message that you have, whether it's tool call, sensor reading, any of that, it's going to still come in that JSON RPC envelope. And that makes the systems, identifiable, routable, debuggable. But what happens when that envelope itself is bigger than the actual resource or data payload there? I was doing some research and I came across 12 Labs and how they built an MCP server for video intelligence, and it was actually really cool. So you send it a video resource, it'll index it, and you can actually query it with natural language, and it's actually really impressive. And then the architecture, the video travels to the 12 Labs infrastructure, it gets processed by their models on the cloud, and the unstructured intelligence comes back through MCP itself. And so the MCP server really serves as that analysis layer. Unfortunately, this doesn't work at the edge just yet. You can't first upload some information or video and then analyze it later, especially when you need a device or a decision in milliseconds. And then by the time that footage actually leaves the building or leaves where you're at and gets indexed and the result comes back, basically the defective unit has already cleared the rejection point, and now you're shipping out something that's been packaged on the truck and it's going to get sent back. So I do believe that the MCP server should still be the analysis layer. The question is going to be, what does that look like if the footage never actually leaves the building or leaves the network? So my proposal is actually going to be a local first resource discovery, and that's basically where you're going to create a specialized URI scheme. As you see here, it's just MCP local. And there's going to be a separation between what the server is responsible for and what it's not. So the principle is that the MCP server is the intelligent and decision layer. It's not going to be data transportation at all. And those are two completely different jobs. And if you do conflate them, that's where a lot of overhead comes in. So what's going to happen is your MCP server is going to signal, it's going to be a signal. And then the raw video stream is just going to be media itself. And they should never be on the same path. So in practice of our factory floor example, there's discovery phase. The client's going to ask the MCP server what resources that it had access to, which is necessary because there's hundreds of web cameras, other sensors and things of that nature. Probably shouldn't store that on device. It should just ask the MCP for that information. MCP server is going to say, hey, your server or your resources that you have access to is this local URI here. The client's going to see where that stream is and then open a direct connection to that resource. And then those frames from the video are going to run straight to the vision model itself. There's not going to be any encoding, no envelope, things of that nature. Then the vision model is going to detect maybe some defect that's happening there. And so, but it's not able to do a rejection arm to block it. The MCP server does. So it's actually going to do a tool call to the server, and the server is going to actually analyze the defect and pass the frame and reference as well. I'm out of time now, but the server never saw a single raw frame itself. It saw a structured finding from the model. And then there's also the correction action that it takes too, where the model is actually going to call the rejection from the MCP server to stop it from moving fast. So, and that can travel, and that command can travel via binary MCP as well. So the arm is going to fire, the unit's going to divert, the event is going to be logged, and then everything is going to be fine here. So the raw stream flows directly where it needs to flow without having to deal with the transportation layer that comes with MCP. You can also extend this to remote devices. Obviously, you would just switch out the local URI for the remote URI. And then you're also going to need to use this when the data source is high frequency and high volume, such as camera feeds, IMU sensors, as well as audio streams. And the second one is when you're actually separating or keeping the resource within the MCP abstraction itself. That way you get the efficiency of a direct stream and then also the intelligence of a proper MCP analysis layer. Okay, great. So when you put everything together, binary MCP handles the tool calls and the sensor commands. They're going to be small, fast, and binary, and then they're also going to be able to cross a constrained network efficiently. The cache is actually going to handle the frequently polled, slowly changing sensor data that we talked about, where there's one hash exchange instead of a full repeated download. And then we talked about the resource discovery here, right, where raw frames, they're actually going to be pointed to in local storage on the device or on a remote source rather than having to go through the actual MCP server itself. So together, those three proposals give you an edge native MCP stack and MCP that was designed for the constraints of the environment that you're operating in. I think that within 2 to 3 years, maybe even sooner, we might even see binary MCP forks emerge in the wild, whether that is the core specification that's being adopted by MCP or not. There's going to be some type of binary framing itself there. Mainly because the edge is not going to wait for consensus. There's already billions of dollars being invested into it. So hopefully this becomes a community project to where MCP is not the one that's overlooked for this. And then also, I think that we should be the ones to shape this. I think there's a lot of room for a discovery here. I couldn't find much research when I was digging into a lot of this work. And a lot of it's just, I don't even think that this is going to be disruptive to the MCP ecosystem. Again, they're supposed to be additive. BMCP is backwards compatible, and the caching is supposed to be an opt-in caching layer itself. And then the local first discovery, that's just a URI scheme. That's nothing new. So existing cloud deployments can continue to work with MCP as it is today, but edge deployments will also get those optimizations that they need to. So yeah, the physical world is where most of the consequential AI deployments are going to happen over time, on the production lines, in operating rooms, in the vehicles that we drive every day, and even in some of the farms that we get our food from. So these environments have constraints that don't really negotiate, and a protocol that can adapt to them will simply be bypassed by something that can. And I think that MCP has a really good, not only community, but they have a really good framework for this to be picked up. So yeah, that was it. Thank you all.
Alrighty. Hello, everybody. I'm going to go ahead and get started here. My name is Daniel Abdel Samid. I am a staff software engineer on the education team at Apollo. I work on all of our education products, but Docs is the one that I spend the most time on. Its goal is to provide the readers with direct access to our authors and our authors with the readers' feedback. If you'd shown me this graph back in 2022, I would have thought that this was a weird graph to put on the screen. But as we're here, we know everything has started to change. And I think really the pivot of that was in 2024. This was really when we started seeing agents getting good at tool calls and then subsequently calling the internet by themselves. So we saw a slight uptick, but then we turned to today, where agents is a much larger portion of our documentation traffic. We'd spent years developing documentation for humans who skim, who search, who get frustrated, and who want deep understanding. But now, our fastest growing audience, they don't skim, they parse, and they pattern match. So documentation strategies defined over decades have begun to break down. And now, the reality is that over 40% of our traffic is now agentic, including AI user agents, AI crawlers, and direct tool usage. And I'll say it again to emphasize the importance. Over 40% of our traffic now reads docs with vectors and not eyes. And it's showing no signs of stopping. So this provides a dual audience dilemma, right? Our agents, they want access to patterns. They want dry and to the point content. They want strict do's and don'ts, and they really enjoy code examples. And this is very different from our human audience, right? Where they want explanations, they want context for understanding, they want narratives, and they have an innate desire to explore. So how do we serve both agents and humans without losing quality for either? Well, we know we can continue to meet our human audience through the browser, but agents have a secondary access method that we can fine-tune specifically for them. Well, agents love tools. They've been trained to use tools, especially when exploring, and to reduce hallucinations or stale information. And of course, to provide those tools, well, that's the reason we're all here, right? The Model Context Protocol gives us a way to allow agents to directly interface with our documentation remotely. So I want to talk about our journey. Where did we start? Where was our first MCP tooling? And then how did we craft that over time into a purpose-built agentic content source? And then 3, how did we test it? We know that our purpose-built agentic content source is better than this first MCP tooling, but how do we quantify that? So the first go-around was pretty simple. We have existing capabilities as a documentation platform. And really they can be broken down into 2 categories, right? Finding documentation and then reading that documentation, which here is represented as search docs and read docs, the actual tools that are live right now. So search docs does exactly what you would expect. You give it a query, and then it responds with information and pages related to that query. The only difference is that at the end of the snippet that lets the agent know what is kind of on that page, there's a command that says in order to read more about this specific page, use this tool, which in our case is the read docs tool. So read docs then takes a slug that describes what page it wants to read, and then a section, because some of the pages can become very large, and we don't want to return the entirety of that page in one result. So instead, we section it and say you can read the first section, and then iterate to the next, etc. And it's also aware of how many total sections there are. Oh yes, and also at the end of the content, there's also a hint to the agent as to how to get the next bit of content. So looking at the patterns here, in watching my own agents use these tools that I created, I would see a pattern where it would search for something, and then it would maybe read a page, and then maybe read a different page, and if it happened to come across a very large page, it may attempt to read the entire page, all 10 sections of it. And then it would try to find something else that's searching docs again, and then reading another page. Well, if you're looking at the numbers to the right, you see this adds up really quickly. We've now hit 25,000 tokens for maybe one answer that the agent was looking for. This is wasted calls, this is wasted tokens, and of course this is wasted time. And if we think about the characteristics of our agentic user, they pay for every single AI token that we provide to them. And they also pay with a context window, right? They don't want these 25,000 tokens taking up their context window. They have probably better things to do with it. So as MCP tool developers, we have one extremely important guideline to adhere by. Context is courtesy. Providing the user with exactly what their agent is requesting in as few tokens as possible is a core determining factor in the quality of an MCP server. Large responses, they cost nothing for us as the provider. I can send a JSON payload as big as I like, but it's everything to the consumer. So with that in mind, I wanted to take our first MCP tools and iterate and build something new. I had a few bullet points in mind for that. I wanted low token usage. I wanted fast responses. Of course, I want accurate answers. But then I also want a single tool call so that we don't have to do this pattern of searching, then reading, then searching, then reading. I want it all compressed into one tool. So whereas for the first exploration, we took existing capabilities of the docs and worked forwards towards an interface that allowed us to expose those capabilities as MCP tools, this time I wanted to take the opposite approach. I wanted to first start with the interface of how I wanted my agents to interact with the documentation website and build from there. So with this, the research docs tools now takes an array of questions. So if there's multiple things that the agent wants to know that may have overlapping results, we can ask for them all at once, as well as a context parameter, so we know in what context are these questions being asked. And then the results should, instead of being pages or slugs, it should be exact chunks of documentation that is able to answer the questions provided by the agent. But in order to build this, we have a problem here. We had to accept that our current content is written for people. And the agentic space is moving so rapidly that spending any time to rewrite content for today's agent's strengths might be time wasted because tomorrow's agents might be looking for something different. We need an automated pattern that can ingest our current content and produce those bite-sized chunks for agents to use. So this now brings us to the research pipeline, which is broken down into 4 distinct sections. How do we chunk our documentation? How do we store it? How do we retrieve it? And then how do we expose it as an MCP server? So first, when looking at documentation, there are a couple of well-defined ways to chunk documentation. There's the easy ones, right? We could chunk based on the headers. We could chunk based on word count. We could do it via token count or character count, or maybe do code blocks with some context around them. But really the problem is that none of these are great, and each page needs a specific way to have its documentation chunked. So this is where we might as well utilize AI, the very tool that's going to be consuming our documentation, to build these chunks, as it's going to be significantly more aware of semantically what is important to be in a chunk. Now this also gives us the capability to, in each of our markdown pages, provide instructions to this agent in the front matter. We can say on a changelog page that we want every major version to be its own chunk, or on an API reference page, we may say, instead of having larger chunks, have smaller chunks that describes each individual property. This would differ from the general guidance that we give for chunk size. So we're talking about semantically this, semantically that, but how do we actually store something that is semantic as opposed to structurally, right? We want to start with a question. I'm getting an error in the Apollo cache. How can it be fixed? And we want to produce the results. That might be incorrect type policies or possible types is incorrectly configured. But how do we go from the question to the result? Well, you may have heard of embedding models before. It's kind of like reading the mind of an LLM. We give it some input context, that is the question that we have, and then the result that we have, and it produces an array, generally a very large array of a lot of floats. In our case, 3,072 floats in this vector array. This vector array describes where the LLM's mind was as it was reading this particular piece of text. But we still don't know how close something is. What does it mean for one bit of information to be close to something else? Well, this is where cosine similarity is helpful. So we're going to have a little bit of trigonometry here. What does it mean to have what does it mean to be close to the question and the answer? Well, if we plot these vectors here, we can see that there's a way to tell how close they are. Now, on the slides here, I've demonstrated these as 2D vectors, because I don't know about you, but anything beyond the third dimension is incredibly hard to understand. So 3072 dimensions was just not in the books for the slide. So by looking at the distance between these two vectors, we're able to determine how close two different thoughts are. But there's still a really big problem here, and there's a reason that I showed these vectors as pointing in two different directions. Well, just looking at Apollo client, the question about the cache error, and incorrect type policies, in a vacuum, they're actually not that similar. This is a big problem. What we want to do is produce results that map questions to answers and find them to be semantically close. Well, we're already using AI to build out our chunks. So instead what I've done is we allow it to produce an array of questions that describe what questions might the user be asking that could land us with this specific chunk of documentation that provides the answer to the agent. This is done at build time, where we have an theoretically infinite amount of time to calculate these questions, and it's cached. So if the page content doesn't change, we don't need to be recomputing these chunks, these questions, etc. So with these questions, now we can embed so much more. We can embed the abstract of the page, we can embed each question individually, and we can embed the content so the answer might be able to be found directly. So to retrieve this, we might then take our existing embedding store that contains all of the information about the different content that we have, and we'll take the input from the user, that is their array of questions and the context they might provide, embed that in real time, which is very quick, and then we're able to produce an output that describes what pages does this content live on, and then score it. We can say how close is this content. So instead of replying with pages and then the entirety of those pages content, we can now give exact chunks of documentation scored and filtered and limited such that we're using significantly less tokens. And now to the MCP, we've basically built the whole thing. Right? At the end of this pipeline, we now are able to give an array of questions, some context along with it, and receive results out. But there's a problem here. How do we know? We just spent all this time talking about this new research pipeline. I put a bunch of engineering effort into it. We've built it out. But how do we test in a world of non-determinism and constant change? I can't just say that the new MCP server is better because I spent more time on it. That's very unlikely. So MCP testing 101, right? We can't just unit test our MCP server to say if they're working or not, right? We can do that for basic testing, but in order to say if something is actually better than the way it was previously, we need to utilize the very agents that the users of our MCP server are using to determine that outcome. And we need to isolate our variables as good as possible. And there's one more thing that I'll get to at the end. So for end-to-end MCP testing, which I have docs crossed out here because this pattern actually works really well for any number of MCP servers. We have two agents that execute our test. So first we have the direct executor agent that is then going to do the work and use our MCP server and understand the results. And then at the end, we have a scoring agent that basically goes through and reviews what the executor agent has done. They have a shared sandbox between these two agents and understand, did it do something correct? Did it do something incorrect? And then at the bottom, we have kind of this shared pool of information. The test suite itself consists of the initial prompts, what tools are connected, and then for the scoring agent, it'll have a static binary rubric, which I'll talk about. So for the executor agent, it's really important that it's built exactly like the user's environment. What does it look like? What does the average user look like that's using your MCP server? For us, it might be somebody attempting to build something with Apollo tooling. Right, but that might look different for every single MCP server. It's extremely important that this tool is as close to the users as possible. Same model, same tools. In order to build this with consistency, You turn down the temperature as much as possible without affecting that relationship to the user's environment. If the user uses your MCP tool in a very high temperature environment, you need to have that configured as such. But for us, coding tools are normally temperature turned down, so this works well. And for consistent testing between like an A and a B MCP server, you can also use the seed parameter. There's only a few model providers that allow this, but by utilizing the seed, you will actually get consistent results every single time. Same input produces the same output. And then finally, and this is one that's really hard, don't steer with the prompt. If you don't think that the user is going to prompt their agent to say, use these tools specifically, don't do it in your testing prompts. This might be something you're testing for. You want to see if your tool descriptions are proper and are actually going to be used. So after the executor agent is done, it now completes a given task. It might have an initial prompt of build this tool with Apollo client or build this tool that utilizes subscriptions, and it then seals that. Right, so it completes this task similar to like Claude Code or any other agents out there, and it produces a result that is normally something on the file system. So then we go to the scoring agent. Right, now that the executor is done, it's done its task, and we want to see and check the output. It needs no knowledge of what the executor did. We need it to be completely isolated, so it doesn't try to use the prompt or the understanding of the conversation history to steer its final output. It has read-only access to this container. So it is not able to write to the file system. It's not able to change the output of the executor. Its sole purpose is to understand what the executor agent did and see if it complies with this rubric. And speaking of the rubric is already pre-written. It's pre-written by us, so that's consistent between each test. We don't just say, did it complete the task, yes or no. This rubric is broken down into individual bullet points that can be checked and are either true or false. There was a problem that we saw. Originally, we started with floating point output, say between 0 and 1 score based on what the output looked like. Was it a 90% accuracy based on maybe this broader topic? But the problem is that AI agents, that in some ways they work similar to people. And if you ever look at Amazon, you'll see that there is not ever a normal distribution around 3 stars. It's always very high or very low. So what I noticed was getting a floating point value back from the agent wasn't worth the time. Switching it to binary to say yes, it completed this task, or no, it didn't, also improved its accuracy towards understanding if that task was completed or not. And then, of course, at the end, we take all those binary results, those true and false, and produce a final score that is indicative of how close the agents were. Now, when I started working on this scoring agent in the rubric thereof was important to understand if our docs and our MCP server were providing the right information to complete the task. But as time went on and agents got significantly better at coding tasks, very consistently we see these rubrics are completed with 100% accuracy. It is very uncommon for us to run one of these tests and see that the agent was unable to complete a task, especially a task that it's completed before. So now we use it for this, which is looking at how is our MCP server improving based on other metrics like token count or tool calls. Now this is the and then part. You also want to use real statistics. Imagine this. You deployed a brand new version of your e-commerce site and you're tracking the very first user that's checking out. And it happens to be that their cart total is 300% of the average. Well, you can't just come out and say that the new site increases the cart value by 3x. That's ridiculous. This is your first customer. But we have to treat AI models the exact same way because statistically, they're normalized, right? Some runs may be better than other runs, especially with the randomization and the temperature turned up very high. So it's extremely important to run these tests over and over and over and over again to understand how does it compare over time with the previous models. And it's also not enough to look at the averages of each of these models. You can't say that the average of one model is better than the average of another if you're looking at a metric like token costs. So no, you need to use real statistics like Filler's theorem or something to say, how confident am I that my MCP tool is better? Now, this is my head. when looking at an equation like this. I enjoy physics, I enjoy math, I don't enjoy statistics. So I had Claude implement this for me. I'm not going to work on that myself. But in the end, what I realized was that this new tool was significantly better, and I had a way to test it and guarantee that it's better. This new tool took 70% less tool calls than previously, and 50% less tool tokens with the exact same quality of the output. And again, quality of the output was determined by the rubric that we had decided previously. So I'd like to demo the tool that I built real quick here. It does take a second to run, so let's see. Where is it? Oh, there it is. All right, so running this tool again here. Let's see, I'm gonna go ahead and run. And so this is the Docker sandbox that I had set up that allows the executor agent to run exactly like tools like Claude Code, et cetera, which is for us where we're looking at our environment. So you can see here that the agent starts to run and it starts to produce output. I'm going to go ahead and make this a little larger here. Goes ahead and starts to produce output. It's showing the tool calls along the way and collecting information about those tool calls such that we know what the outputs were, and we can go back and analyze any individual run that might stand out as an outlier. So this run runs pretty quickly, so I'm gonna let it run here and see if it works. But what we're actually doing, and you'll see this is dictated here, MCP A is what's running right now, and then we're gonna run MCP B right after that. AI agents are very much like a black box. We are unsure of if there's any micro changes going on behind the scenes at Anthropic or whatever model agent or whatever model provider you're using. So by running these tests back to back, we try to the best of our ability to guarantee that we're almost using the same state or the same version of the model as both tests, so that we can know that the difference is because of our MCP tools as opposed to differences in the model. We'll go ahead and let it run here. Looks like it's almost complete here. We're on MCP B now, which is the new research tool. And again, because of the statistics of this, I can't guarantee that the output is going to be exactly what I saw. This is also a particularly quick test and not a great determining factor in the doc's quality of the output, but it was quick for a demo. There we go. So we can actually see that it shows now the output of the docs read tool and the docs search tool versus the docs research tool. So you can see it required 4 calls, 2 to search, 2 to read, and then it required only 1 call to the docs research tool, and it used about 3,000 tokens to do so, while we're looking at roughly 5,000 to 6,000 tokens for the previous server. So there's the improvement right there on this particular example. Let me go ahead and get my slides pulled back up here. There we go. And there we go. So what did we learn today? We learned how to start with exposing existing capabilities and turn that into a iterative, agentic content experience. We learned how to harness math to make AI more accurate for responses. And finally, we learned how to use statistics for confident end-to-end MCP testing. Thank you so much. If you want to add me on LinkedIn for any questions, feel free to use this QR code here. I will also be at the Apollo booth in the solutions showcase area, so feel free to stop by and say hi or ask any questions that you may have. Thank you so much.
Just gonna wait some more minutes for more people to come. I think it starts in 3 minutes anyway. Hey everybody, welcome. Thank you for coming. Hopefully you're in the right talk, and if you're not, I mean, just leave really quietly. But if you are, welcome. Right? I'm going to talk about OCI images as packaging for MCP servers or packaging for AI tooling in general, because a topic that I'm excited about. And if you don't know what an OCI image is, hopefully you'll learn a thing or two today. So that'd be great. All right, so I'm a security person. So as a security person, I'm going to start with a little bit of fear mongering, because that's what we do. And yeah, the first thing that I want to say is if you're running NPX directly, you shouldn't. Please stop. It sounds really easy to do, and in fact, it was the first thing that I noticed when I started looking at the MCP, right? Like all of the guides had adding in MCP.json, like adding NPX or UV run and adding your API keys in there, and I just freaked out a little bit, right? Because I'm used to a slightly different world. It sounds like it's really simple, but there's a lot of hidden risks that you might or might not be aware about. And I'm trying to, little by little, give a little bit of tools and tips and tricks for you all not to fall in these ones. So hopefully it helps. So a little bit of a timeline, right? And this, in a way, it's scary, but it also means that the protocol and the ecosystem is evolving, right? As you get a lot more usage, you're going to see threats come in. And we already had our first malicious MCP server, right? So Postmark MCP was, I think, the first in the wild. And in a way, it's kind of exciting, right? It means that people see this as a worthy target to attack, right? So it's just natural. Like it's not about the protocol. It's just about evolution and usage, to be honest. We already found the first exploitable critical CVE, right, with the CVE 2025-6514, right? And even worms started to approach to that extent, right? And attacks are getting a lot more aggressive, a lot faster, Recently, a security vendor got attacked via a supply chain attack. That's not necessarily related to MCP, but I just want to tell you, we're going to see a lot more of that, right? And especially with AI and AI making it a lot easier for exploits to come by, it's just going to come more and more, right? And it's not about fear, it's about being aware and knowing where to stand and what to do, right? So fear-mongering aside, hi, my name is Juan Antonio, people call me Oz, and yeah, you might have understood I'm a security person. I created a little project called ToolHive to run MCP servers, and yeah, we have a booth around here, StackLog, right? Before this, I did a lot of security in OpenStack, Kubernetes, and in bare metal environments. And I do believe, though, that tooling in general, not just AI tooling, should be secure, right? By default, not by suffering, right? It's a nice little tagline that AI helped me with. But yeah, so if there is going to be a couple of slides that you might want to take a picture about, and this is one of them, right? These are some of the questions that you should be asking yourself. When you're running an MCP server, can I answer this? And you should be able to, and hopefully after today you will, right? So the first thing that you want to know is what's in this thing, right? Like, what am I running? And throughout the years, we've come up with a bunch of standards to help you be able to do so, and you're going to see a little bit about it today, right? The next thing that you want to know is who built it, right? Like, did this come from Uncle Bob or Alice or like some rando in the internet, or is this actually the person that I'm thinking built this package, right? And so again, like, proof of built provenance, like, it's something that we've already come up with, right? Like, and you're gonna see a little bit about that today. How was it built, right? Was this built in some random person's laptop, or did this come from an actual CI job that I know and trust? And like, is it vulnerable? Is not really something that is going to help you with the more advanced cases, but just dealing with the low-hanging fruits of knowing, am I running something that's actively exploitable today, is going to take you very far, right? So again, just small little things that are going to get you further in, hopefully not being pwned. And finally, of course, you want to know if you can enforce this at all, right? Because that's important, right? It's nice to be able to know all of these things, but if you can't really make a process out of it, there's not a lot of value in the end. So unfortunately, the package managers have made a lot of progress, right? So they are building auditing tools. They are building a lot more attestations around what they're building, but there's a lot of gaps, and especially around software is going to run in an environment, in an operating system, and you don't have all of the info around what it's running, right? So even though you might know exactly all of the dependencies from your NPM package, it's still going to use OpenSSL. It's still going to use a lot of packages from your operating system, and it's going to be deployed on your box, right? So it's not enough. Fortunately, though, there's a format for that, right? And it's nothing new. It's vendor neutral, right? It's not something that I'm selling to you or anything. It's OCI images, right? And for those of you who don't know that, you know Docker files? Does anybody know Docker? Right, there we go. So it's that, right? An OCI image is just a Docker file. It's a format, it's a standard. People from many, many companies work on this. And if you use Docker Hub, it uses the OCI spec. If you use GitHub Container Registry, if you use Quay. So vendor neutral is going to get you really far. And all that a Docker file is, or an OCI image is glorified tarball with a lot of metadata, with a bunch of utilities for you to be able to attach extra information into that metadata. It goes as far as even supporting multi-architecture, right? So if you want to run ARM, or if you want to run on x86 or in PowerPC or whatever you want, like it's there, right? So use it, it's amazing. And there's a standard for the registry too, right? So if a registry supports OCI, then you can use it, and it's great, right? So basically, if you're building MCP servers, all you have to do is build, push. It's content addressable, meaning that it's going to create a cryptographic hash that addresses the content of the container, right? Then you push that tag that's with the cryptographically content addressable hash onto the registry, right? And you're off to the races, right? Then it's up to you to take a lot more steps into assuring to your users that it's safe, right? So you might want to attach an SBOM, you might want to attach attestations, and you're going to see a little bit of that. I'm just not throwing keywords or random buzzwords to you. But you can attach it, and there is a mechanism called the Referrers API, which allows you to attach extra artifacts onto the container, or the container image. So getting back to the questions, right? Ultimately, let's go a little bit into more detail. What's in it, right? Like, I get this package, either NPM or hopefully a container at this point. You really want to know what it is. And in the industry, we've come up with a thing called SBOM, right? Like a software bill of materials. There's a couple of formats that you might care about, but ultimately, you're going to ask Claude. Claude is going to give you something. And it's going to help you generate basically a list of all of the libraries, dependencies, and different artifacts that are part of this glorified tarball that I just talked about. And from that, you can already make assertions, right? Like, does this package contain everything that I expect it to contain, right? Or does it have something else that I should be worried about, right? If it's an OCI image, it also contains the user space packages, so you can say it has this particular OpenSSL version, and thus I am vulnerable or not, right? So this is as deep as you can go with an SBOM. It's not going to fix everything, but it's going to give you a good sign of where you should focus on your risk assessment. Who built it, right? You all might have heard about being able to sign packages, but who signed it, right? Like, who here uses GPG keys to sign software? Yeah, I mean, yes, but there's better ways out there, right? Some really smart folks came up with a project called Sigstore, and it allows you to leverage existing identities for you to sign without needing to handle GPG keys, right? So you could sign with an identity that like your GitHub sign up, right? Or your Google account. I think there's a couple more, I don't remember. And we're gonna see that in a bit, so that'll be a good reminder. But it also handles identities from known CI systems like GitHub, or GitLab, I think, has something, and BuildKite, right? So with that, you already make an assertion of, I am running a container built by, I don't know, Uncle Joe, who I trust, or by this particular GitHub pipeline that I know it's the right one, right? So it's a little bit harder to get your rug pulled, so to say. Yeah, go ahead.
So trying to understand, the benefits you're trying to explain about running an MCP in a Docker container and focus on the build with your SBOM.
Yeah.
So you're saying you don't run NPM or X or NPX.
That's right.
Because I'm thinking, well, you're going to pipeline virtual environment, right? You set up to run, say, a Python MCP. What's the difference? Right? Can I answer my own question? You're basically saying you haven't done a scan, or it's not easy to do a scan on that virtual environment, whereas with the Docker image, you get everything packaged in, it's easy to do a scan, it's easy to identify exactly what you're running.
Yeah.
If you create a virtual environment and just download the requirements, it's a little bit more convoluted. Is that what you're saying?
I mean, to some extent, yeah. I mean, that's basically the short form of this, right? Basically, what I'm trying to promote is a format that a lot of the infrastructure that you already have already supports, right? Chances are your organization already has a registry. Chances are you are already doing some sort of scanning. And as opposed to bringing in extra artifacts that you don't really know how to handle, just use standards.
If you were repository which contains a Git package, so that you
Yeah.
NPM thingy, I think. So would, something your repository be scanning that for any dependencies that it has that might expose vulnerabilities, and would you catch those same vulnerabilities?
You would catch some of them. I mean, there's always the things that you know, and there's the things that you don't know, right? And it's all about security in depth, really, or defense in depth. What I'm trying to advocate for is for you to be able to protect yourself from the things that you know to some extent, and then it's up to you to protect against the things that you don't know, right? So in that case, then hopefully you're going to run in either a container, right, which is going to help you with some of the low-hanging fruit, such as it's trying to steal things from your operating system, like your keys or whatnot, right? Or if you're truly paranoid, that you might do a micro VM, right? But that's yet another level of defense, right? But all of this is possible because you have a portable format that makes it easy for you to run wherever you need in a standard way. Does that make sense?
Yeah, and what I'm getting at is you have a well-known, basic bill of materials.
Yeah.
This package, you know what you're running, whereas in other situations, a little bit less clear.
Yeah. Yeah, it becomes complicated, especially with like NPM, which might bring thousands and thousands of dependencies. Like, you're right. But anyway, I mean, I'm going to show a little bit of how you would build one of those. Just continuing a little bit with it. You don't only need to know who signed it, but you also want to know how it was built, right? Like, there is possibilities of you knowing how the pipeline that built this thing looks like, and is it secure enough, and for you to actually do policies on top of that pipeline. And going a little bit further, like, you want enforcement, right? So now that you have an answer to all of these questions, how do I make sure that I'm only running things that meet my criteria, right? It was signed by a GitHub action. It was running this particular pipeline with these properties. It even ran a security scan, right? So you can make those assertions depending on where you're running the MCP server, which might be Kubernetes, might be something else, might be local, but there are ways to enforce this, right? So you're not on your own. The second, the refers API. I just wanted to say again that you're able to attach security information onto the container to view the tree of attestations that you're building. And if there's another photographic slide, it would be this one, right? And it's just a comparison around the things that you get with OCI as opposed to with the other package managers or package systems, right? Some people are still taking pictures. I'm going to wait for that. 1, 2, 3, there we go. All right. And so, right, I mean, I can talk a lot about this, but I think it would be a little bit easier for you to see and get a little bit of these concepts. So then probably you can ask ChatGPT or Claude to help you automate this, right? So, all right. Let me add do not disturb. There we go. All right. So I didn't record a demo, so I'm definitely up for the demo gods now. Let's see how it goes. But I did have a script, right? So I'm not going to do a lot of typos here because it's already done. But yeah, the first thing that we're going to do is look at what we're packaging, right? And in this case, I'm not making the most secure package. I just want to package something. Ideally, you would be using something from a company like ChainGuard. I mean, I'm not affiliated with them, but I really like what they're doing. But in this case, I'm just building some container, right? Ideally, you would make something a little bit better, and AI can help you with that. But this is what it looks like, right? It just uses the Node 24 Slim image, and it packages some MCP server. So off we go. Now we're going to build it, and I built this before, so hopefully it's going to go super fast. Go machine, go. There we go. And now it's done. All right, so now we're going to do a scan, right? And since we're running in a container, there's a lot of utilities that you can use. In this case, I'm using Gripe from Anchor. I like him. Again, not affiliated, but it's good stuff. Gets the vulnerability DB, and wow, okay. I thought I had the latest one, and apparently I don't. This is going to take a while. Is it using my Wi-Fi? Nope. Give me a second. I'm going to use my phone for this. Yeah, 100 megs is too much for this Wi-Fi from the conference. Come on. There we go. How's the weather, people? No. Right. So what it does is that Gripe is a tool that actually brings down the container image. The container is a tarball. It actually goes through all of the files and builds a tiny SBOM out of it, and then checks for vulnerabilities in all of the packages. You won't really know that they're outdated, so it doesn't really tell you, like, hey, this is outdated, but it will tell you that it has a lot of vulnerabilities, right? So if a package is really old, the chances are critical vulnerabilities are not patched, if that makes sense. I'm gonna start it again, and hopefully the other internet is a little bit better. Come on. Docker build. Good thing that this happened exactly on the third step, so it's not too bad. Gripe. Yeah, now it's going a little faster. Should have run that exactly before. Okay, it's going to be a little bit faster. In the meantime, do people have questions? No? Nobody? Do people run vulnerabilities at home? I mean, scans? Yeah? Do you? Okay. 2 people. It's more than I thought. I do run them. I'm really paranoid. Actually, was going to show up with a tinfoil hat, but I decided not to. Not today. Oh, God. Yeah. Okay, it actually went a little bit faster. Come on. Yeah, so I work in a startup. We don't have a team that does it for me. Somebody needs to do it, and there's some of us that care. We used to be a supply chain security company. That's why I care about these topics. 107. God damn. Demo effect. It was going to hit me. I should have sacrificed a goat or something.
What are the overheads you see in running an MCP server in a Docker container?
Not as much as you would think, really. Mostly the big issue is when you come with a prepackaged MCP server, they might do exactly what I just did and just slap an image and off you go, right? If you're dealing with a statically compiled language like Go, then it's just one binary. Then it's really easy. You don't have a lot of dependencies or vulnerabilities like, woohoo, here we go. Yeah, so the 24 Slim has a bunch of won't fix high vulnerabilities in DPKG, which is not super relevant. libc might be exploitable, and some folks from Edera might give some really nice hints on how to exploit those. Yeah, libc, and curses. So like there's a lot of stuff, and it really depends on the quality of the container that you're running, how bad this is gonna be, right? And you're gonna see that in a little bit. So now we're gonna build an SBOM out of it. And there's another tool called Sift. It helps you build SBOMs. And the higher quality container image that you get, the smaller the SBOM is, because in that case, you're running a lot more minimal images with a lot less packages, which is less attack vector, if that makes sense. So it built the SBOM. It's 1.5 megas of text. That's a lot. I know that people get used to really big packages nowadays, but I mean, to me, this is a lot. Components. And of course, it's NPM, so it's going to bring a lot of dependencies, but then the operating system ones, it's 3,600 components. That's plenty. But at least we get a notion of what we have and what we're dealing with, which is what matters here, right? So let's look at some of them, right? And a lot of it is going to be node dependencies, right? You have the version, you know it's a library, you know what kind of things we're dealing with. Go ahead. Go, huh? SBOM, right? The software bill of materials, if that makes sense. All right. So we're going to push it. Let's see. This might also take a little bit because of the internet. Push refers to this, and no, it didn't take that much, so that's good. So now we can sign it, right? Like I know that I pushed an image. I want you to know that it was signed by me, right? So there is a Sigstore project called Cosign. It's from the OpenSSF, free and open source, and it's going to help me do it, right? So let's see. Right, takes me to the by signing. I can sign with Google. I'm gonna sign with my Gmail. And, there we go. Okay. It never asks me this. Galaxy settings, tap Google. Come on. God damn it. I did this demo like 2 hours ago, and it wasn't that painful. Yeah, there we go. I was signed to my StackLog account. There we go. So now it goes through an OIDC flow. It generates an ephemeral key. The ephemeral key is tied to my identity. Signs it, deletes the private key because it's not needed, and then it publishes up to a transparency log that's publicly available, right? So you can verify it from wherever you want, and we're good, right? So we got the token. There we go. Now we're going to attach SALSA provenance. SALSA is software levels of attestation, right? And the idea is that it gives you a notion of what the environment that this artifact was built in looks like. In this case, I'm kind of faking it. Ideally, you would use something like GitHub. So I'm not showing anything super relevant, but this is more or less what the document looks like, right? This is the builder image. This is the build type. Dependencies look like this, runner details. So just running something so you can see it, right? And I'm going to attach an attestation in there, and it looks a lot better in GitHub, right, or GitLab. So let's see, I do it again, submit, and now I'm definitely not going to use my personal account. And there we go, right? So it'll get the token received, and it goes and signs it, and off we go. SBOM is signed, now we have an attestation, now we can attest, and go again. And normally you would do this automatically, right? I mean, I'm just showing you the long route of doing things. You can run this in a Kubernetes job. You can run it automatically with existing projects like Kuverno, for example. And but yeah, like now I have attached a bunch of stuff like attestations around. Right, like the signature. It should have a little bit more. But anyway, demo effect. Right, if you want to verify it, it goes to the public transparency log. And right now I'm not really checking for anything. Here you could actually check for, I want this particular identity to have signed it. Now I'm just using a full regex, but I could have used my email if I wanted to. All right. Right, and it was verified, right? Because I just checked for Google accounts, and that's it. And that's the demo, right? I mean, the idea here is that, we'll see, images, present. You should be able to run all of these things systematically in a process by yourself, right? And this is not only applicable for MCP servers, you could also package skills this way, right? Like a lot of the agent skills today are from GitHub or Git repos. You could just put them in a container image and get a lot of the same checks, a lot of the same assertions and scans, right? So it's only good, right? Because an OCI image is not only about the things that you can run, but it's any artifact, right? As I said, it's just a glorified tarball. So you could do that. And the advantage that you get, as I was telling you a little bit before, was your IT department probably already runs a registry, or if you don't, you're paying somebody to do so, right? Like you may pay Docker, or you may pay GitHub or somebody else. You might have Artifactory in-house. And so you already have all of these things. You don't need extra infrastructure. But let's be honest here. I mean, I didn't come here to promise you that OCI is going to raise your children, walk your dog, and do everything, right? There's a lot of things that it cannot do. But it's a defense in depth kind of thing, right? It's one step around many things that you can do to secure yourself. Tool poisoning is an example here, right? An MCP server has descriptions that will make the agent do something that it's not supposed to do. An OCI image that's secure in a container can't really protect you from that. If you want protection from that, probably you're going to trust a trusted registry, right? Or you're going to run only approved and attested and secure MCP servers that you know about. But you could do something around that. I mean, you could sign or add the tool descriptions onto an annotation in OCI, and that signature will stick, and you could potentially verify it at runtime. That's a possibility, but again, defense in depth, you need many tools. Tool shadowing, right? Like an MCP server that exposes a tool pretending to be another one. Again, maybe a trusted registry would help with that, not OCI, right? Or rug pulls, right? An MCP server that all of a sudden behaves differently. OCI allows you to pin to a particular version and cryptographically pin, right? Not just the tag. And so potentially you could secure yourself with that a little bit, but again, like as MCP servers get updated, as they start running new things, maybe one of them gets compromised. And so rug pulls is something that, again, an OCI might help a little bit, but it's not the whole thing, right? But we're all here to learn. We all should get more tools to secure ourselves. And so run a scanner, right? I used Gripe, but there's a lot more out there. Use Cosign, right? It's an open source project. Validate your MCP servers and sources, right? Establish policies, and I'm sure your security team will be super happy to help you with that. And stay informed, right? And if nothing else, that's all. Thank you for listening. Only 6 minutes off. There we go.
Hi, I'm Alex Salkever. I am with the Agentic AI Foundation, and we are here today at MCP Dev Summit in New York City. As you can see, it's quite the scene. We're going to go out and talk to some people and find out what they think about MCP. Uh-oh. We're live streaming for AIF. Do you mind if I ask you guys some questions?
Hit me, yeah. I've already had somebody grab me, but you
Wait, already?
Yeah.
You guys already did him before?
Yeah, you can tell me again.
Never mind.
What do you want to know about?
So, Claude Code, Codex, or Cursor?
I mean, I mostly use Cursor, but that's mostly because I'm working in an IDE, so.
No worries. What's the worst YOLO that you've seen on your team?
I have not been working. I just started a job on Monday, so I haven't gotten
So
there.
you haven't gotten there yet.
Yeah.
How about you, Rio? You're at Node BGP, so you're security, so.
That's right. It's a whole different thing. It's like I live in a different world.
I'm also in security too, so.
We are all cloud code, so.
Very good. And so, what do you guys think is going to happen in MCP in the next 2 or 3 years?
Well, so 6 months ago, ancient times, I always thought MCP was like the App Store moment for AI. But nowadays, I'm thinking that you got to rewrite everything for essentially for agents. And so, I think CLI makes a lot more sense if you're talking to agents. And so, I think you're going to have a real split between the two things. So, I think MCP is going to definitely look a lot more like an app store. You're going to have very, very deterministic apps that are going to be built around that. Whereas I think CGI is going to be where you're going to have a lot more instrumentation of intelligence. So,
thoughts?
I'll go with what he said for right now. Yeah.
Thank you, gentlemen.
Cheers.
So I'll always hold it up. Okay.
Are you looking for someone to talk to?
All the time.
Wow, okay, you can talk to us.
Well, I mean, that's too easy.
I've been told worse. How are you?
How are you?
What are we
This
doing
is
here?
we're the Agentic AI Foundation.
I
So.
just had my talk.
Very cool.
Yeah.
What was the talk about?
It was the sexiest topic you can imagine, deploying MCP at scale without skipping compliance. So we're talking regulation.
So, you say sexy. Why is that sexy?
I was being self-deprecating because I don't think most people like to talk about regulation, but hopefully I made it kind of fun.
Why would anyone care about regulation when everyone wants to just YOLO all the time?
Well, you could YOLO so hard that you end up owing the EU Parliament millions of dollars. So.
Worst case that you've heard or seen?
I mean, the EU AI Act just started enforcement, so it's not, but like GDPR, like 4% of like your gross revenue could, per violation, that's pretty egregious, so that one's pretty bad. But TBD on the EU AI Act.
Makes sense, but then MCP security, what does it need to take care of that in the future?
I mean, I'm unabashedly biased, but an MCP gateway, in my opinion, helps with runtime guardrails, enforcement, security, logging, things of that nature.
And is there anything else that you would recommend to anyone who's doing MCP security?
Who's doing MCP security?
Or who needs to make their MCP more secure?
Obviously OAuth. I mean, that's just table stakes at this point, though, right? So, but yeah, I think if you're not doing that, what are you doing?
Very cool. Thank you very much.
Yeah.
So, how much more time do you have? Oops, sorry.
I mean, everybody talks about it, but I don't know.
Hi.
Hi.
You're on live stream. Is that okay?
Well, why not? I can jump into it. What are you guys doing?
What is Alpic?
Well, Alpic is an infrastructure platform to build and deploy your MCP and ChatGPT apps.
So why does this need to exist?
Well, because a lot of people want to have their own interface in Cloud, ChatGPT, and be able to show their product in there. But
it's kind of hard to build it. So we built like an open source framework that makes it super easy for developers to build this new AI application, AI-facing application. And then we just make it super easy for developers to go from building the app to make it available in the ChatGPT store.
And what's the craziest thing you've seen built on Alpic?
Well, we've seen video games in ChatGPT.
Video games in ChatGPT, you mean as ChatGPT apps?
A ChatGPT app that is actually a game, and you play with the model or against the model or with the model on this kind of new video game. That's pretty crazy.
How was that built? Was that built on like a Godot engine MCP or something like that? Or?
So it was built with Skybridge, which is our framework, which is basically UI components in React plus MCP server. And that was basically it, and some intelligence some backend behind the MCP server, and then leveraging in a smart way the model so you can play with it with prompt on the MCP. It's kind of cool.
And no latency issues?
Well, it depends on what you're coding. If you're coding the model, it's just right away, so it goes very fast because you're in ChatGPT. So you just have to make it fast for everything that when you're coding the tool, that it's not too heavy. So you have to bring back some components that are loaded at the beginning so you can reuse it instead of like reloading everything.
And so I'm curious, with something like Alpic, how do you keep bad actors from getting on the platform and using you or something like that?
Well, one tool that we have for our customers is to actually restrict the access of your MCP server to only ChatGPT or Claude. So it's not like in the wild and everyone can connect to it. We have like IP restriction and ID restriction, so it's only users in ChatGPT. So if there's bad actors in ChatGPT, well, it's ChatGPT problem and a little bit, but they try to keep them away. But at least you don't have an MCP server in the wild that can attack it or block it. That's one of the things. Then we also have like some rate limiting, some caching. You can put like some sort of like bot protection in front, but it's kind of clunky because what is the bot protection these days? So
bot protection from bots?
That's the thing. It's like, yeah, it's a new world existing.
Very cool. Well, thank you very much for sharing.
My pleasure.
How much more time do we have? 1, 2 minutes? Okay. Sorry, looking for interesting people. Hi, can we interrupt you?
Sure.
This is live stream, by the way.
Okay.
What is Augment Code?
We are an agent orchestration platform.
What does that mean?
We are helping developers build specs, implement specs, and help, I guess, in their coding practices.
So how do they use you?
How do they use us?
Yes.
Go to augmentcode.com and download Intent.
I'm sorry, I'm supposed to hold the mic for you. I'm a rookie.
Okay.
But I'm actually with the Agentic AI Foundation. So.
Okay.
What is Augment Code built on top of?
Context engine.
And how does it fit into with like harnesses or different, coding agents, things like that?
That is. Sorry, you said it again.
I probably said it the wrong way.
Yeah.
How would you say this fits in with other components inside of, Claude Code, OpenAI, or Open Router, all the different pieces of the ecosystem?
We integrate pretty seamlessly. I mean, we're partners with a lot of the different models, so we can integrate pretty seamlessly through integrations, APIs. It's kind of pretty simple to integrate with other sorts of tools.
So the goal of this talk is...
And what's the most interesting thing that you've seen people do on Augment Code?
We had a hackathon actually internally, and people built, like on the sales side, they built a lot of like account prioritization tools, account research, things to help organize their day-to-day. It was pretty intuitive and very much in-depth.
Cool, thank you very much.
Yeah, thank you.
Thanks. Thank you very much. I guess we're signing off now? Okay. Sorry, I'm with AIF. We're just...
Perf events
And this lets you do some really powerful analyses that you just couldn't do otherwise. MCP also makes this data conversational. So you can ask questions like, why is this process stalling for 50 milliseconds? So we have a really nice, useful human interface. But some of the problems that this also helps solve is BPF tooling has a really steep learning curve. If you haven't written BPF before, it can be very painful, and you have to understand the data model and the execution model in the kernel to be able to write BPF code. It also unlocks hypothesis-driven investigation, where AIs are actually really good at taking really wide-dimensional data and to be able to ask questions and do complex analysis over it in a similar way that like a performance engineer would. So what is BPF? Just as a really quick one slide, it's basically, it runs inside the kernel. It's a JITted runtime. It's verified when BPF programs are loaded, so it can't crash your kernel. And you get basically near native execution with the JIT. It also has access to what are called core data structures, where you compile once and run anywhere, so it's able to run across different kernel versions and still work the same. And our key insight is BPF lets you add that custom instrumentation to a running kernel without writing kernel modules or even rebooting. So what's our plan? We want to build a BPF MCP tool. We're going to talk about SEXtop, which is a scheduler MCP tool, and some of the uniqueness about that. And we'll talk about some of the problems you'll encounter when writing BPF tools and some best practices. So for building a simple MCP tool, we're going to start really simple with a single trace point, one ring buffer. A ring buffer is basically how you pull events out of BPF and into user space. We'll have 5 different tools, and we're going to use JSON synchronous standard I/O. And for this example, we're going to use libbpf-rs. And there's a lot of different frameworks that you can use, but for our example, we're just using this one direction. And there are some, because this is a simple example we're going to walk through, we're not going to cover permissions and security. And also, as part of that security model, you can have AI agents generate BPF bytecode and load that into the kernel. That's a very dangerous thing to do, so we're just going to keep it simple. So, for building our MCP tool, there's a reference if you want to follow along. It's on my GitHub at HodgesDS and BPF-MCP example. And for this, we're not going to cover things like complex BPF event types, BPF map types, task storage, stack traces, or sampling. We'll get to some of those later in the talk. But our example is very simple. So we have a 5-step process for building our simple tool. So first we need to define our BPF events. Then we're going to write a BPF program that uses those events. We're going to set up ring buffers to communicate from kernel space to user space. Then we're going to do aggregation of the data and expose those as MCP tools. So for defining BPF events, we just have a really simple event that we're hooking into. This is the sched switch event. And this event happens every time a process changes from one process to another in the scheduler. It fires this event. So we want to capture that and understand what's happening. So we have a very simple struct where we have our event, we have an event type, which will be important later in the talk when we talk about how to collect multiple events, and then just some common fields like PID, task name, things like that. So for our BPF program, we also need the ring buffer. The ring buffer is the interface from the BPF kernel space to user space. And it's just defined like this as a simple struct with a name called events. For our BPF program, we'll have event handling. There's a couple interesting things here to unpack. At the very top, there's a yellow highlighted section of code. it's basically a macro that says we're using BTF to attach to the sched switch trace point, and it's just a macro that attaches to that specific event. Then we have our program definition, and here in white you can see where we set up our event and ring buffer. We reserve a entry from the ring buffer, and in the green we just kind of fill out the fields in our struct using various BPF helper functions. And then finally in the white we submit the event. So that's basically a very simple BPF program. So on the user space side, we also need to set up the ring buffer so we can consume from it. So I'm going to go through this pretty fast just to get through all the slides, but all this is on the GitHub if you want to follow. But anyways, libbpfrs has this ring buffer builder, so we build the ring buffer builder. We had a callback that basically runs every time it consumes from the ring buffer. And in green, you can see we're switching on our event type and then processing the event type where we're recording the sched switch. And lastly, we have to consume from the ring buffer. So this is also Rust, by the way, if you're not familiar. But basically, with our ring buffer consumption, we're launching a background thread where we pull from that using epull, and then we just consume from the ring buffer. So now we need to aggregate the data. So basically, we're transforming our kernel events into structured user space data. And in this, we can also have we can parse our event from Rust, which gets generated. And we can also aggregate that into a stat struct. So aggregation can take various types of form. For our example, we're just going to aggregate in user space, and there's a helper method that resets all the stats. But basically, we're just using a hash map to store all our events. And here's the record switch implementation, where it's basically just updating the map every time and keeping track of when one process wakes another one up. Finally, we need to expose this via MCP. So we have our basic simple JSON of our different endpoints for the MCP server, such as get scheduler stats, enable collection, disable collection, and this allows our MCP tool to be discovered. And one last final detail for the MCP server is we want it so that because BPF programs vary in complexity and can have different amounts of overhead, we want a enable and a disable method. And so what this does is it basically loads the BPF program when that tool is called. So the tool gets called, it can run, and then when the disable collection tool is called, it unloads the program. So you can see in green where basically the call to the attach of the sched switch program happens. That code path is basically saying like the BPF program has been loaded successfully. Otherwise, we hit the red state where, if it's already attached, we fail out, or we just error if we couldn't attach. So to recap our simple MCP server, we want to follow our 5 steps of defining BPF events, writing our BPF program, setting up ring buffers, doing aggregation, and exposing that as MCP tools. But this simple example leads to many interesting questions of, what if we need to handle security, right? We may not want to just have AI load BPF programs that can do, nefarious things, right? We also want to discuss, should this just be a tool versus MCP? So some of the problems with having it be a CLI is you need implicit permissions to be able to run the CLI. And if you're running it as root, then maybe that's not great. Versus exposing it as MCP, where you can have different protocols such as HTTP to have a secure MCP server running. And the other thing we want to know is, can this pattern scale to large machines and large number of events? And the other question we want to think about is, would this work for large deployments? Could you deploy this on every machine in your fleet? Or is this more for debugging? So let's switch gears a little bit and talk about an actual MCP tool. So this tool is kind of built around SCEDX. So SCEDX, if you're not familiar, is a way to build a scheduler in BPF. And you load the scheduler into the kernel, and it makes all scheduling decisions for you. So with this, we started out with a lot of observability with BPF trace scripts. But eventually it got to the point where maintaining all sorts of just BPF trace scripts got kind of tedious. So that's why I started working on SEXtop, which is a way to aggregate those scheduler events and try to make sense of it. So the architecture of it is there's both the kernel side, which has various BPF programs. I think it hooks into like 15 or 20. And then on user space, there's a couple different ways that it works. It has a TUI mode, which is kind of like a top. It's built in Ratatouille. It has an MCP mode, which allows you to connect to agents or other things like that. And it also has a trace mode to generate trace data. We'll talk about trace data more in a little bit. But the really interesting thing here is there's an event processing layer that decoupled the TUI, the MCP, and the trace mode. So as you're consuming events off the ring buffer, they go through a generic event dispatch layer. And that allows it to scale pretty well. There's also multiple ring buffers. So one of the things that we noticed is that when you're collecting a large number of events, let's say on a machine with several hundred cores, we'd start losing events because a single ring buffer just couldn't keep up. So we had to shard those out. So you could do sharding based on things like L3 cache, NUMA node, things like that. But it all comes down to like how many events you're pulling off of the ring buffers. So here's just kind of an example of one of the TUI views where you can see it's just basically like a top-like program. But it also has some more advanced TUI views where you can see detailed scheduler stats. So this is a scheduler view where you can see different things. Different queues are called DS queues, and you can see the hex over here of the different dispatch queues, and then aggregations of queue latency based on P50, P90, P99, et cetera, and queue depth, and then sort of process views where you can analyze and see which processes are experiencing the most scheduling latency. It can also generate traces. So depending on the type of data that you're collecting, you can also generate Perfetto. Perfetto is it's basically a whole tracing and profiling framework that's developed by Google, where you turn those events into protobuf events, and then you can load it into the Perfetto UI and be able to run complex SQL queries and also do very interesting analyses using the Perfetto UI. So this just is an example of some of the scheduling data where you can see per CPU views of what things were scheduled and for how long. So SEXtop also has an MCP analysis where it can do a lot of different, or it has many different tools, but you can sort of ask questions like, which queues have the most delay, or which processes are experiencing the most scheduler delay. So in this example, we can see different processes being exposed. We can see how many times they're context switching, what's their average latency, what's their max latency. So if you really care about performance of your application, it can be a pretty powerful tool. And it could also tell you which queues are being hit. So here's a brief overview of the different MCP tools. I'm not going to cover all of them just because there's a lot. But they're kind of broken down into different categories. So it can do dynamic runtime profiling, where you can start and stop profiling. It can also do live analysis of Perfetto data. Also just loading Perfetto traces. So it has a mode where it will take a trace and then be able to load it into its process memory, and then also do analysis across that trace by doing generic queries just like you would in the Perfetto UI or CLI to do aggregations of P99s or P50s, whatever you really want. It also has exposure of hardware and topology and different events that are available on the system. So one thing that AIs really need to be aware of are like, what events can I actually profile? So it's important that it has tools that allow you to do these different types of things. So one problem that we have when we had our simple example that we needed to solve with SEX-Stop was, how do you deal with multiple events coming through the same ring buffer? And I kind of talked about the type earlier. So basically we have a generic BPF event struct for SEX-Stop, and one of the first fields is the type, so that it can be parsed in user space. And then we have a set of common fields here, such as size, timestamp, or CPU. And then basically our events are just one big union. So you can see we have fork, exec, sched switch, perf sample event, etc. So that's basically the way that if you're building a BPF MCP tool and want to have different messages over the same ring buffer, you can just use this pattern. Another problem we had that I alluded to was high frequency events. When you have just sched switch, it can do many tens of thousands or hundreds of thousands of events per second, and that generates a lot of data. So depending on the type of data that you're doing, you may want something like a per CPU counter. And without going into all the different BPF map types, here's an example of a per CPU counter. So we just have like a generic stats counter here in the white on the left. And in green, we can see it's a map type per CPU array. And that's really cheap if you're just collecting counts of events that happen. If you don't want to know like specific details and just counts, it's a highly effective way of doing it. And then on the rest side, we can see in the green where we load up our BPF skeleton. We can look up per CPU data for the stats map that we have defined. And this code is just very specific for this use case, but once again, if you're implementing this in whatever language, it'll be not too different. So we also have the problem of if you're tracking an individual task, let's say you're interested in like what's the latency of my Chrome tab when I'm watching YouTube. I want it to be scheduled so the audio doesn't crack or things like that, right? So we need a way to track per task. And for that, we use this special map type called task storage. And basically what it allows you to do is have basically allocate an event that gets stored on the task struct, and you can update it and do various things like that. So that's very useful if you're trying to get a full trace of like when a task wakes up until it gets scheduled, or when it goes through various events. You can use a task storage map. Another problem that we kind of ran into was PID is not a stable interface. So if you're just trying to track different events and store a PID into a BPF map and then do something based on that PID later, the PID may have changed because the PID life cycle is shorter than the actual task struct existing. So a trick we had to do with that was basically we take the task pointer, convert it to a U64, and then use that to store into our maps as a stable way of updating or tracking an individual task. And that's useful if you're doing aggregations across like task, but not doing task-specific storage. Another problem we had to solve is what happens if you want to do dynamic tracing? You may not want to have a BPF program for every single possible trace point. You may want to select that dynamically. So on the left here, we can see we have a static K-probe for BPF SEX reg, which is when a scheduler gets registered. And you can see we have a special type in green. We give it a timestamp, do the ring buff. That's all good. But on the right side, here we have a generic K-probe. And what a generic K-probe allows you to do is, from user space, say, I want to attach to this specific event. And the really powerful thing about that is you don't have to know the event ahead of time on the BPF side. And we handled that with this BPF func IP, CTX, which basically gives you the function pointer. And we set that on the event. And then we can use that to look up the function address in user space. On the Rust side, it's also just, we have this attach K-probe function where we can say, I want to attach to TCP send message, right? And it's just a pretty easy interface to use. Another problem we had is if you want to call into BPF from user space, there's this API called BPF prog run or test run. It originally was used for testing purposes, but you can kind of hijack it to use it to run any BPF event. So on the BPF side, you can set up a syscall, and here we call SEX top init. And for this, we're just initializing a bunch of timers and doing other setup that we need for our MCP server to work. And similarly, on the Rust side, there's a API where we first reference the SEX top init program, and then we can call into it using the test run, which libbpf abstracts for us. There's also program input, so you can get you can send data to BPF from user space, and then do whatever you want with that. It's not shown in this example, though. So permissions is also a problem depending on what you're trying to do with BPF. So BPF needs either root or capsys BPF and maybe a number of other permissions depending on what your tools do. And that may be far more permission than you want to give to your agent, because that's a lot of permission. So when we're dealing with that, another thing to consider is we have local instances and remote, and where you collect that data becomes kind of important. Sometimes it's better to just run a tool to generate a trace or generate some dump of the data, and then do your analysis on a machine with less permissions. And this also is kind of an issue that needs to be considered of if you have a continuous process that you're monitoring your entire fleet, or if it's more, or if you're building a tool for one-off debugging. Maybe it's okay to launch it with sudo, and that's fine. So as I mentioned, SEXtop has a trace subcommand where it can just collect the Perfetto data, and then you don't have to worry about permissions as much, or it's more isolated. And that way, for analysis, you don't have to worry about permissions. Another problem we kind of went through, I'm going to try to speed run so we make it in time for questions, of event aggregations. Basically, as I mentioned, ring buffer and having multiple of those is what you have to do to get it to scale on machines that just have a lot of events and a large number of CPUs. You can do aggregation in BPF. BPF trace is a pretty common tool that it does that for you. So that's another method as well. So to recap, for BPF, if you're scaling to large machines, you need ring buffer sharding. You want to do sampling where you can be able to control sampling through the life cycle of a task, which probably means you need task storage. If you want to do really high resolution timers, You probably want BPF timers for that, for sampling at very high resolution intervals. You can use per CPU maps for high throughput data that needs to be collected and aggregated if you just care about counts. And syscall programs allow you to basically call BPF from user space. So some of the best practices for MCP tools, basically know your BPF life cycle and have that be well defined. You don't want, or depending on the tool, you may want it to run consistently, or you may want it to have a short-lived life. The MCP tool should also have discoverability for the different events that it supports. So if you've ever used like perf, it has perf list, which lists out all the different perf events, or BPF trace L. But the danger of that is you also need to return like filtered data, because it can blow out your context really quickly because there's so many events. And also, if you're trying to build tools that analyze BPF, having some way of giving it topology awareness, a lot of times it can shell out to like LSCPU or things like that and get some of that data, but you can also build it into the MCP tool itself. And then finally, having a data storage strategy that makes sense with the data that you're trying to collect and what you're trying to do. So if you're doing trace analysis, Perfetto is pretty good. And for analysis tools, a lot of times you need to join with other data sets. So often you'll want to join it with like kernel source code or user space source code. And you may want like actual perf data coming from your metrics data or hardware counters. So depending on where that lives and how that's structured, you may want your analysis tools to have access to all those. So it may mean making a really big set of MCP tools, or just having a bunch of separate MCP tools. Okay, so how do we generalize this to solve pretty much any problem that you would face or your company faces? I think there's a lot of opportunities for security, observability, debugging, networking. There's just so many areas that BPF can just give you insight that, you know, there's not a lot of tools right now that are kind of built for AIs to use. So like SEX Top is just a very niche thing for understanding BPF schedulers, but you know, this could be generalized for almost anything. And then just some of the considerations of making sure you understand the data model, the security, and how you want the tool to work. All right, I left 2 minutes, sorry. Any questions? And I have a bunch of stickers if you want. I'll have them in the back afterwards. So, question?
I know this whole talk was about kernel space. I'm just curious if you know anybody who's doing something similar for like a JVM kind of environment with taking like bread dumps and so forth, like doing that kind of analysis.
I'm not personally aware because I don't work on JVM stuff, but I think the same lessons could apply for like JVM thread scheduling, things like that. The JVM does have a lot of like points where you can observe it, so I think that's a really cool idea. Yeah.
I have a question about your sort of end-to-end workflow here. So,
Yeah.
like, where are you kind of coming from, like at a starting point? Like, what are you asking your agent to do? Is this like, are you asking to do this sort of like pinpoint, like I want to do this Perfetto analysis, or like did you have some other problem that you were starting from, and like what is the whole kind of thing?
Yeah. So like, I work on the BPF schedulers themselves, and I also work on doing deployments of those for specific services. So sometimes I need to understand like why a scheduler is not performing as well as another scheduler. And so for me, if I have a way where I can feed in the scheduler source code and a bunch of raw performance data, then I can understand like why is the scheduler working in this specific manner, and what does it mean when I see these specific perf events. Yeah. Cool. All right, if no other questions, thank you for your time.
Okay, mic check. I'll let you can hear me. Okay, I'm just checking if folks are still coming in. Let's give it a few seconds. All right, let's get started. Thanks for coming. My name is Darius. I work for Broadcom, and I work on the Spring OSS team, and I work on the Java SDK. Right. I'm going to be talking about Java and the lessons learned from building the official Java SDK for MCP. But before I get started, I'm really curious who of you is working with Java, so I understand better. All right, it's probably all of you, almost. So some of the things I'm going to share are not going to be news, but it's worth reminding ourselves why we are really well-positioned working on Java with AI. So essentially, Java is widely adopted in their enterprises. It has over 30 years of presence in production. And according to reports, I linked to them below, we have around 30% engineers using Java extensively, according to Stack Overflow. There's also a claim that around 90% of Fortune 500 companies use Java. And enterprises are adopting it for their business logic, their mission-critical systems. And mostly Java is very good at integration. It's really easy to write programs that connect to other programs, and there's a very broad ecosystem of frameworks and libraries that you can use and rely on. And current Java focus, we are like 2 weeks after the Java 1. The current focus of the evolution of Java is essentially around integrating with AI on both ends. While talking about MCP, we have quite good base, but at the same time, Java is also considering and trying to get in front of GPUs and be able to be really performant and be able to train models, and as well to make inference. But most of all, people rely on Java because it's like super performant, right? And I want to show you a graph of independent research that has been published recently where the Java SDK was compared to other MCP servers. As it turned out, might not be a surprise to you, but it is to some. Java is the best performance ratio in terms of latency throughput, while at the cost of some memory. But there are ways to optimize Java as well. So underlying this performance beast that Java offers is the JVM, the Java Virtual Machine, where you essentially have the foundation of the language that is statically typed, that enables a lot of optimizations. And the underlying technology making things possible is compilation to bytecode that is interpreted and with a just-in-time compiler can be made super performant on the hot paths while running. There are also other alternatives to the JIT, but I'm talking about the JVM per se. And there's also the other aspect, which is dynamic memory allocation and control with like best-of-breed garbage collection algorithms out there. And Java SDK has been contributed around the end of 2024, so just after, very soon, as MCP was announced. We started working on it. We donated it as a public SDK within the Spring team. We also accept a lot of contributions from our friends and collaborators. The team is composed of 3 people right now, Daniel, Christian in the middle, and myself on the slide. So how did we design the SDK in general? We wanted people to have a quick start, to learn, to experiment with MCP. And I want to highlight what are the foundational principles that we had when we were building the SDK to cater to a broad ecosystem that Java is in. So what we decided is that because the JDK offers just building blocks that frameworks actually combine to make people productive, we essentially needed to focus on how you can combine these things so that at some point you can take it to production, but you don't limit people from exploration. That's why we considered an SPI approach, which is like a service provider interface that doesn't carry on an implementation, to be too minimal for something like MCP, which you want to take and experiment with. So an example of that is like JDBC, which you need to actually include a library to talk to your database. Well, with MCP, that was a no-go because we wanted to be able to iterate quickly and start with something. That's why we decided an SPI is not useful for a quick start experience. So we started building around the JDK HTTP client, which we based the MCP client around. There's also the widely known Jakarta servlet specification, which essentially is the continuation of the Java Enterprise. We implemented something called the MCP Server Transport Provider around that abstraction. However, bear in mind that this is not production ready. You need to pick a framework. You need to choose a set of libraries that actually build upon years of experience, bring the trust that you want around authorization, around observability, and enterprises actually need to rely on those tools. So that's why we want to be an enabler for enterprise adoption. So turning to MCP, which is on the other end of the spectrum that enterprises are, it introduces a lot of churn. And I'm going to focus on one aspect, which is the transport evolution and how statically typed language and our approach has worked with the crazy pace at which Gen AI is going. So as you are probably aware, we started with std.io. We have separate channels for communication, and over those channels we have JSON RPC messages that are flowing. The next step was the introduction of the remote specification using SSE that essentially now allows us to connect remotely to servers. It added a level of complexity that was partially solved by a best practice called sessions that we started to experiment with. That was later on codified with the streamable HTTP protocol. But you probably have already heard that the streamable HTTP is also going to change with the stateless approach. We already started to explore that as soon as streamable HTTP was unveiled, because we essentially saw the need of large-scale adoption where servers essentially were limited from scaling by the sessions and the mechanism for maintaining a persistent connection. That's why we introduced in the SDK a concept of stateless transports from the beginning. That essentially takes away the ability for the server to communicate back with the client and just serve responses. So what were the engineering trade-offs that we went through when we were actually going through the journey of changing those specifications in the protocol, in the transport layer? One idea that you could consider, and some SDKs have taken this path, is to add to an existing transport abstraction over time without breaking the API. One advantage of that is quick iteration. You can keep adding things as you go, and you are quite productive. However, that risks duplicating logic. That introduces conditional logic inside both the implementation and the user space. It also risks implementation errors internally. And the worst of all, it carries on the risk that users are entering this space where they surface errors, such as you try to elicit the client, but you are running on a streamable variant that doesn't actually have a connection to the client. So we wanted to avoid that. Our idea was to incorporate strong type safety into our SDK. And with that, there's a compromise. We iterate a bit more slowly. We needed to introduce API breakages. We were still at 0-point versioning scheme. So we could do that. And our users have adopted that because it was actually the way to go forward because the protocol was changing. What we actually benefited from was the lack of duplication that resulted in no conditional logic in the client code, in the user's code, and also in the implementation of the SDK. And it's much easier to reason when you have dedicated implementations, and essentially that saves us from implementation errors. And the best part of all is that users are unable to enter those erroneous states. And I want to give you some code examples so it's easier to understand what I'm talking about. So we, in the Java SDK, we have builders where you start assembling either an MCP server or a client abstraction using a construct like this. You type mcp server.async, and an argument to this builder is a particular transport. So in this example, we are talking about the MCP streamable server transport provider. And once you call that, the result that you get, a builder object that you start assembling, is a streamable server async specification that allows you only to enable features that are dedicated to this particular workflow. On the opposite spectrum is the stateless server transport that you can also provide as an argument to that building machinery. And that gives you a stateless async specification, which limits the amount of operations the users can deal with so that you don't have an elicitation, for instance, in this case. How does it work when you start defining tools or resources? In the case of the rich experience with sessions, that's where the streamable specification lies. You get, for instance, a way to specify the tool call handler, and you are essentially faced with the exchange that you are able, as an implementer of a tool, to take advantage and talk to the client. So the server author might call exchange.create elicitation and work on the response. There is also it's the commented outline, exchange.transport context, where we essentially abstract away the transport from the actual tool implementation because the MCP logic needs to be decoupled from transports, right? You don't have to know whether this implementation is in an stdio context or remote SSE-based execution. So there's a means to create this transport-agnostic information, for instance, about authorization. So you get access to that as well. On the other hand, if you are working with the stateless async specification, you get the argument being limited to just the contextual information. You don't have the exchange anymore. That means that if you are implementing a tool, you don't have the ability to call it elicitation. You don't enter a state where you would try to send something to the client, but you cannot. So that's quite useful, we think. The other aspect of MCP is the asynchronous nature introduced by the JSON RPC, being as the envelope type underlying the protocol. Just to remind the slide, with separate channels of communication, we have to map requests and responses that arrive on those different channels. So the concurrency of the protocol is built into the nature of it. And how does Java actually facilitate us in writing these primitives? Well, multi-threading has been core to Java since the very beginning. And Java threads, since the inception, were essentially backed by OS threads. That means the OS threads are a scarce resource. You cannot create hundreds of thousands or millions of them. There were early experiments with lightweight threads, but that has been put to halt. And very recently, in Java 2021, virtual threads were introduced with the project Loom, which allowed us to address the scalability limitation of Java. However, we also need to keep in mind when working with a broad range of versions in Java as SDK developers, that some problems are solved in a set of versions, and we are catering to people who might be on older versions. So one thing on one end is that in Java 24 only, one problem introduced with the virtual threads in the beginning was something called thread pinning, where that particular situation where a thread would occupy a platform thread would essentially limit scalability and disable this concept for a lot of users. So we could ship our SDK just to Java 24 plus users, but that's a no-go because Java 17 has been established across frameworks and libraries as the current baseline for a lot of them. So we decided we will stick to Java 17. And the future also is evolving for Java with structured concurrency being on the horizon. It is still in Java 26 a preview feature. And the other part of the equation is the streaming. And streaming in Java has been quite difficult to speak, frankly. There are some basic building blocks like the input stream, which just operates on bytes, and we want to consider high-level objects. You might use a blocking queue. However, a blocking queue itself has no life cycle, which we also need to consider. So there is a lack of higher-level APIs for I/O streams on higher-level objects. There is no channels abstraction in the JDK that you can take advantage of in other languages. There is no framework such as async await. And the solution to that typically has been reactive streams, which have been defined in the Java community even before Java 8. So we decided to stay pragmatic and start building around Java streams. However, in the future, Java might consider adding channels, and we would be able to take advantage of some new developments there. With that in mind, the way we created the Java SDK is to create a reactive core, which we are wrapping with synchronous imperative programming style primitives, which you can see from those builders that you start with either async or sync words. And then you define the particular transport to work with this particular paradigm. And our plans for the future are to look into a unified, Loom-friendly API that provides an imperative blocking style that most Java developers are familiar with and happy. So that's the direction we are heading. We have an issue to track that story. And one other angle that we needed to keep in mind all the time when developing the SDK is openness for extension. Like I said, we are not just creating an isolated product with the SDK, we are catering for frameworks. And the biggest question is, how do you actually support auth in the Java ecosystem? We are talking about enterprises that have vetted in security solutions based on their particular framework offerings. We didn't want to rewrite all of that. At the same time, there is no OAuth 2 library in the SDK. Some language runtimes offer that kind of support. We didn't have such an option. there is also no common HTTP server abstraction in Java. You know that there is a servlet API. However, there are other options like Netty, like Undertow, that don't build on the servlet API. So we don't have an easy task here. And also in each framework environment, you have a multitude of HTTP client options that you might want to choose and connect to your authorization library. So that's why people essentially choose established, battle-tested auth solutions in their respective frameworks of choice. As I said, these choices are approved by security teams, and we didn't want to re-implement all of this in the SDK and risk CVEs. So that prevents us and also the companies that run this SDK in production. So we want to essentially provide the best experience in the relative stack. And our goal has been to provide hooks that allow frameworks and libraries to essentially work with the SDK, but the SDK is not concerned with those primarily. It enables authorized flows. So how did we actually approach this inside the SDK? For the server, we provide those context extractors. I mentioned that there's an access to the MCP transport context inside tool execution, inside resource handlers. A particular API inside the SDK might look like this, where you have the HTTP servlet streamable server transport provider. That's quite a mouthful. But on top of this builder, you provide this context extractor that gives you access to the servlet request that you can extract headers from, that you can essentially take a header and put inside this MCP transport context, just like that. And that allows the tool execution to take advantage of that. For the client side, as I mentioned, we are working with the HTTP client from the JDK. We provide this builder as well that you can provide a request customizer on top of. That gives you access to those various things that are available when the request is being created. And you can also extract the header from the context that this MCP client interaction is happening in. And you can essentially attach that to the outgoing request. That's how you essentially add the authorization header, for instance. Specific frameworks can have different approaches to this, so this might not be the way that it is implemented in Micronaut or in Spring, but if you are building your own, you might take advantage of this approach. And there is also the authorization error handler that allows to build flows that actually work with authorization when you get a 401, for instance, and you want to retry the request and actually authenticate the user. On the JSON serialization aspect, we also wanted to stay pragmatic. We decided that we are going to use Jackson, which is a leading JSON parsing and data binding library for the Java ecosystem. However, at some point we were reached by the Micronaut team that they would like to replace Jackson implementation with something that they ship, which is an optimized version for JSON parsing. And we settled upon the Jackson annotations library as a common abstraction for data binding. But the definition of mapping from JSON to the Java types, but the actual parsing and binding is going to be achieved via pluggable approach. That means that inside the MCP core, we just have the Jackson annotations dependency, and the types are defined, and there are abstractions for JSON parsing that actually is accomplished by a module inside the SDK for Jackson that provides the implementation. And there's also a convenience module. If you just want to have a single dependency, you can just use MCP, which provides Jackson 2 in case of the 0-point version, and the stable one ships Jackson 3, which was released actually last year. And this whole exercise with the Micronaut team enabled us to easily introduce the Jackson 3 dependency into the picture. So what are the key takeaways from the exercise and our learnings building the SDK that works with other frameworks and not just experimentation? We think you should stay pragmatic when building such a thing and choose something to begin with, and you can evolve as you go. But at the same time, it's important, especially if you're working with Java, to cater to a broad ecosystem. And it's worth thinking in these terms. I think it's useful for other SDK designers as well to try to protect the users and the implementation by making undesired states impossible via type safety. At the same time, being open to extension and use cases that might not be obvious from the beginning, especially in enterprises which might run their own quite elaborate authorization schemes. So that's all I have. Thank you very much, and I'm open to questions. Yes, please.
So how can we implement retry or circuit breakers in MCP ecosystem?
You mean retries from the client perspective or on the server side?
Both, like client and server.
It depends probably on the stack that you're running. If you're on a particular server, let me repeat the question so everyone hears it. How can we implement circuit breakers and retries with the MCP Java SDK? And as I understand, it's quite specific to your use case, but if you are writing a client with just the Java SDK, in case of the reactive approach, you can just use reactive operators that allow you to do those things. If you are writing a synchronous, using the synchronous APIs, you can just use the regular language constructs that allow you to catch exceptions and retry things. However, if you are talking about circuit breaking, then there are options to choose from as well as library dependencies. If you are thinking about authorization schemes and things like that, I'm keen to hear a bit more to be able to answer.
So we are in Spring. It is in Spring. So if you're developing REST APIs or something, right, we use usually resilience for J. So is it the same or like MCP works in a little different way? Because we annotate those with the tools and all, right? So is there any difference between the REST and the MCP of defining these kind of protocols?
So the question kind of continues to be around using Spring in particular and combining that with resilience for J and how that fits in the context of MCP. And well, depending on your actual context, I think we would need to kind of try to take it offline and discuss this a bit further, because it's not really a concern of the SDK itself, but I'm sure there are ways to solve it in a particular case-by-case scenario.
Okay.
Let me take a question from here.
What's keeping the Java SDK from being a tier 1 SDK?
Well, we are still lagging behind the latest spec from November, so we need to implement those features. We have a plan to do so, but at the same time, we need to make some cleanup on the JSON parsing aspect. And we essentially want to be a tier 1 SDK. That's our end goal, definitely.
Are you currently conforming to all the conformance tests? Do you pass all the conformance tests?
We are a tier 2 SDK at the moment, and the conformance tests are essentially for the latest spec. So in our case, tier 2 requirements are that you implement the latest spec within 6 months. So we are essentially meeting the requirements of the November spec in full. However, for the latest spec, we still have that backlog that I mentioned. All right, thanks so much.
My name is Sterling. I'm a founding engineer at Arcade. I work on our core product, and I do some work on our infrastructure. And part of what I have done in the last year is work on our MCP integration. Arcade's an MCP runtime. We manage auth and governance for agentic tools. And we also provide a evaluation suite and hosting for MCP servers. So I'm going to talk about my experience adding MCP to our product. It was something that I thought would be a simple task for us to do, and ended up becoming a drawn-out process that wasn't as straightforward as I had imagined it would be. So integrating with MCP was hard. I initially started doing it when streamable HTTP was added, and along with OAuth, so version 2. So initially, I wanted to try it out. I made a standalone script. I just got an open source SDK and tried to test it against a remote server. First server I used worked. Second one didn't work. The next one also didn't work. So why wasn't it working? I wasn't sure. Was it the server that wasn't implementing something properly? Was it the client that wasn't implementing something properly? I saw people at our company having issues with this too. If it was, a client like Cursor or Claude that they wanted to add an MCP server to, or just like an SDK, they would also run into issues with some servers every now and then as well. AI has helped to open up development and these tools to people that aren't developers. So if I'm having a problem figuring this out, what are these people experiencing? So we analyzed the entire ecosystem of MCP tools. We took some of these servers from registries. I'm sure you've seen there's tons of lists of servers that you can use. People compile them all the time. We also found smaller projects that people were building on public repos in GitHub. And why we included non-production servers into this is, think about when you make a project and you use an HTTP client. We assume there's guardrails to make it hard for you to mess it up, and you expect them to just work. So we should assume that MCP itself, if we pick up some client that's provided to us, will also be 100% compliant. To get this data, we built 2 tools internally. One is called MCP Debugger. It does live tests against servers, gives you information about parts of the spec that fail. It shows you the risk of not implementing that, or that it just may not work. And it gives you a link to remediate it. So it helps us internally understand, is it us making a mistake on our clients, or is it the server we're connecting to that's not working properly? So most of the data I'll be talking about is from this tool. We have a couple hundred servers that we use this on, but it's a bit smaller than the overall scale that we have, because we have to actually run the servers ourselves or have it already hosted in order to test against them. The second tool that we use is called Toolbench. It's our static server analyzer, so we can give it the code. It will, one, tell us the quality of the server in terms of, does the code itself comply with the spec? It needs to be things that we can actually look through and check in the code itself. How much functionality does it support? Is it just tools? What other resources can you use on that server? And then we have other metadata like the framework and owner of the server. And we found that 94% of servers we tested failed some kind of test. So only 6% fully complied, 9% failed one check, and 85% failed 2 or more checks. For context, this doesn't mean that they don't work. You may be able to use it, and you may not even notice that there's something wrong with it. It may work perfectly fine. But you can introduce security issues, or the client may have to rely on fallbacks instead of being able to use the initial path it was supposed to take. So for examples, a lot of servers don't validate the origin header when they get requests, and a lot of them also don't return a www authenticate header. So very minor. If you're using a pre-built client, you probably haven't even noticed it. But it does have implications. These were also, we compared them against the version of the spec that the server advertised, because in some versions it may be suggested that you do something, and then in a later version then that is required. So we made sure to not count things that are currently required against servers that were previously built. So let's dig in, let's figure out what's happening and what we can do to fix it. So first, the spec is moving really fast. We've only had 4 releases, but every release is really big. They're not little patches. They're new functionality, changes in functionality, changes in the transport itself sometimes. So like I said, in the latest release, we changed some suggested things into hard requirements. So as a developer, if you're building a client or you're building a server, you now have to support that new functionality. You have to support the changes in functionality. You have to test all of that. If you're trying to run multiple versions, maybe your client supports multiple versions, then you need to make sure that you can support those changes in the schema between versions. When I started trying to build our own client, I was like, how do I test my client? And for reference, this was about a year ago. So there's a lot less tooling then, but it still hasn't come up to where I would expect it to be. So I wish that we had a conformance suite back then, and something that I could run in CI/CD and make sure we don't have any regressions, make sure all the differences in versions work, you know, like normal software engineering. So this is actually new to me. I didn't realize that there's a conformance test. I have been looking for this. I could not get it to come up in search results. I figured out this week that it exists. I was surprised because it has 50 stars on GitHub, whereas most of the clients have tens of thousands of stars. I thought this would be something that would, you know, show up and be well used. But the MCP debugger that we built before, we started building that before this came out, so that's why we currently have that. And in the time that I had to test it out for this talk, it seems to be pretty narrow in the scope it does, and there's some tests that only work for the client and don't check the other side on the server. So what should we do about that? We want to get the spec into a place where people can just pull a client off, know it works. We can see conformance tests. There's no thinking about, does this server SDK work? Does this client SDK work? So something is, I feel like we need to heavily promote this conformance repo more. It should be something that everybody should be running in CI/CD. It also needs to be extended more. I would like to see, I could see them putting things in from the new specs, but it feels like it's fairly lacking in what it currently supports and scenarios that people could run into that we need to make clear when they test if it's acceptable, if it passes. So another stat, 19% of all tools that we scanned had some issue with the input schema. So why does this happen? A lot of people use the provided frameworks or they use a third-party framework. And I learned that a lot of this was due to bugs or just not enforcement in the SDK itself. People can give null values when they shouldn't. Or ambiguous parameters, and that's something that we need to work with the third-party libraries on making sure that they are doing everything properly to help their users. I'm sure some of you have seen this. I'm sure all of you have seen this. API key usage in the spec. So API keys are not in the spec at all. It wasn't in the first spec. The first spec didn't have auth in it, but how are you going to connect to GitHub or Linear or some other service that you want to make an MCP server for if you can't use an API key or there's no auth? So, the easy solution is allow your server to take an API key and a header or throw it in the environment. Problem with API keys is it takes work on the user side. So if someone else builds a server, I can't just use it. I have to go get that API key, and maybe I'm at a company and I don't have access to go make my own API key. A lot of API keys also give full access. There's some apps that you can make them more granular, but they often just give you full permissions, and it's less secure. So in V2, we introduced, MCP introduced OAuth with GCR, a lot better usage. Users can just log in if they already have an account. It's more secure, but people still use API keys. So why are we still using API keys if we have a better alternative that's safer, that's easier for the user? And I've been thinking of it as a scale problem. So if I'm a company and I have my product, the lift to add OAuth to my app is pretty low comparatively to the effort that I'm using to build that app or product itself. But if I'm a developer and I'm making MCP servers for my personal projects or for some friends or for some coworkers to use, not an official company product, then this is a little overly complicated for what I want to do. If I just want something to read my emails, I don't really want to implement that. So if everyone has to implement OAuth, we're going to have issues with compliance. The thing is, though, very few people build servers and clients from scratch. Most people use a provided SDK. So why are we still failing so much? A lot of frameworks still make you do a lot of the work. So like I mentioned before, the origin header verification or the WW authenticate, some frameworks don't handle that for you. You have to do that yourself, even though it's very minimal code from your side and their side. But people forget. So the framework should take ownership of making sure that it's very difficult for the user to forget something like returning a header. This could be guided setups where it's a requirement when you make your server, or templates, or just a easier flow or interface where it's required, you need a host name or something. The user doesn't have to think about that. They just have to give it to you, and they can't forget it. So other solutions. What else can we do? These are a bit more aggressive. Registry gatekeeping. So I believe MCP is already starting to do something like this. They have their tiers. So making it so that if you're failing as badly as some of the servers that we've seen are failing, that shouldn't be something that is offered or allowed for users to use through like official lists. And client-side rejection. So thinking about clients as more of a browser, the way we treat browsers rather than a standalone piece of code. So if I don't have a certificate on my server, my browser lets me know that very clearly and puts roadblocks in the way for me until that client exists, or I have to forcefully get through that. Now, this is easier for MCP to support with things that it provides, but let's say we need Cursor to support that for this to work. It needs to be part of the spec. It can't just be maybe you can do this. If we really want to push everyone to be compliant, we need to enforce that. So overall, the goal is to lower barriers for users, non-coders, make developers' lives easier, and produce a standard that we know will work and we don't have to guess. And this has just been servers. I could make a whole another presentation on clients, but just as a scope, that's what I have so far. Thank you for coming. I still have some time to answer questions. You can also come to our booth or grab me after this, and feel free to check us out. And you can check out MCP Debugger and Toolbench. They're free. You don't no account required. You can just go look at them and use them. Any questions? Yeah.
Yeah. So I saw the talk by your colleague this morning, demoing a lot more of Arcade. I'm interested to know, like, the problems you're talking about here. Did you learn a lot of them, or did you find them through the process of building Arcade, or were these sort of foundational problems that led to your team building Arcade?
These were not issues that led to us building Arcade. These were issues that we found while we were building Arcade. So earlier on, we had our own protocol that we were using, and then MCP got really popular and became the way to go to support. And then a lot of this was finding those problems while getting that MCP implementation in.
Cool.
Besides the two tools that you mentioned, MCP Debugger, and obviously MCP Inspection, what other tools do you recommend to say, I checked for the boxes?
So far, I would say that's a hard question because we built the debugger because we needed more. Inspector works fine, but I couldn't find any other tools that were widely used that I felt gave me the clarity that I needed. So that's why we built MCP Debugger. Going forward, I would like to see the conformance test provided by MCP to be built out further, or someone else to build a client test. But the client test was definitely the hardest thing to find. I wasn't sure, how do I confirm that my client works? I just couldn't find anything that would help me with that when I was building this out.
The way you showed it, it's synonymous to how back in the day you would create your website. You had an A+ on you've seen that website, right? So is there a rubric out there that can say, okay, here are the things that need to be graded on?
Oh yeah, so for MCP Debugger, that is a very, I'm not sure what the lettering grade as much follows, but it'll give you an exact number of you fulfilled 50 out of 50 requirements. For Toolbench, we do have a rubric on there that shows you how we weight things, what kind of information we're using, how we collected that. So. Any other questions?
So
yep.
Part of your conclusion is that the three major frameworks essentially need to make some improvements, right? To improve the situation. Did you share the feedback with them? Did they listen? Did they respond? Are they making some improvements in the direction that you recommended to them?
I have not chatted with them yet, so.
Because then based on your slides, that would be the main course of action. Kind of guys see that's what they concluded. You need to improve.
Yeah.
Yeah.
Yeah, I think that's totally fair. Cool. Thank you all.